Systems, Aaron Fulkerson.
Back. So welcome back, everybody. We have an incredible lineup of speakers today. I don't know how we possibly did it to even exceed yesterday's incredible lineup of speakers. Our speakers include one of the most respected security leaders on the planet, the deputy CISO of Anthropic, a CIO who's running confidential in production on regulated and sensitive data. Also, we have the author, really, of the definitive distributed systems textbook, Yan Stoka, who also is responsible for engineering much of the AI infrastructure utilized today by everybody from frontier labs to enterprises. And then finally, we've got an incredible lineup for a keynote panel. So I want to give Ivan as much time as possible. Oh wait, I've got a clicker, hold on. There we go. Okay, well, let me just turn it over to Ivan.
Folks, good morning. It's great to be here. I am Ivan Krstic. I head security engineering and architecture at Apple. I wanted to thank the organizers especially for letting me do this 2.5-hour-long presentation, so get comfortable. No, but it will be about an hour in 30 minutes, so I will move very fast. Blink and you will miss it. All right. Yes, great. So what I want to do today is walk you through how we have thought about security and privacy of modern cloud AI and the threats that our users face and the steps that are required to address them. And then I'm going to discuss how those considerations shaped our private cloud compute design, first on Apple Silicon, and how we then just recently expanded it to Google Cloud while maintaining our security bar. So we're going to dive right in. To orient ourselves, you all know this, but with traditional cloud AI, a user's device will send the prompt to the cloud service. The service is effectively opaque to the user. After some processing, a model response is returned to the user's device. And the security properties here leave a lot to be desired. Any security and privacy guarantees are difficult to verify and enforce. It's difficult to provide runtime transparency to conclusively show what software was running or how it's being used. And finally, it's hard to enforce any kind of strong limits on privileged operator access. Now, researchers agree that Apple builds the most secure consumer mobile devices in the world. We keep data on device as much as possible with industry-leading defenses that are constantly scrutinized by security researchers. So it shouldn't surprise you that when we first started assessing cloud AI, we wanted a much stronger security model than what existed in the industry. And that model is to make cloud AI processing an extension of the security and privacy of your iPhone. We want to operate on behalf of the user and minimize trust in everybody else, including the cloud AI service itself. So let's take our standard cloud AI model and flesh it out so we can actually start thinking about the entire inference pipeline. First, we have to consider any front-end and middleware services that are handling the request. Then we have the inference pipeline itself, as well as the privileged operators that are able to access it, and its entire software supply chain. And finally, any observability, analytics, or data warehouse systems that might be storing data produced by the inference pipeline. All of this is managed by the service operator, and we need to consider their infrastructure decisions as well as attackers operating from inside or outside their network. The service then sits on top of the cloud service provider and their hardware supply chain. So essentially, every single part of this is an attack surface, creating a tremendous number of potential threats that can impact the user. To help formalize our thinking on securing these systems, we developed a simple coarse-grained framework that classifies cloud AI in 4 broad security levels. What we've discussed just now was level 0. Level 0 has a large, complex, and opaque software supply chain. It uses shared inference pipeline that concurrently operates on data from many users. It enables privileged access for the site operators for debugging, and any data retention and use policy is just that, a policy. There is no inspectable technical enforcement of how data is retained and used. So level 0 accepts operation with a substantial and very broad range of heterogeneous threats against user data. To move to level 1, we need an auditable, high-security, hermetic inference pipeline. Using a measured boot flow that covers all the runtime code, the systems within the inference pipeline need to be verified against a tamper-proof ledger, so we can audit both the code itself and any privileged or observability access to the system. And the inference architecture itself needs to be built with resilience in mind, ensuring that it doesn't retain user data beyond what's strictly permitted. At level 1, we get a much better picture in terms of the trusted components. Our users still have to trust the AI service front-end to route their requests to a secure pipeline, and they still have to trust the service provider, the service operator, the cloud service provider, and the hardware supply chain. But a well-designed level 1 cloud AI system can limit the risk from all of these other threats. But this still poses substantial risks to user privacy. An operator could covertly deploy modified software that implements different data retention practices than claimed publicly, or perform user-targeted substitution, where particular users are targeted with different software or hardware, or manipulate callouts to leak specific data to external services or tools like web search. So to move to level 2, we need to add verification of the cloud AI service and the underlying cloud provider. We do this first with verifiable transparency. Software images are published for inspection, the system attests to the software that it's running, and transparency log inclusion is enforced by the client software. But we also need non-targetability. Service access must be via anonymizing relays, and authentication must use anonymous tokens, ensuring the service operator cannot target specific users or content. And finally, we need call-out transparency, which is to say that calls outside of the inference trust boundary must be inspectable by the user. It's important to emphasize something about level 2, which is that we believe non-targetability is not optional. It's a critical component of this level. And that's because it raises the bar on attacks by ensuring that an attacker must compromise the entire system to get data of interest, rather than targeting just one node. So this places scalability limits on hardware attacks, forcing them to be implemented at scale, and it ensures the data leakage, for example, via side channels, doesn't provide data that is attributable to a specific user. If we can address all of these threats, we can minimize trust in the service operator as well as some of the trust in the cloud service provider. Last, to reach level 3, we have to defend against advanced adversaries. These adversaries are well-funded, may be state-sponsored, and they can carry out sophisticated attacks. And that includes side-channel attacks, where they can become co-resident with an otherwise hermetic workload and can then leverage side channels to extract user data, as well as hardware supply chain attacks, where they can compromise the root of trust via certificate misissuance. If we're able to meaningfully protect against all of these threats, we rise to level 3, what we call frontier security and privacy, which we can accomplish by providing side-channel resistance through limiting co-resident code and by providing hardware supply chain auditability and redundancy. So if we handle these threats, we can finish minimizing trust in both the cloud AI service front end, as well as the cloud service provider and their hardware supply chain. Now, even with all of these steps, we should still be clear about the risks that remain. All software will have bugs, and exploitation of those bugs has the potential to allow an attacker access to some user data. In addition, hardware defenses can raise the cost and detectability of an attack, but they can't prevent it outright. So level 3 systems have to be designed to minimize and recover both from complete fleet compromise for a short period of time due to software exploitation, as well as persistent partial compromise due to a hardware supply chain attack. And designing for that really requires thinking carefully about what data is present in the AI system and at what time. And finally, abuse monitoring and mitigation remains quite sophisticated and challenging with level 3 systems. So that's the framework for how we approach the problem. And now we can turn our attention to private cloud compute on Apple Silicon and how we ensured that it met all of these requirements. First, we'll build level 1, the world's most secure and private system for stateless AI inference. This starts with the PCC node itself, which is our custom Apple Silicon server. It leverages the foundations of iOS, as well as a set of custom cloud extensions designed with privacy in mind. And finally, we built our inference engine to provide stateless inference at scale. Now, the PCC node is the atomic unit of our trust boundary, and it's designed to ensure that personal data resides within the trust boundary and that it's not retained, other than the special case of the KV cache, which we'll talk about in a moment. Building this wasn't as simple as just running iOS on a server. In addition to the decades of investment that we have placed in iOS security, we also brought a range of new features and technologies to the system, and we'll cover a few of them. The first step in the lifecycle of a PCC node is the measured boot flow that takes us all the way to its hermetic runtime. We start with immutable code in the silicon as part of our SoC root boot chain, which measures and records all the code that can execute in the system until we finally seal it and prevent the loading of any additional code. Once the system is up, it's time to perform inference. We isolate all of our data processing to minimize and contain any potential compromise. All processing for us starts in CloudBoard, which handles and demultiplexes incoming connections and ensures that we can use the appropriate attestations to exchange keys. Then it hands off to isolated process per request instances that handle the actual decryption of the request, as well as the initial processing of the request data. That finally hands off to our inference engine, which is periodically recycled to minimize the amount of time that any data can stay resident in the system. Implementing an inference engine for a secure and private service presents some unique challenges. One of these comes in the form of prefix caching. On a traditional AI system, you would simply build a cache of previously presented prompts, but with stateless inference, we need to ensure that one request cannot influence another and the data isn't retained. So we separate system prompts from user data, and rather than letting a node discover shared prefixes automatically from traffic, we deliver a tree of system prefix data to our PCC nodes ahead of time to seed the initial set of cached KV content. Then, as a user makes a request, we maintain their state encrypted with a per-user key. And so this allows us to continue to process requests without having to recompute previous turns, but it also ensures that a user's data is cryptographically unavailable to us outside of a live request. And of course, we need to be able to operate all of this without any privileged runtime access. So we had to build specific filter mechanisms for metrics, logs, and crash reports, as well as custom diagnostic tools so that we can actually empower both our observability systems and our site reliability engineers to operate the service while ensuring we have multiple levels of review for all data that leaves the trust boundary. That just gets us to level 1. Now let's take it further and make the system non-targetable and verifiably transparent. Verifiable transparency starts with end-to-end attestation. The PCC node must present its attestation to the end user's device, which verifies that the software measurements which are present in a public append-only transparency log. Security researchers can use the virtual research environment toolset to access that same log and download the software corresponding to each release. And this allows the broader privacy and security community to verify our claims and look for bugs and flaws in our implementation. The attestations start from the hardware identity, which is rooted in our secure enclave. Every secure enclave has a unique identifier that is securely generated and fused into the silicon during manufacturing. From this, we're able to derive what we call the data center identity key, which is a permanent identity that's attached to that piece of silicon that we use throughout PCC. The secure enclave signs the full system attestation using that data center identity key. And this captures the full software stack. The boot register that covers the underlying operating system, a set of software sealed hashes that cover the application software running on top. And so those measurements, along with the rest of the necessary collateral, form an attestation bundle that a device can use to verify exactly what is running on the PCC node that it's talking to. Each attestation bundle corresponds with a specific release digest, and PCC infrastructure generates an inclusion proof that the release digest is present in the transparency log, which allows efficient validation by the end user's device. Now, we use transitive trust to allow us to perform load balancing just in time while also ensuring that we don't weaken any of our verification in the process. The way we do this is that the proxy node commits to a particular revision of the transparency log as its view of that log, from which it will perform all attestation validation. It includes that in its own attestation, which it provides to the client device. And so this way, the view of the log that is seen by the user is actually guaranteed to include all software that processes that user's request. This provides verifiable transparency, but we also need to ensure non-targetability. And so for this, we bring in two more components, an anonymous authentication scheme as well as a third-party privacy gateway. Our authentication process involves 4 steps. The first is to issue anonymous one-time tokens to the device using RSA blind signatures. The device redeems those tokens to issue inference requests, and along with the response, it also gets a cost token, which is essentially a receipt of the cost of that inference request. The device then aggregates these cost tokens anonymously, communicating through an oblivious HTTP relay to our cost aggregation service, which returns a range of cost denomination values that sum to the total that needs to be replenished. And then finally, when it comes time to fetch additional inference tokens, the user's device can include those anonymous cost denominations, which will replenish the user's quota. So this is a lot of work to ensure minimal data leakage. We cannot link the cost of any individual request to the replenishments that we will ultimately issue. In addition to the anonymous authentication, we also need to ensure that access to other services, such as world knowledge, cannot become a privacy leakage vector. And we do this through the request execution log. Anytime a PCC node wants to access an external service to fulfill a request, for example, accessing the world knowledge database, it includes the query terms of that request in a request execution log. And then our users can verify those terms by looking at the Apple Intelligence report on their own device, ensuring that the search terms were reasonable and valid. Of course, to make all of these steps useful, we need to pair them with tools that allow security and privacy researchers to verify the system. And that starts with our virtual research environment, which allows anyone to run the PCC inference software in a virtual machine right on their Mac. It also includes the supporting source code and documentation, just as you would expect. So with all of this, it's now time for level 3, protecting against advanced threats such as side channel and hardware supply chain attacks. For PCC on Apple Silicon, we have a naturally side channel resistant design. Our verifiable transparency covers the entire SoC. We have exploit isolation techniques that limit within SoC side channels, and we continue to follow the state-of-the-art of evolving research on network and power side channels to ensure that we've mitigated those attacks. We also need to consider how we secure our root of trust. Our goal is simple. Admitting bad PCC nodes to the fleet should require a severe multi-party breach. And we accomplish this by using a provisioning ceremony that evaluates a range of evidence about the hardware's authenticity and integrity. And that evidence then allows an independent auditor to review the process and ensure compliance. The ceremony we have puts each chassis through a sequence of validation gates. We start with manufacturing, confirming the node was genuinely built by Apple with a valid paper trail. Then we validate the physical chassis and its location. Next, we check the chassis is still sealed. Then we confirm the software is inspectable and the silicon is fused correctly. And finally, we validate the node identity. Only once a chassis clears every one of these gates do we issue it a certificate allowing it to join the PCC fleet. All right, let's take a breath. Hope you caught all of that. As you can imagine, it was a formidable challenge to expand this architecture to Google Cloud. And so next, I'd like to talk about how we accomplished that. The first and most important thing you have to know is that we were unwilling to lower the level of security or privacy at all during this expansion. But the principal challenge of the expansion is to deliver a secure system that can minimize trust both in hardware vendors and the cloud provider. So how do we approach level 1? For PCC on Google Cloud, we started with Google's attested container optimized OS, or ACOS, running in an Intel TDX CVM. This is a hardened image. It's designed for zero operator access, and it ensures only attested code runs. And this image is open source and auditable. Now, what's hard to guarantee here is full attestation coverage. In other words, that the system is truly hermetic and doesn't have a path to load arbitrary code. PCC on Apple Silicon used iOS's existing signing mechanisms, but the Linux ecosystem is quite diverse and presents a number of new challenges. So working in close collaboration with Google, we ensured that ACOS was designed to boot to a truly hermetic runtime. And this included ensuring that instance metadata pre-declares all containers and their hashes, a boot flow that loads only the specified container and measures it into a runtime register, a new eBPF Linux security module that restricts execution to only known binaries, and carefully monitoring any place where we had both a read-write file system and a shell. We also had to think carefully about how we protect attestation keys. On Apple Silicon, the Secure Enclave provides integrated key management and attestation capabilities, and this ensures one very important property, which is that attested keys cannot be exported or exfiltrated. But for PCC on Google Cloud, we collaborated with Google to build a key management confidential virtual machine. So this is an independent TDX CVM running on the same host in a separate isolation domain, ensuring that a compromise of the inference CVM would not allow exfiltrating keys. When it comes time to do inference on Google Cloud, we ported some of our key technologies to Linux. This included CloudBoard to provide attestation and request handling, as well as our techniques for auditing logs and metrics. We also adopted a number of Linux native technologies, and we ported the inference engine to run our Apple Foundation models. So with that baseline set, let's reach for level 2. When it comes time to route a request, we use the same transitive trust techniques as with PCC on Apple Silicon. But this time, our proxy validates the attestation of Google Cloud nodes. Expanding our security research program to cover this new hardware presents a number of unique challenges. The hardware is expensive, it's hard to access, yet it's necessary to verify transparency. Validating that the attestations match particular firmware requires reproducing golden measurements on live hardware, and encrypted firmware means that the hardware is needed to verify runtime behavior. And so to address these, we will be providing access to real hardware for qualified security researchers. Finally, let's push all the way to level 3. An observation we made is that confidential VMs are not on their own sufficient to protect against sophisticated attackers. The key challenge is side channel resistance. Confidential VMs leave data open to side channel attacks from the host. And this has been seen repeatedly in the academic literature, including TDX-Ray, which is able to recover a user's LLM prompt from a single trace. But one of our key insights from PCC on Apple Silicon is that most side channels become unreachable when there is no co-resident workload on the system to act as a launch point for attacks. Therefore, we have a hard requirement: attest the entire system, not just the confidential VM. So PCC on Google Cloud uses whole host attestation. The host is also running the same attested container optimized OS as the guest. The system boots directly to a single application CVM plus the key management CVM, and the system will reboot before loading any other CVM, just like the guest. The host runs only attested code and has no privileged operator access. Our boot flow leverages multiple roots of trust. We start with the Google Titan root of trust for the host boot, which records measurements of the BIOS, the host firmware, the host OS, and the hypervisor. And the contents of the guest workload and the key CVMs, as well as our application containers, are all covered by TDX. The last step prior to lockdown is to record the measurements of the confidential mode GPUs. And the measurements from each root of trust contribute to this whole host attestation. And this is a key point for us. These layered attestations also provide redundant roots of trust. Hardware supply chain resistance is another crucial property, and with PCC on Apple Silicon, we accomplish this through the use of an extra auditor. For PCC on Google Cloud, as we said in the beginning, it wasn't enough just to minimize our trust in the service provider, we must also minimize our trust in the hardware vendors. And so we believe a level 3 Cloud AI service should have multi-party control over the root of trust, in this case by using multiple vendors together. In our case, the multiple roots of trust include the Google Titan for the boot chain, as well as Intel TDX for the CPU. For the GPU, we rely on NVIDIA's root of trust alone because that component on its own doesn't have the ability to independently exfiltrate user data. Of course, the firmware measurements of all of these components are included in our transparency log, and just like the Google Cloud hardware identities, which ensures that attacks on the hardware supply chain can be detected. Ultimately, it just should not be this hard for a cloud AI service to operate at level 3. Most deployed systems today target at most level 1, with many unable to achieve it. Systems from large companies often have no transparency or partial transparency. Systems from smaller vendors often skip non-targetability, which we consider a hard requirement. And what's more, current confidential computing primitives on their own don't enable level 3, which puts a ceiling on what most commodity providers can offer for cloud AI. In fact, we've analyzed a number of cloud AI systems based on entirely the published security information, and we've tried to do that as a straightforward reading of the information they themselves publish, and this is our best current assessment as of this moment. We believe that PCC is the only system that meets level 3 today, and that no widely deployed system today meets level 2. This has to change. At Apple, we believe privacy is a fundamental human right. And we believe that the immense promise of AI will be fulfilled only if we build systems that are worthy of our users' highest trust. And this is why, since the very first version of PCC, we have been publishing tools and code and documentation, tremendously detailed technical documentation, hoping to inspire more work like this in the industry. The work ahead of us is difficult, but I hope that the people in this room will be part of the tide that lifts all boats, and that we will help deliver a more trustworthy AI future for all. Thank you for having me.
Thank you so much. Thank you. So I intentionally did a very, very brief introduction to Ivan because I knew he had an hour to fit in, and I wanted to afford him as much time as possible. So now that he ended in a very timely manner, let me just say a couple of things. First of all, I reached out to Ivan, I think a few months ago, and it was just absolute irrational boldness because Apple does not speak at non-Apple events. So Ivan being here and speaking at CC Summit is really unprecedented and speaks volumes about Apple's commitment to privacy by design and their commitment to privacy being an essential human right. When I spoke with Ivan on the phone, which my personal agent scraped the web and made some inferences about what his email might be, and I got lucky. He shared with me that his agentic system that reads his emails ordinarily filters out any cold outreach like that, but I used the right combinations of keywords involving confidential and privacy that he actually received the email and took a call with me. So I told him on the call that I was immensely grateful for his team's work in this category, and it was the announcement of Apple Private Cloud Computing that undoubtedly helped us secure our Series B funding, or at least at the valuation that we got anyway. So it set the standard for what we'll expect to see from every enterprise going forward. Because when you have the largest consumer platform on confidential AI powering privacy with verifiability for billions of iPhone users, it makes you ask the question, well, why doesn't my bank provide me some of these assurances, or my hospital network, or my healthcare network, or government agencies that are taking advantage of AI to optimize and create efficiencies? Why isn't my data being protected that's even arguably even more sensitive than what I'm talking to Siri about? So again, thank you so much, Apple and the Seer team, for all of your leadership here in this field. So I'd like to introduce another amazing human being. If I can, yeah, great. So coming up next is Jason Clinton. Jason is the deputy CISO at Anthropic. This organization is arguably at the center of the most consequential work around AI and security. And Jason has been at the vanguard of this, leading the way by example and speeches. He's been a regular at CC Summit, and he's genuinely just a great human being. So thank you so much for being here, Jason. Come on up.
Hey, is there a clicker? Yeah, there you go, thank you. I apologize in advance. I normally drink decaf, but somehow this morning I ended up with a quad shot of caffeinated beverage. So I might be ping-ponging around the stage quite a bit as I try and unwind a little bit of that pent-up energy. So it's great to be here, and thank you so much for your presentation, Yvonne. It's wonderful to see Apple leading the way on privacy, especially for user data. It's incredibly important and something that we think about a lot at Anthropic. But I'm going to be taking the provider perspective here and trying to give an update on where we are in securing frontier AI. Through that, that journey, you're going to hear a bit about some of the challenges and the threats that we're seeing across the ecosystem. So I'll be touching on that, and I'll touch on confidential computing contribution to the moment that we're living through right now as we try and figure out how we can preserve the defender advantage. So I'm going to make some bold claims. I'm going to try and predict the future at the risk of being wrong about the future. But I think it's important that we contemplate the next couple of years, because each of us in this room is on the defender side. And if we are building for AI that exists today, for the challenges that we think of today, we are going to be sorely disappointed and out of date by the time the future arrives. So with that, I want to inculcate you with this graph yet again. This is the third year in a row that I've been on this stage, not literally this stage, but at the Confidential Computing Summit, saying AI is going to get smarter. It will get smarter, and you must prepare for it. And if there is only one slide that you take away from today, it is this slide. This is a graph of all of the compute that has gone into training AI models since the perceptron in 1957. A year ago on the stage, I presented this graph and said it will keep getting smarter from my perspective at a frontier lab, and lo and behold, it has. And in the last year, since that update, we had the PRC using AI models to launch fully autonomous attacks, which I'll talk about in a second. And we've had the Mythos moment, which I'll also touch on as well. The thing to remember from that graph is that as models get smarter, they will be able to do long horizon tasks. They will be able to be better at cybersecurity, and increasingly there will be other threats from things like bio or other sort of agentic insider risk threats that we have to consider as we're thinking about defending. So in November, we disclosed the existence of an attack that had been launched by a PRC-affiliated entity. That entity used Anthropic's model to launch attacks against a number of institutions in Southeast Asia. They used jailbreaks and bypasses to compromise their systems. This was covered quite broadly in the press at the time. And then earlier that year, we had disclosed other examples of the models being used in offensive ways, both in open weights models on things sort of open, broad access platforms where abuse can be sometimes hard to find. So this pattern is now well entrenched in the threat ecosystem and the threat landscape. So when we talk about any kind of an attack now, one of the standard TTPs that we look for from threat actors is which models are they using, which platforms are they using to launch their attacks? Are they running on-prem models? Do we see MCP signatures in the attack path? This is incredible step change in the efficacy of these organizations. And one of the things that we've historically done to attribute the threat actor involved with any particular thing is, especially nation-state actors tend to work 9 to 5 jobs Monday through Friday in the geographic region where they operate. Now with autonomous agents, they can run 24/7, and increasingly it's becoming quite difficult to attribute. But we're seeing continued attacks, and we'll continue to disclose them as we find them. And so everyone in this room is aware of Mythos. I was in a room yesterday with a room full of executives from some big companies, and I think a lot of folks have gotten almost tired of hearing about Mythos. I think many of us have heard Mythos multiple times per day for the last 2 months, and many of us in this room have had our Q2 or Q3 plans completely blown up by the consequences of this disclosure and the model changes that are now being promulgated through Frontier Labs. There's so much to say about this, but I do think that one of the reasons that it's worth mentioning again that this is important, if it was not obvious from our communication on this, I need to stress it again. The Mythos moment, the cybersecurity capabilities of this model were an accident. We did not intend to create a cyber model. This was a model which is generally intelligent, however you define it, on certain benchmarks, and as a consequence of it simply attempting to get better at coding through reinforcement learning techniques, it became extremely good at cybersecurity. Some of the examples that have been used, there's examples of public disclosures from parties who are not us, including the UK AC, on attacking critical infrastructure simulation environments, to public blog disclosures from folks like Firefox and Chrome, and then partners across the Glasswing set of companies, which is approximately 200 companies now, on just how capable this model is at discovering cybersecurity vulnerabilities. To be clear, connect this to the graph that I showed at the beginning of the slide. It's been 3 months since we had this model come off of our production line. And I can tell you from inside of a Frontier lab, the models are going to get smarter. And if they're going to get smarter at cybersecurity as well. And so this is just the beginning of probably 2 or 3 more cranks of the capabilities on the cybersecurity landscape. And as we think about the consequences for the implications of a model accidentally discovering cybersecurity capability, we must price in that every model on the planet will eventually have this capability. And so the question becomes, when? I'll talk about that in a second. But before we get there, I want to strike a note of optimism. This is a bold claim, and I realize that often when you're speaking from a Frontier lab, people don't necessarily think that we are being completely honest with regard to like hype and the sort of the way that we speak about the future. But it is so important that we plan for this that it is worth saying again. Everything that we're saying and everything that we're doing in public is an attempt to prepare everyone for what's coming. So why am I claiming that the permanent defender advantage is coming? Imagine that you're a company in Glasswing right now. You have access to advanced cyber capabilities, and you're looking at the possibility that in a few months, maybe a year, there will be this level of cyber capability in every open weights model on the planet. So you're asking yourself, okay, in 2027, I'm going to release a product, let's say product X, whatever that is. And within hours of me releasing that product, some teenager using an open weights model, living in their mom's basement, say, may be able to find a remote code execution vulnerability in the software that I literally just put out the door minutes ago. And in an hour or two, that kind of vulnerability can be discovered by an open weights model. I cannot have my launch day be ruined by that kind of discovery. I cannot have a world where I ship security bugs and someone else finds them immediately. That is not going to inspire trust. That is not going to make my customers happy. It's going to make me have a very bad day on my launch. So, therefore, I will put these advanced capabilities in every part of my software release cycle. Everything in the SDLC, from the CI pipeline to the CD environment to our automated pen testing that we run against our staging environment, whatever it is, we are going to put advanced models in there. And it might be at first that it's quite expensive and it is latency sensitive, but the cost of models go down. Open weights models are an example of this, right? We will see the proliferation of this capability going across the entire ecosystem. And while, yes, it is today the case that Mythos class models are the models capable of doing this, and they are very expensive, the thing that AI labs do, what we do as companies, is we find ways to put more intelligence in less neurons, to run more intelligence on less hardware. So if you compare today, for example, Haiku 4.5 to the intelligence of GPT-4 from 3 years ago on the same benchmarks, Haiku 4.5, as dumb as it is, and it's a very cute and adorable Claude, it is capable of doing things far in advance of what GPT-4 was capable of doing 3 years ago. And because of this scaling laws of implication of the cost, it will be the case that literally every software company within, let's say, 2 or 3 years will have cheap, ubiquitous, cyber-capable models running in every part of their CI and CD pipeline. We will not ship security bugs anymore. Now, I know this is a bold claim, and some of you in the audience are probably thinking, what about the halting problem? This seems like a claim that's out of alignment with what I know to be true about cybersecurity. The thing is, software can only be wrong in so many ways that are also useful for an attacker. And that is an advantage that we have the opportunity to take advantage of in these, these techniques for securing the pipeline. So how much time do we actually have? This is a graph that Claude and I, using Mythos, made in the last couple of days. The one caveat to this graph that I want to make right before I say what I'm about to say is that GLM 5.2 just came out, and I have not been able to find any reliable source for cyber benchmarks. For some strange reason, they dropped all of their cyber claims from their model card for the GLM 5.2 release. So I don't know what's going on there, but with a small caveat to that, Claude is concluding that there's approximately a 12-month difference between open weights models and proprietary models. I actually think that's too long. So my best guess, based on all the intel that I have, what I can see inside of a frontier lab, what we know about especially Chinese lab advances and model capabilities, is that we approximately have 7 to 10 months from now. 7 to 10 months from now before an open weights model has advanced cyber capabilities of the class that I'm referring to here. So that means we as defenders in this room have an opportunity to harden our systems before that 15-year-old example that I gave earlier. And if we can do that, if we can use this lead to succeed at defending and hardening our systems, we will not have a vulnerabilities, as some people have said. Yes, there will be many vulnerabilities. Yes, we will have to patch a lot of them, but we have a lot to do. And so what does that look like? What does that 7 to 10 month time look like? A couple of things. The week that we made the Mythos announcement, that was a very long week. I think I worked like 100 hours, not a lot of sleep. But we did manage to put out sort of an emergency blog post to say, like, if you're a CISO and you're reading this, please do these things to prepare yourself for what's coming. I'm going to take 3 things from that briefly and touch on them, and I'll touch on confidential computing's contribution to the landscape here. So the first is that we must actually, for real today, take seriously what we've been saying for more than a decade on the defender side. Zero trust matters. Zero trust networking became a bit of a marketing term, and a lot of folks started ignoring it because it seemed to be completely overloaded with specious claims. But if you just go back and look at the 2015-ish Google Beyond Corp paper and think to yourself as you're looking at your defensive playbook, we have to be in a world where every network connection inside of our corporate network is coming from a trusted device that matches the device in our inventory, has hardware root of trust in the way that we make network connections. Many of the technologies that underpin that claim are like very part of the TCB for making confidential computing work. And so there's like a huge synergy between making sure that we have zero trust networking. There's many products in this space that you can use from startups that help you achieve this, but we have to do this now. This is not optional anymore. They will get in, the bad guys will get in, and they will be using AI on the attack path. And so we must design for a world where there is no opportunity for an attacker to leap from one breached device to another. The second thing, as models get more intelligent, the one place in your security program where you can take the most obvious benefits of intelligence increasing is to use the models on your detection and response program. So if you are hunting for intruders and you're using AI models to drive your SOC, when there's like 60 different startups doing fully autonomous SOC at this point, including all of the incumbents, folks like Palo Alto and CrowdStrike and Arctic Wolf and others. You have an opportunity to benefit from the intelligence of models getting smarter at the same time the attackers are. So if you invest in AI on the defensive side, you can find the bad guys and stop them before anybody else does. And then obviously we have to do something about vulnerability remediation. So vulnerability remediation in this case may mean fully autonomous upgrades. It may mean something as simple as running a traditional, a high-end crit, vulnerability remediation program with SLAs. However you do it, there has to be some solution. There's of course lots of options in this space to reduce the total surface, and if we're actually really facing a tsunami of new vulnerabilities, then perhaps most of your SLAs will go out the window and you will be quite behind the 8 ball on this. At Anthropic, we're using AI to remediate these as you'd expect, but you don't have to necessarily adopt AI to solve this, you just have to have a plan. Okay, so how does this connect to confidential computing? So in the last 2 years on this stage, I was here saying, hey, it's possible if we do the right things to invest in the right sets of technology to make it possible for protecting model weights as we approach AGI. And it is still true today that if we want to preserve the defender advantage, we have to be in a world where we don't leak these incredible capabilities to adversaries. We don't have a world where we lose the 7 to 10 month lead. So it's not just about not leaking, it's also about enabling defenders. So I know that many in this audience are quite frustrated that they have not been able to access Mythos. I can't say any much more about that for obvious reasons and in this forum, but it is the case that we will get to the point where there is ubiquitous defender access to these advanced cyber capabilities, whether it's through KYC type programs or other programs where we understand who the defenders are and that the good guys are using it for good. And to do this, we need to be able to distribute the model in ubiquitous geographic locations against customers across all parts of the economy, both in the United States and in allied nations. And to do that, we have to, as a frontier lab, whether you're Anthropic or OpenAI or Google, have confidence that as we're doing those deployments, as we're making and scaling up data centers all over the planet, that we do not leak the intellectual property. I cannot tell you how fast and how incredibly arduous teams are working to get deployments out as fast as possible. But confidential computing is now a critical part of the story here. If we can bring a data center online when we know nothing about the people who run it, and we know nothing about the HVAC system or whatever the concerns are, but we know that we have a TCB and we have confidential computing, we have an opportunity to deploy models in places where we would not have previously been able to do. So I'm extremely optimistic. Every chip provider that matters today has said confidential computing is a priority for us. Incredible advances from folks like Apple on PCC have driven demand for effort in this space. We've seen huge investments in the software stack to make sure that it's possible for us to achieve this from companies like Opaque. So much is going on across the ecosystem. There seems to finally be universal agreement that this is an important part of both the user privacy and the intellectual property concerns of all of the players in the ecosystem. And so there may be a path for us to achieve AGI with all of the puzzle pieces in place to secure these models against attackers. As I said earlier, we can only win if we make it possible for defenders to get access to the capabilities that I'm talking about, the people in this room, to actually secure their software. And doing that is only possible through the confidential computing contributions. And then finally, as we think about what every bit of deployment at scale looks like, it's not just chip makers, it's not just data center providers, it's not just frontier labs. Increasingly, the regulatory environment is pointing to confidential computing as part of the solution, where we understand that from an auditing, from a control perspective, from a governmental concern perspective, that as we talk through some of the worst possible scenarios that we might plan for from a national security perspective, confidential computing is part of the answer. It's part of the solution to those problems. And with that, I will end, and thank you so much for listening. Thank you for coming.
Thank you, Jason. Okay, great. Our next speaker, Brittany Kaiser, is the CEO of Alpha Compute. She's also a globally recognized leader in data rights, AI governance, and digital privacy. Many of you probably already know of Brittany by her reputation as the whistleblower in the Cambridge Analytica scandal. She's become one of the leading voices in modern privacy movement and is the author of international bestseller Targeted, and was featured in the Netflix documentary The Great Hack, which I keep hearing people talk about being an excellent documentary. So let me welcome on stage Brittany. Thank you so much for being here.
Thanks for having me. Good morning, everyone, and thank you for being here with me today. It's a pleasure to be at my first Confidential Computing Summit. I couldn't be more excited to be here. So to introduce myself, my name's Brittany Kaiser. I'm the CEO of Alpha Compute, NASDAQ ALP. We are an AI infrastructure company that is focused on making confidential computing available to all. And my talk today, I'm going to address what I believe are some of the most important topics around data protection, data ownership, and our ability to really have digital sovereignty by making sure that we can ensure privacy all the way down to the hardware level, and why the stack needs to change before the rules on digital sovereignty can. So a little bit more about me. I didn't start my career as a technologist. I started my career as a human rights lawyer. So I came to the technology space from a completely different angle, which is how can we use technology in order to make the world a better place? How can we use tech in order to improve people's lives? And I started doing that for organizations like the United Nations, for Amnesty International, and on political campaigns for people that I believed were going to take office and improve the lives of their constituents. Now, as I got deeper into the technology space, and especially on the human rights side, I realized that just using data-driven systems, like some of the first data-driven political targeting platforms that I built while I was on the Obama campaign, that eventually there would be much more complex systems that I needed to start to understand. I was writing my PhD on something called preventive diplomacy and early warning systems. So I was looking at what types of real-time data were governments, militaries, and international organizations able to collect and model in real time in order to predict crisis before it happens. So you could prevent things like war and drought and save lives before any of these things actually happen, because you would see them coming. And I realized I definitely did not know enough about data science from a legal perspective. I really needed to know about it from a technical perspective in order to finish my doctoral work. So I joined then quite a little startup, which is now quite an infamous former company called Cambridge Analytica, as a part-time consultant in order to learn enough about data science to finish my doctoral thesis. But in my over 4 years at that company, I learned a lot more about data than I bargained for. I worked in over 50 different countries around the world, serving governments, militaries, political parties, and companies, building out what was really early AI infrastructure. We had built out data centers and physical architecture, and then build bespoke models for our clients so that they could use those both internally and externally for targeted campaigns, whether from the government or political or military side, and companies, data-driven advertising as well. But because I was a human rights lawyer, not a technologist, I started to see red flags in the way that the global data industry functions, which it seemed like billions of people around the world were having all of their data collected, bought, sold, traded, and used without their explicit consent for purposes that they would probably never consent to if they actually knew what was going on. And it started to seem to me that the way that technology functions was not compatible with human rights. So eventually, I left Cambridge Analytica as a whistleblower and have spent the past 8 years in government investigations, lawsuits against big tech companies, and creating both legislation, regulatory precedent, and the first case law on data ownership as a property right and your ability to own your data from the time you create it and have consent and permission structures and tracking and traceability rights around custodianship and fiduciary responsibility of people who are using data sets. And then your ability to actually own revenue coming out of your data. So I've helped write and pass over 60 different laws on these topics in the United States. I sit on multiple US congressional committees on fintech, digital innovation, technology, and ethics. And I have done both expert witness testimony as well as testifying on behalf or against technology bills around the world. And I do a lot of trainings for governments, whether parliamentary briefings or congressional briefings, and usually training at Fortune 2000 boards on these topics. So it's been a long journey over the past 8 years to where I can actually be in a room full of people that agree with me that everyone should own their data and have fully encrypted data workloads. It's really a pleasure to be amongst everybody in this room, because what I learned while I was at Cambridge was that the world's most valuable asset is our data. The personal data that we produce, our intellectual property, our copyrights, our patentable information, if you're a government, classified information, all of your intelligence and your content and your value that you produce every day is quantified in these ones and zeros. And it's the reason why most of the world's most valuable companies are companies that have been collecting people's data for most of the time that they've been around. And so, how did we get to a place where data is the world's most valuable asset, yet most of us as individuals haven't really had too many rights to the data that we produce. We as the producers of the world's most valuable asset class have not really had the ability to own that from a legal perspective, a regulatory perspective, and from a technological perspective. The growth of confidential computing now is the first time that this is really going to be possible. And it's still so niche. The people in this room are all of the thought leaders in this space. And even if you've been working on this for decades, still 99% of the world has never heard of this. Probably closer to 100% of the world has never heard of this. And we got here because technology is inherently extractive. It is meant to take as much data from you all of the time without your explicit knowledge. Terms and conditions, which, has anyone in here ever read terms and conditions of apps that they use? Anybody? Bueller? Yeah, exactly. Nobody does. But they're written in 40, 50, 60 pages of legalese, which in law school they tell you that means that's how you trick people to not read the thing. It's designed that way so that you don't read it and you don't know what you're giving away, which it's not exactly very ethical. And with my work with the FTC, we've said that's really kind of against consumer protection standards at this point as well. So now you've probably seen that more terms and conditions are bullet points. There's more toggling where you can clearly see in 1st to 3rd grade reading level what you're agreeing to and turn it off. That's, I've been working a lot on that over the past decade, and it's getting there, but it's not the be-all, end-all solution. So how are we unprotected? I would say a decade ago, it was really that, our data could be purchased and licensed and matched from companies like Experian and Infogroup and Axiom, and then you could go and match that to your digital life for another, couple billion data points. But in the age of AI, it's completely different. You are giving up more than just your commercial and behavioral data sets. You are giving up everything, your thoughts, your fears, your emotions, your mental health, everything you're producing for your company, your ability to actually be an entrepreneur and have a patent that stands up in court, and you're giving that away to platforms that own everything that you're giving to them, and it's no longer yours. So what are we really trying to achieve here at this conference? It's to create trust. Trust, in the encryption industry, we really say, don't trust verify. We're not trying to build trustworthy systems. We're trying to build trustless systems so that you don't have to trust who you're interacting with or sharing data with. You can mathematically prove that your data is yours and it's not being shared non-consensually with other parties. So in the age of AI, I really believe that trust is the ultimate currency, and being able to build trustless systems is the most important thing that we could be doing. So what do I mean by digital trust? Digital trust is, firstly, transparency. What data am I sharing and where is it going? And consent mechanisms. Do I consent for my data to be shared with certain parties? Where is it going to? Who is going to get access to it? Can I revoke that access? Can I say no? And then accountability of where that data is going to and how it's going to be used. And if there is a data breach, do I have any rights? Do I have any legal recourse? The first case law that I won at the Supreme Court, I won the first case against Equifax for the data breach, where they had not updated their systems over 2,000 times and missed hundreds of patches. The lawyer that I worked with, who also structured the Taylor Swift v. Spotify case, said that it was like leaving the lights on in your house with the doors open and music playing and expecting no one to come inside. We won at the Supreme Court in the state of Minnesota for property damage. That was the first case won against Equifax that made the whole national decision. And that meant that, in Supreme Court case law, we now own our data as our property because we experienced property damage for that data breach. So accountability is quite important, but that's from my legal point of view. What I really believe most strongly in is data ownership. So our rights to own our data like a property. So if you think about the Airbnb model, if someone wants to use your house, which is your property, they tell you who they are, how long they want to use it for, how long they're going to be there, how much they're going to pay you, and you get paid before you hand away the keys. And if they mess up your property, you have legal recourse and you get paid in order to fix it. That's what data ownership means. You own your data as your intangible personal property, which we passed the first law in the state of Wyoming in 2018 that gave you those rights. And more increasingly, digital trust is also sustainability. So how can we own our own compute power, especially in the United States of America, where we're currently experiencing a big pushback on being able to build our own data centers sustainably, and what that means for the environment, for local communities. So a little bit more about Alpha Compute, the company that I co-founded last year. I think I've got about 20 of my colleagues in the audience, if you guys want to put your hands up. Yeah, thank you guys for being here. So we are a full stack vertical integration company focused on making confidential computing available to the entire world. But we are focused more at the bottom of the stack. Energy rights, mineral rights, semiconductors, storage, batteries, converters, grid connections, real estate, so the land and the data centers, and then hardware. So GPUs, RAM storage, networking, racks, liquid cooling equipment, things like that. And then we partner on the middleware and software side, where we can integrate with any software product that ensures confidential computing. It just depends what our clients want, from government, military, enterprise, and individual developers. We are happy to use any software and middleware stack on top of our hardware in our data centers on our land. So a lot of people here that I've met yesterday, we are very excited to partner with you all in order to have end client delivery for confidential computing. Our divisions. So firstly, Alpha Sovereign, that is focused on our government and military work and ensuring data sovereignty for national security. Alpha Capital, where we have created various financial products in order to get exposure to compute power as an asset class, which has widely been considered over the past many months one of the most important new asset classes on the planet. So that's everything from GPU compute funds to futures and other types of products that can allow people to invest into this space. Alpha Studios, where we create educational and awareness content on data protection, privacy, data ownership, and digital sovereignty, how important it is and how you can access it. And Alpha Games, where we have hundreds of millions of users that can try out our confidential computing products in gamified ways so that we can improve them and create the best products. We have incredible leaders working with us from many different verticals who have been very successful in technology, fund management, and creation of financial products. And something that I'm very excited to announce today. Firstly, I would like to ask quickly, who in this room has seen news over the past month or targeted information on social media complaining about AI data centers being built in America? Yeah, a lot more than people who have read terms and conditions. Okay. So I don't know how many people here noticed that when President Trump and the CEOs of most of our biggest AI companies in America went abroad to China and were not paying attention and away from their desks, all of a sudden there was a sweep across America, crazy disinformation campaigns about how AI data centers are going to destroy our country. And we should create a moratorium and build no more AI data centers in America. So interesting, huh? I've seen a lot of cyber warfare campaigns, but this is one of the most special ones I've seen in a long time. Now all of a sudden there are people saying not in my backyard to data centers. Now there are people that seem to care about water pollution. I started my career as an environmental activist. I've never seen so many people care about birds and water in my entire life. This is so interesting. All of a sudden, because people are mad at AI and foreign adversaries decided to take advantage of that, there are now people all over this country that are very mad that we want to build data centers and own our own compute power for national security purposes. So if we don't build any more data centers in the United States, where do we have to send our data to process AI? Certainly not America, right? Because we don't have enough data centers for our own compute power. So today I'm launching with a number of amazing commercial partners and support from our government, the Right to Compute campaign. You might have noticed last month that there were 300 bills dropped across states in the US in order to create a data center moratorium. Many of those have actually been passed, and even data centers that are in the middle of being built, where computers were even being shipped there, are now paused because local people have said, we don't want any more AI in our community. We're against this. I think that is probably one of the most dangerous things that could possibly be happening in our country, and our right to be energy independent, build our own data centers and process our own AI locally within our borders and not send our data abroad is one of the most important things that we could come together on. So we will be dropping right to compute bills to compete with those data center moratorium bills in every single state across the US, and also working at the federal level in order to make sure that Americans understand the importance of processing our data within our borders, and having data security is national security in the end. So that campaign launches today, and anyone that is interested in getting involved, please go to right2compute with the number 2.com. You can also scan this QR code in order to partner on this campaign, because I think everybody here would really love to be able to continue to grow their businesses. And if we are not able to run our own stacks within this country, that is going to be a lot harder. So we would really love all partners that are interested in co-authoring bills, co-sponsoring bills, showing up and testifying in their local Congress. That would be amazing. I think most people here can agree that we would love to be growing our businesses in the United States. Of course, we also have data centers abroad, and we're super happy to work with clients around the world in building data centers abroad as well. But in the United States, this is the first time I've ever seen an attack on our entire industry. And especially on the confidential computing side, if we really want all Americans, American companies, and our government to own our data, then that needs to be processed here. So we very much welcome partners. Again, can everyone from Alpha Compute raise their hands so that people here can come find us if they want to get involved with that? There's a lot of us. So we would really love that, and we're grateful for anyone that wants to join in. So this is how you can contact us. We're alphacompute.ai. We are really excited to work with everyone in this room in delivering your confidential computing stack to our end clients We have clients all over the country, all over the world in the public and private sector that are very excited to get access to fully encrypted workloads. Some of it is an education process. Some people are reaching out to us specifically because they want this. And we're completely, as I said, software and middleware agnostic. So we're really excited to work with everybody here to put your stacks on our GPUs and ensure that everyone that we are working with has the true ability to own their data and have digital sovereignty. So thank you again. I'm Brittany Kaiser, CEO of Alpha Compute, and I look forward to meeting you all.
Thank you, Brittany. Thanks so much for being here. Okay, everyone, thank you so much, and especially to our incredible keynote speakers this morning. I'd like for all of you to go out, eat, drink, be merry, be social, forge new relationships to build great new systems, and be back in here at 10:30. That is 10:30. Thank you so much. All right, welcome back, everybody. And for those of you out there in the hallway or talking in the back, I encourage you to come take a seat or just pay attention. And in fact, would you all close the doors in the back too? Thank you so much. All right, so our next speaker, Manik Dum, is the Senior Vice President and CIO at Encore Capital Group. So Encore is a publicly traded company on NASDAQ. They're the world's largest debt purchaser. So they work with every credit issuer on the planet, and they help individuals achieve financial stability, but they're also working with incredibly sensitive data as part of their daily operations. So Manik is going to share what it actually looks like to evaluate, adopt, and govern confidential systems inside of a large enterprise that's highly regulated and working with highly sensitive and confidential data. So please welcome Manik Dum.
All right. Well, thank you, Aaron. And I have to say, super impressed with the speakers this morning. So I have a very different lens that I'm going to talk to you about. So again, my name is Manik Dum. I'm the CIO at Encore Capital Group. We are a global company. So the Encore Capital is our holding company, but we go by Midland Credit Management. So hopefully none of you are my customer here in the United States, but in the EU and UK, we go by Cabot. So what I would say is here's Encore by the numbers. So we are a very large company. We are the largest debt purchaser. It's interesting, at the leadership table, we often say that our account managers have the hardest job because they literally have to say to everybody who they are on a call with that they work for a debt collection company. And when I get asked who I work for, I often say I work for a financial services company, because explaining why I work for a debt collection company is not always fun, but I actually have a captive audience. So I work for a debt collection company because I believe that consumers need to get back into the cycle of being able to get a house or a car or whatever else. They cannot do that if they have debt. People acquire debt. They have hardships that happen in their life. So we are a very large debt collection company, 2.6 billion in collections annually. We are in 8 different countries, and we've been in business a very long time. So what I would say is that the consumers are at the heart of everything we do. We purchase 4 million accounts a year, 4 million accounts. That comes with about 25 to 50 documents. And I purchase all of those accounts. And you and I have something in common, because I care about my brand. And that sounds weird. And if you look us up on Google, our brand has a pretty good rating. And I care about my brand like you care about your brand. I care about my brand because the issuers, the banks that I'm buying debt from, care about their brand, and I'm representing their brand. So we are very tied. And so everything I do has to make sure that our consumer is protected. Our consumer's at the heart of everything. Our account managers are not paid if they don't have a good Google review from that from that person that they've collected debt from. So that's odd, I know, but that's what we do, because we care about our brand just like you do. And so it's important that we are in this discussion together, because I'm actually looking at us from a CIO perspective. I'm looking at you for help, because I have a lot to do for these consumers. So what I would say is, oh, this didn't move ahead. What we need right now. So I've been in financial services my entire career. Some might say I'm crazy. I worked at Bank of America during the mortgage crisis. I owned the default servicing systems on those platforms at that time. The platforms didn't actually exist. There was no such thing, because default servicing at the time for a mortgage was done on spreadsheets. And then all of a sudden I went from having 20 employees to 500 employees in 6 months. We hired 15,000 new people at Bank of America to service all of those accounts. It exploded. You can't even imagine putting 15,000 new users on one platform that was not built for that at all. And there was nothing there. But I'm using the transferable skills now that I built then, because at that time, I met with every regulator on the planet. The OCC, the DOJ, the newly formed CFPB came in around 2012, 2013. We were having to meet with those regulators. They were throwing regulation at us so fast. We were in a penalty box very often, because there was just a lot of new regulation that was coming in. And so I'm using all of that right now as a reusable knowledge, because I feel a little bit like that right now with the age of AI that we're doing. So the mortgage crisis upended that industry. It really did. And so now here we are again, and where our industry is being upended, but not because of a mortgage crisis, but because of what's happening with AI. So that's what we need to get right. We need to actually get right. Everything that we do together for our consumer needs to be buttoned tight. And it's not yet, as we know. So what it means to be a CIO right now. So most financial institutions are being disciplined adopters. We're not fast, we're not jumping into AI, we're being very disciplined about it, because we've suffered what it's like through the financial crisis, what it's like to have regulation come at us, but we also know what it's like for a consumer. So we're trying to be very disciplined adopters, and we have a lot of angst. CIOs, we have a lot of angst, and even today, I'm feeling a little bit better. But there's still a lot to do. And so this feels a little bit like the perfect storm for me. And it feels a little bit, it feels a little bit like the financial crisis, but it feels very, very different as well. So what I would say is there's kind of three things I think about when I'm thinking about what's going on right now. So I need to unlock the value of data. Right, and Brittany talked about data. The data is yours, but I need to unlock the value of that data, but I have to prove that that data has never been exposed. I'm always being asked that. Our environments were not designed for that. Our environments today are not designed for that. And our regulators do not understand. The regulators do not understand. If you spend any time with regulators, we're going to talk a little bit about those. So that's really what I want to talk about today. So the speed of the frontier models. So thank you very much for the talk that we had related to Mythos. So we definitely see that there is a bunch of software vendors that are participating in Glasswing and appreciate all of that, but the volume feels like an avalanche. The volume feels like an avalanche. And I have to say, I'm in the servicing industry. I'm not in the software industry. So my developers perhaps didn't really do a lot of the good secure coding practices that they should have in the past. And now we're all of a sudden quickly looking at how to resolve that. And I'm not the only CIO in the world that actually are now hiring people. It feels a little bit like Y2K. I'm hiring people to come in and solve a bunch of the code that we've created because we didn't do secure coding. We didn't. That's not a really good disciplined. We did some. I'm not going to say we didn't do any, but that's not a really good discipline that we had. And so the capacity is not there. So I have to run a business, right? We're a large company. We're trying to transform the way we do, and we're using AI. We're applying AI to all of that. But we're also then trying to balance all of this other stuff that we have to do with all the vulnerabilities that we're seeing. So we just don't have the capacity for all of that. And we're looking at all of you actually to help us. So then the other thing is these agents. So the agents are breaking the data boundary. Here's what I worry about. Back in the day with the developers, they used to actually code, remember they used to hard code user IDs and passwords, or they used to hard code where they're going to get the data source from and then where they're going to store it. So we don't do that anymore in the development team. But agents are my business users. I have agents running in my organization that my business have created. I don't know that they haven't coded. They haven't put their user ID and password in there. I don't know that. I don't know that they're not. I know that they don't store PII data on their hard drive anymore because I wipe that out every day if they do. But what I don't know is, are they actually putting into their prompt, into their agent, to go get data from a source that I don't want them to go get it from? And then are they storing it somewhere that I don't know where they're storing it? Like, what the heck is happening with all of that? I don't have transparency with these agents. And so actually the agents things that scare me the most, because it is actually putting the hands of software development into, and Yes, that can be a good thing, but these are not technologists that we're dealing with. So I'm super worried that all of a sudden I call them rogue IT. I know we're supposed to call them shadow IT. I call them rogue IT. I'm afraid that these people are just going out and coding prompts that have things that unsophisticated things, and I cannot see it. I cannot figure out how to see it yet. I've talked to lots of companies. I've had Microsoft come and chat with me. I've had AWS come talk to me. I've had Zscaler, all of them. So we're talking to so many companies, but I just can't figure out how to do that well yet. So managing agents is like a huge fear of us CIOs. So I know there's a good thing, and I certainly know that in the hands of my developers, I trust them. They've been educated, but I don't trust them in the hands of my business partners. But they have it already. And so that's a big fear of mine. And then regulation. I'm so glad Brittany talked to you about that today. We have a government affairs organization in our organization, and what they do is they monitor what regulation is being proposed that might impact the debt collection industry, right? So it is important because people are uninformed. They think of the old, Guido, whatever, mafia stuff. That's not who we are. And so what we have to be very careful of is when legislation is being proposed, that it doesn't actually impact negatively the consumer who wants to get back into their financial wellness. They want to be able to go borrow again. They want to buy a house. Our consumers are 35 to 45. That hasn't changed in 20 years. Why hasn't that changed? It's because 20-year-olds get taught to use credit cards, and then all of a sudden, when they get into their 30s, they want to buy a house. So I have to fix that. So I'm always constantly involved in that. Now I've actually asked my government affairs team to broaden their scope. They're widening their net. They're looking at what the bills are for AI. So just to give you context, in 2023, 191 bills were proposed. That's state and federal. In 2024, 635 bills were proposed. In 2025, 1,208 bills were proposed related to AI. So far this year, 1,600. 1,600 bills are being proposed. And when those bills are proposed, if you think of the Colorado bill, I don't know if you're familiar with SB 189, the Colorado bill had words in there that said that a consumer was allowed to tell you to not use their data in AI. What? How do you do that? That's impossible. And the governor signed the bill, and they knew it was impossible, but the governor also said, we're not going to instate that bill yet, we're going to hold it. So it was supposed to go live in June. They've now proposed that it's January 2027, and they're changing the language with amendments. But the reality is all the other states are looking at that. California is great on doing those types of things. So California is looking at that bill saying, hey, that sounds like a good one for us. We should try that. I need all of you at the table with me when we're talking to these legislators. They have to understand the implications to the bills that they're creating, because they're not possible for us to implement. They're actually hurting their consumer, and they're hurting our customer, our businesses. So we have to be very, very careful about the bills. And so I think that Brittany mentioned it, and we actually all have to be talking to legislators about these bills. The EU Act, of course, is another one that we talked about today. So definitely that one is really big for all of us. But I'm very worried about the ones that are being introduced in the United States. So we have a strong government affairs. I hope you all have a strong government affairs group, because we're definitely looking at that. So what that looks like for me. So we have old methods, oldish methods. We've been modernizing, but we are not a software development company. I tell my team that all the time. We're not a software development company. I'm buying software, I'm integrating it, I'm making it work in my environment so that we can service our consumer. But that, at the heart of my company, that's not what we do. We don't develop software. That's what all of you are doing. So these AIs running are causing a lot of pain for us. So I really need your help in understanding what's inside those agents. I need your help with the legislation that's being proposed, right? Because we need to keep our data encrypted. So I'm so happy to hear about the software solutions and the hardware solutions that you guys are proposing, because we absolutely have to do it there. And that's actually why we're working with Opaque. And then only authorized models. So like, how do I make sure that only authorized agents and models are going after that data? Because I do have a lot of business partners that love to do that kind of stuff. And then also this hardware signed audit log, love that. So we're looking really for all of that. And then because the capacity in my own team, we're not built for that. We don't have the capacity for that. We're actually depending on all of our software vendors for that. So that's what it looks like for me. So really at the heart of it all is our consumer data is non-negotiable. It's non-negotiable. And I know that might sound weird coming from a debt purchaser, but it really is non-negotiable. My reputation stands on the consumer data being protected, and the issuers who I'm interacting with, so all of the large banks, all of the credit card companies that you've ever heard of, those are my customers, and they count on me to protect their consumer data. You know, so some might say, oh, it's a dead credit card, it doesn't matter. I have their social security number, I have all of their information, and I'm trying to get them back to financial wellness. So that's a non-negotiable for me. So it should be for all of us. So let me be candid here. On the left side, I think some of you may think that I have clean architecture boundaries. Clean, right? So I think that's some of the things that you might be thinking about. Some might think I know what my actors are, what the predictable actors are. You also might think that my systems, I can fully observe all of my systems, right? That would be a perfect world. That's not my world. My world is actually more of a hybrid environment. I have AWS, I have Microsoft, I have data centers, I have a variety. So I have a hybrid environment. I have leaky abstractions. I do. I'm going to be candid. I have rapidly evolving behavior. I have my own employees. I have our consumers' behavior is changing. So there's a whole lot of rapidly evolving behaviors. So really the question is, how do we get to the right side? How do you help me with my reality? Not what the perfect world is. What is my reality? So I'm looking for your help with all of that. So it has to be built in trust. We have to build that trust in right away. So I don't have any products to sell today. I'm not selling a product, and hopefully you're not my consumer. And if you are, I'm hopefully you're having a good experience. But I need help. That security has to be built into everything that you do. I need you at the table with my regulators. And after hearing today, I feel like I need to cast my net even wider. But I'm watching every bill that's being proposed at both the state and federal level, because I think they're going to impact all of us, and we need to figure out what to do with that. And just remember, I don't have an army of people that are coding. So I'm actually looking for you to provide that software or that hardware solutions that I can implement safely. So it's really built on trust and my trust with you. So what we need is execution that is verifiable, right? We need data boundaries that are enforced. I need that from you. And I need policies applied at runtime. I need policies at runtime. It's super important. So the future for me, the future is that systems we can trust. There's provability, it's consistent, and it's at scale. We're not a tiny company, it's at scale. And so that's what that future looks like, because for me, I'm gonna prove that I can have governance, right? I need to prove to everybody that I have governance because I'm gonna win in the market that way. And the people who aren't doing that, they're not gonna win, right? They're gonna explain to regulators why. I have sat in the seat explaining to a regulator why back in the mortgage crisis days. I never wanna do that again. So I'm trying to do it up front and right away. And so that's actually why I've engaged with Opaque and engaged actually with many of you here. So anyway, that's all I have for today. And I thank you for listening to me. I think it's a very different perspective than the software and hardware providers here, but I'm definitely a constituent and need your help. So thank you.
That was outstanding. That's really good. Okay, I hope everybody heard the three forces. I just want to reinforce what those three forces are, and all of you have heard it on repeat throughout the conference so far that Manik just highlighted, which is there's a new class of models. You heard Jason talking about, hey, it's not the Mythos class models, and there's open source models that are lagging somewhere between 7 and 10 months behind the most sophisticated frontier model labs. that creates tremendous risk across our global economy, industries, governments, and ensures that it's not a matter of if you're going to get infiltrated by one of these models. It's going to happen and when. So that's one major force that drives the mandate around confidential and verifiable systems. The second is, of course, as we're adopting agents, we understand that these agents are intrinsically hemorrhaging data just by their very design if they're architected in legacy approaches that we've been using. And I think Yvonne did a tremendous job of pointing that out for generative AI chatbot, right? We know that agents are far more risky and capable of leaking data as part of their architectural design than even generative AI chatbot. And then the third, of course, is the regulators are increasingly mandating runtime proof of governance and policies that are enforced at runtime along with your AI bomb and crypto bomb. So all of this leads us to the inevitable conclusion that for all of us here, as I kicked off this during my keynote, we are literally working on the technology that is the most important technology of the next 2 years because it determines the future state of, for generations, of what benefit we will receive from AI, as well as what the second order consequences or negative externalities that are created by our adoption of AI. We have to build systems that afford us data sovereignty in order to ensure a robust, vibrant, thriving ecosystem that's durable and resilient because it's distributed rather than consolidated into one or two intelligences, which would be horrible because it would be an incredibly fragile system and detrimental to our economy. So speaking of distributed, I want to introduce our next speaker, who is undoubtedly the most influential distributed systems researchers alive, and someone whose work sits at the intersection of the systems that power all modern AI and the security guarantees that make that AI trustworthy. Dr. Yan Stoka is a professor of computer science at UC Berkeley. He's the co-founder and executive chairman of both Databricks and Anyscale. He's also a co-founder and board member of Opaque. His research has laid the groundwork for Spark, Mesos, Ray, VLLM, most of our AI infrastructure, and I'm very pleased to have him once again at CC Summit. He's one of the creators of CC Summit, in fact. Thank you for being here, Yan.
Hello, everyone. I'm very glad to be here. Thanks for having me. So I'm going to talk next about some work we have done recently at Berkeley, and it's about reliability in AI in general, and in particular, reliability for agentic systems. So first of all, what is reliability, right? And again, there are many definitions. So I picked the one which is on NIST website. This is National Institute of Standards. And what it says is that the reliability is the ability of a system or a component to function under stated condition for a specified period of time. Okay? And what does it mean? To functions is to meet some properties like accuracy, correctness, consistency, predictability, robustness, and safety. So now, the reliability in AI has received a lot of attention over the years. This is a paper coming up of Stanford. Dario Amodei was saying in an interview 1 year and something ago that he says, actually think the most challenging thing about AI agent is making sure they are safe, reliable, and predictable. And in the same interview, he's basically saying is that it's what holding us back are not the model capabilities. And this is over 1 year ago. Of course, we have a lot of improvements in the model capability in past year and so. But what's holding us back is the fact that what we are going to deploy in productions is going to work reliably. And this is some state of the agent engineering published recently by LangChain. The same thing is saying that as we enter 2026, organizations are no longer asking whether to build agents, but rather how to deploy them reliably and efficiently at scale. And a few others kind of headlines. The last one is a little bit over 1 month ago. We also have done, with collaboration with some of the partners, IBM and others, a study of the agent in production. And we wrote this book, this paper, which you can find it on our archive. And we look at 86 deployments over 20 different use cases and 5 domains. And it's the same, the conclusion when we interview people, they're basically saying, reliability remains the, like the main the top development challenge. So now, this is not something new, right? We had this in systems forever, in software engineering. You have that everywhere, right? For your fridge, for your car, and so forth. Reliability is a big thing. And the one thing I want to note, again, with the software engineering, is like you first build a prototype to demonstrate the capabilities. And then you have to productize this prototype. Now, it turns out that the most of the work is going to productization. It's anywhere between 10 and 50x. So this is, the famous book by Fred Brooks, The Mythical Man Month, which is basically saying from prototype to production, you need to spend 9 times more effort, okay? Now, this was in 60s, 70s, so smaller code base, maybe people are more careful, but it's, there are more recent code, so to speak. Here is John Miller, which was architect, engineer at all these kind of top large companies like Amazon, Google, Microsoft. And he was saying basically that going from prototype to production, it takes the effort, it's over 50 times more than just building the prototype. So why I'm telling you this? What does it mean to go from prototype to production? Is basically making that software artifact reliable, right? Meaning that it has to work for any user, every user input, in all kind of use cases, maybe on different kind of hardwares, all of this, right? And to, just works, like Steve Jobs used to say, right? Now, going into more details, what does it mean this to productize a feature? It's like, what does it mean? You need to test it, debug it. You need to care about compliance, governance. When you deploy it, you need to have observability and all of this stuff, right? And if you are going to go to testing and debugging, it's like, how do you do it, right? Typically, a system consists of multiple components. Then you try to figure out which components, to locate the error, and then, to figure out what then the error is, make the changes, and then it's kind of, and then hopefully it's going to work. Now, the one thing which is very important, and I'm going to come back towards the end, is that you can do that because each of these components, as well as the entire system, you have very clear expectation what it's going to do. Okay, so when it's an error, when you have a deviation from these expectations, and that expectation is specification, right? Always you have that, right? Now the question is about how precise it is, right? Because the specification can be in the form of PRDs, the product requirement documents, or formal specification using some languages like Lean or Coq and so forth. Okay, and then debugging, once you identify the component, like I mentioned, you fix the problem by changing the code and repeat the process until hopefully all tests pass. Okay, now debugging an AI agent is harder. Okay, and by the way, going to the software engineering examples, I just want to we are talking about the software agents, right? Which generates the code and everything. The point I want to make here, that for a long time and in many situations, generating the code is not the biggest problem. It's just make sure that that kind of software, actually, that program is working. Again, the reliability, which I just mentioned to you, takes much more time, right? So that's kind of, I just want to put things into perspective. That's where the problem is. And it does not now, it's today, it has been for decades, right? This is what people do. This is what software engineering spend time. So for an agent, like I mentioned, things are more difficult. And basically, just to make sure that we define the agent is a system in which an LLM acts as a central reasoning engine and in a loop, which repeatedly interacts with the environment using some external tools, gets the observations of these interactions, and iterate until a stopping condition becomes true. Like task is done, budget exceeded, or there are some errors. And the reason it's much harder is because the central part, like I mentioned, of an agent is a large language model. A large language model is a black box. Unlike software, every software component, when you debug it, it's like you have the source code. It's a white box. You can go and identify the instruction which has a problem, and you modify it. Here is much harder. Just to give you a sense, it's like you would debug a program without looking into it, just observing the inputs and outputs, right? Just much harder. Now, we are going, and in the past year or so, you see all of this kind of transition from agent loops to multi-agent system. It's a good transition, right? It's actually, in some sense, user agents resemble more kind of the system, and you have different components which communicate between them, and which, more clearer interfaces. And the reason you have multi-agent systems, it's actually a similar reason of why you have a system which is composed from multiple components. You have content isolation. With content isolation, each component, each of this agent or sub-agent knows only about its prompt, about what it has to do it. Like specialization, right? Each sub-agent is doing only one thing, which is much easier than one agent handling many tools with a very large prompt, and also sometimes more cost efficient. It's parallelism. If you have tasks which can be executed in parallel, you can have a sub-agent executing its task. Like, for instance, you want to process a lot of documents in parallel. You do a lot of searches, and then you want to aggregate the response, and so forth. And it's modularity, right? If you want to change the system, you don't need to change the entire system. You can change one component at a time, right? You have an agent which is doing better verification. You can change that one, and the rest can remain the same, right? It's more modular way to build systems. This is an example about chat dev, and here what you have is like, you model the agents by kind of a software company organization. You have a CEO which comes with the idea. You have a CTO which basically figuring out what to do and how to do it, provides a plan or requirements, documents, so something like that to the programmer, and the programmer is implementing. Then you are going to have kind of iteration between the programmer and the CTOs, and you have a reviewer for the program, and then you have testing the program, right? That's kind of what it is. So the next part is going to be what I'm going to focus. It's about one step in all of this kind of process about how to make system reliably. And that's the first step. It's how you have to actually identify the errors, right? The failures. And I'm going to talk about two projects, MAST and Atlas. So MAST is multi-agent system failure taxonomy. And we made this study around 1 year. We started 1 year ago, and we published this paper a few months ago. And we look at different agentic frameworks, multi-agentic frameworks, like MetaGPT, ChatDev, HyperAgent, and so forth. And we try to identify, to run them on kind of pretty regular benchmarks at that time. And the main point here is that each bar is basically saying blue is success, yellow is failure. So as you can see, the majority of cases you have failures. So failures are prevalent. So the next question is, why do they fail? So we look into that, and we come up with, the goal is to identify and classify, come up with a taxonomy of these issues, of these failures. And how did we do it? We took 150 traces, and the students manually annotated all the failures to fit in some kind of categories. Then we took 1,000 or more traces, and then we developed a system, basically using the LLMs, to categorize these failures. And then we use the data from manually generated by users to make sure that these LLMs are going to classify the same way. The agreement between the human classification and LLM classification, 95%. And then you generate this kind of taxonomy. We look at 7, the most popular at that time, agentic frameworks. And this is what we got. We got to 3 categories, which is specification issues, inter-agent misalignment, and task verification. And each of them has another 3 subcategories. The one point to notice here is that there is no dominant failure category. They are pretty balanced. I'll give you a few examples next. So specification issues. Let me just, so specification issue is that the failure is like here, it's about ambiguous prompt specification and things like that. But here are some kind of failures. The agent disobey task specification, disobey what you are going to tell it to do. Disobey role specification. If you are going to say, hey, you are going to play the role of a verifier, it's not going to do only that, it's going also to change the code, for instance. Step repetition. You are going to in a loop, doing the same thing over and over again. Of course, you don't want that. You're just going to spend more tokens. And conversation loss. You lose things in translation. The information is not carry on across iterations. And agent unaware of terminal condition, I don't know when it's going to terminate. Here is one example, very simple example, in this chat dev. So here, the CEO basically say, okay, we are going to discuss about what to do and how to do it. And when we all agree, then we are going to do it. And in this case, the CPO is basically saying, okay, I will do it, and just go to the website to do it. So this is an example disobeying the role specification, because the CPO shouldn't do and take anything or take any action before the CEO kind of decides what the action is going to be taken. Okay? So the interesting thing here is that you may think, okay, I'm going to use a better LLM, better prompts, and so forth. But one other way you can fix this one is to basically process. Like you'll be in a company, you'll improve the process, right? You don't change people, you don't think, you improve the process. So here it's equivalent to changing a little bit the system and inserting another step in the process. In this case, you have a step in which basically the CEO is going to decision step, right? You discuss, but then it's a decision, explicit decision step, and you are going to make the decision what to do next. And by doing just that, not changing anything else, you can get an improvement in the accuracy by 9%, which is pretty high, okay? Inter-agent misalignment. So here you can have a lot of things. It's like conversation reset, failure to ask clarification questions, information withholding, ignoring the input, and so forth. Here it's an example. So here you have a supervisor, you have a user, which tries to, through an agent, to take an action. Like, for instance, you want to go to use an agent to buy your flight ticket, okay? So here you say, okay, this is a task I want you to do. And by the way, these are my credentials, because you may want to log in from a site to perform that action. The first thing is happening here is that the phone agent, this is kind of the agent which is doing action on your behalf, taking action on your behalf, is just sending to the, to this case, Python executor, like this is like the site where you buy the ticket, for instance, is just sending, hey, I want to buy this ticket without sending the credentials, right? So it's just information withholding. Now, the site, the Python executor is saying back, okay, you need to log in. You have to log in. And for that, you need to give me the username, and for your account, it's a phone number, okay? Now, I didn't notice that the supervisor, when you ask the agent to do the action on his behalf, he did provide credential, but look at the credential. The credential was a username, it was an email, right? While this Python executor, in this case, asked for a phone number, okay? Fine. Now, what it turns out that this kind of phone agent, in this case, ignores the inputs and basically sends to the Python executor, ignore the input in which was asking as a phone number as a username, and it just sends the username as an email. Okay, so that's, now the Python executor is basically say, hey, invalid credentials, okay? And what happens right now is like, the phone agent is going to go back to the users and basically say, hey, the login credentials are incorrect, but it doesn't say what was incorrect. It doesn't say what. It doesn't say, hey, you should provide actually the phone number, not the email, right? So it's again, the information is holding, as a user, you don't know what to do about it, okay? So the inter-agent alignment are kind of more subtle, and you cannot do this kind of easy changes. You need, in some sense, more deeper social reasoning to solve these problems. Let me talk a bit about task verification. The task verification is like the last category of failures, and these are premature termination, incomplete verification, or simply stating that something is working when it doesn't work. And here is one example. I'm telling, I want to build a chess game, right? And this is what the CEO tells to the programmer. And then I have a verifier to verify whether the program is working correctly. Okay, so looks good to me. However, in this case, the inputs do not follow the standard chess notation, like king at K6, like king at, king E8, right? The king is E8 position. And then the pawns can move backwards, okay? So with task verification, there is no silver bullet. You need more testing, multi-level verification, and so forth. Now, let's understand the user profiles for some of these cases. So this is, again, the chat dev. So specification issues. You have, I don't know, okay. Disobey task specification, step repetition, and then agent unaware of termination. And then here you have the other for the other, you have for the other categories, inter-agent alignment and task verification. Now, if you look across all these frameworks, you see it's kind of diverse. In particular, for upward, each of the categories you have more or less the same errors. It's pretty well balanced. However, if you are looking for open manus, it has much more skewed. Most of the problems are specification issues. You have very few task verification issues. So this raises a question. Is one taxonomy good for all, right? And obviously the answer is probably not. So what you want to do, you want to have to customize your taxonomy of failures based on agentic architecture or domain, like coding, finance, math, and so forth. And then the other question is that, okay, I'm going to have this taxonomy. What am I going to do about it? How is it going to help me, right? Can I use it to improve the system? So this is the next work. At last, I have only a few slides. And it is another way to look at. It's about here what you are going to see is an overlap between the failure modes for different domains. Each benchmark is a different domain. As you can see, it's very low, right? One is total overlap, 0, no overlap. Everything is like 0.1, 0.2. The max is 0.3, okay? So again, just tell the same things, that failure modes are kind of different across domains, across frameworks, which you should expect. So Atlas is going to build a customized taxonomy for a domain and kind of framework. How you do that? You take the traces, then you are going to classify the traces in system, agent, and domain errors. Then you are going to clean a little bit that, you eliminate the duplicates, you make sure that each failure is indeed a failure. Then you have a group of agents which are going to try to figure out a taxonomy and agree on that, and then you end up with a taxonomy. So the last question I mentioned is that I have these taxonomies. What can I do with them? Well, it turns out that you can use them to improve this multi-agent, system reliability. How you do it? So this is how the mass, logs look like. In this case, the first one is a prompt for the CEO in chat dev. Then you have an error. Then the next prompt is about for the CTO. Okay? Now, so this is user system prompts, chat history, logs, different logs, and code execution errors. It's lots of unstructured and messy data. You can have thousands of lines of that. So even if I give you the programmer, hey, this is the logs, find the problem, it's very hard, right? So what you can do here is to use this taxonomy to make a little bit of order, to produce a structured feedback around the failure modes. Okay, and you can do that, for instance, providing in the prompt, hey, these are kind of the taxonomy failures, or you are going to do it as a skill, right? To have another agent, sub-agent, using that sub-skill to check and how debug the problem. And here you have compared self-reflection. This you are going to sweep bench for two frameworks and harnessings. And the only thing, you have self-reflection, this is a baseline, and then you have must, using the must, the fixed taxonomy, and using Atlas in pattern A in the prompt and as a skill. And as you can see, by having, first of all, taxonomy helps. Both must and Atlas are better. The second thing is that Atlas, so customized taxonomy help even more. This is another example. You have terminal bench to 0, and here we do it as a LLM as a judge. In many cases, you use LLM as a judge to decide whether an output is good or not. Right? This is what you do. Now, in this case, I'm going to tell to LLM that the judge, I'm going to give this taxonomy for that domain, and that really helps you. Again, you see pass 1 and LLM as a verifier, they are baselines. Must judge using the fixed taxonomy. Atlas it's using customized taxonomy, and you can see the best of 5. Oracle, this is Oracle. It's actually, that's the best you can do, assuming that you know the correct answer. So in summary, reliability is critical to AI success. Must and Atlas. There are 2 projects which try to understand why must fails and can use failure categories to improve reliability. And this is just starting many challenges. Some parting thoughts. So again, reliability is important. It's important in every domain. It's important in the software. It's important for your car. It's important for your fridge, everything. So reliability will be very important for AI as well. There is no question. It's also reliability. It's a staple of engineering disciplines. All of the things I'm talking about, they are engineering disciplines. Okay? And I don't know. And in AI, it's going to be true, and it's going to be even more difficult to solve it. And one thing which matters a lot is specification. We are talking about verification. There is no verification without specification, right? What you are going to verify. You always verify that something behaves according to some expectation, according to a specification. That's very important. And specification not only allow you to verify, allow you to debug, to decompose the system in smaller pieces, to reuse a component. If you know exactly what a component is doing and it's very well specified, you can replace it with a component which matches the specification. And it also helps you automate decision making. Because if you trust the specification, then you don't need maybe you don't need in some cases a human in the loop. So, okay. So these are some papers in this area we done. So this is my last slide, and sorry for taking so long. So specifications help makes agent verifiable, but alone they don't ensure correctness. So that's why you want to use a hardware can enforce the correctness. right? Like you heard, right? Using the hardware, you can ensure, you can guarantee that where the code is running, what code is running, what data is accessed, and what rules and policies have been enforced. And not only that, but using cryptographic proofs, it can provide you provable evidence that all of these things were correctly followed by your agent in production. Thank you.
Thank you so much, Yan. Thank you. Great. So Jan's point about specifications can improve reliability, but in order to enforce it, you need hardware enforcement. I just want to draw everybody's attention to announcements made yesterday about the Agent Trust open source project that Opaque released. Includes a specification we call Agent Manifest. It's all released under an open source. You can find it at agenttrust.io on GitHub. So thank you so much, Yan. We're preparing for our panel discussion, which is being led by Jason Heiner from DeepView. If you guys are not subscribers to DeepView, it's a terrific newsletter that has a very large readership because of the quality of the work that the team do there. So I'm going to go ahead and invite Jason up, and Jason will introduce all the panelists. So please welcome our esteemed moderator and panelists to the stage.
All right, thank you. Good to see everybody. So go ahead and I'll welcome the panelists up to the stage. First is Brittany Kaiser, Yan Stoka, Manik Dum, Jason Clinton. Hi. Love to meet you too. Hey. Hi. Good to see you. Hi. Hi. Such a pleasure. Hi. All right. Well, you know, throughout the course of the event so far, I've been so impressed by the depth and fidelity of the conversations, themes of decentralization, local control, agent verification, you know, all of the really focus on safety, manageability. All of these things are so present right now in all the conversations that we have with people throughout the industry, that all of my team of reporters at the DeepView and I have. These are themes that come up again and again and again, and have gotten to the point of a real sense of urgency. And so it's great to see the level of conversation here, to see how far advanced, you know, some of these conversations have gotten. So, you know, I'm thrilled that we've got such a great panel to double click on these topics. And so we'll go ahead and dive into it. The first thing that I would love to talk about is the fact that, you know, AI agents have become more widely deployed in our organizations. They're coming to our devices really faster and more furiously than any of us could have even anticipated 6 months ago. And so, you know, what are the most sensible ways for our organizations and for, you know, ourselves to manage the agents, to maintain, you know, privacy and security? I think it's probably a great place to start, because it's very present, I think, for everybody here, both personally and for the organization. So maybe we'll sort of go in order to start.
Well, thank you so much. I have seen over the past 6 months that nearly everyone, whether you're an individual, an enterprise, or a government entity, is trying to integrate AI agents. And the only organizations that are not are because they realize the amount of data breach opportunity, and they can't get it through compliance to actually integrate agents into their data systems. And so because you're sharing so much more data with agents than you have in other ways before, we're now looking at compliance as the #1 issue. So there's legal and regulatory compliance, but there's also within your organization, especially if you're from a regulated industry like banking and finance or healthcare or government and military, how do you actually integrate AI agents without creating so much more risk than you've ever had within your systems. And that is the reason why we are promoting the use of agentic software on confidential computing. We see that confidential computing is more and more not just a compliance issue, but as Jason also talked about in his keynote, this is a national security issue. If we're attaching agents to all of our most sensitive data sets in both the public and private sector, we need to make sure we're running them on confidential computing so that we don't become a target and a bigger risk.
Yeah, so I think actually you have to deal with the same problem like before. It just is much harder because these, artifacts, they have more autonomy and they are more black box. But data governance, compliance, we are talking about compliance in some sense, kind of the same laws, right? Which are for years, right? It's just much harder to enforce, right? I think that's kind of the difference. So I think that, to your point, I think that companies which are doing a good job of doing it, is just recognizing that. And you have to maintain control, at least for a while, to make sure that you know exactly what data is accessed, right? How it's accessed, who is accessing it. So, which you have to do in the past, is kind of typical software systems. But again, this is much harder. So if you recognize that, I think that you are on a good path. But it's not going to be easy. It's not like this.
I think the governance is hard. So we don't have ability to really see. So what I worry about with agents is I have my users, as I mentioned earlier, who are creating agents. But if they leave and that agent has a critical process that they're running for whatever function they do, and they leave, is that agent still running? Is it running rogue? What is it? And how do I know that? And so that's actually something that I've been looking at, and I know you mentioned it as well, is like, how do you lock that in and make sure that, like we're looking at, do I start making them check in their code?
Mm-hmm.
And the SEC actually requires it as well. The SEC requires, right, that it doesn't matter if you're a developer or not developer, you're supposed to actually manage your code, your agents the same way that a developer does. But they don't, and so how do we enforce that?
Yeah.
And that actually has to happen with the tools.
Yeah.
Because you can't actually, a person at their desk,
Yeah.
that person's going to do bad things, maybe not on purpose.
Yeah, I love that you sort of like leaned into something that's more like an example. Sometimes actually, there's so much I could say. I have like a 2-hour talk on this topic, so I have to come up with a short version of the answer here. I'm having a microphone problem. Here we go. So one of the things I would say on this is that so much of the way that agents get deployed at Anthropic is actually really well represented by the example of what happens in code review. So if I just use code review as you were just giving an example of, if you think about today, we just closed, was it 3 weeks ago now, in the recursive self-improvement blog post, when AI improves itself, that we're at 8x the lines of code per engineer being written, relative to 18 months ago. That incredible explosion of productivity is being facilitated by agents. Mm-hmm. And then in the announcement yesterday, we made it very clear that there's this other thing going on that's not just the agents that you're talking about that are owned by a person, mm-hmm. but there's this like other kind of agent that's sort of like a virtual employee that's doing a bunch of this engineering work. Yep. That is producing so much code that effectively oversight of that agent and securing those agents from traditional code review practices is actually itself becoming a bottleneck. And this is Amdahl's law. So finding ways to scale the oversight is actually part of the solution space, right? Mm-hmm. And in the case of code review, what we're doing, and just to make it very concrete, is code review is being run by agents as well that are initialized with orthogonal or adversarial prompts. So they're trying to find insiders, but then those results themselves are being reviewed by humans. Both on the engineering side and in our detection and response team looking for insider attacks. So there's lots of different ways that you can think about scalable oversight, but I think fundamentally the answer is scalable oversight.
Mm-hmm. I want to double click on something that you said, Ian, which is that in a sense, we're still trying to do the same things that we've always done with systems. The challenge, though, is that we had deterministic systems before. Now we have these non-deterministic systems. Do we need, and some of this is what you're getting at, I think what all of you are getting at, we sort of need new ways to think about it. Yeah, how fundamental is that? We'd love everybody to,
Yeah, so I think, and I want to piggyback a little bit on what Jason mentioned. And also, Karpati have this kind of code you can outsource thinking, but not your understanding. So what I want to say is give you an example, like code reviews. So in some sense, you see, it's like the agents are going to do more and more, right? There is little question about that. But then this means also it's much harder for the human to verify and convince themselves that without deep understanding, that what they've done, it's correct, it's some form of correctness. And they have to do it because someone has to be liable, right? Anthropic will not be liable, at least. So you see, so you have to do that. But it's like you have a long tail of issues, right? Like failures or things, And then you are, the models are going to come to the head of the distribution, do more and more and more. And they are going, yes, fewer and fewer issues, but these are going to be more and more difficult to figure out. Right? So I think that's kind of, it's one way for me. And that's, in some sense, when and I'm going to take in total different direction, but in some sense, it's like when there is a discussion about the jobs and so forth. Today, in the AI process, the humans are the bottleneck. There is no question. Right? Of course, it's a different kind of skills. You need to have very deep understanding about what happens, right? In order to try to figure out, oh, it's good or, that. So that's what I want when I say this is about the difficulty, but it's fundamentally, at least for now, things have not changed. There is another thing which I found, because there is a way to do it as long as you have the human in the loop. You can look at this like tools. Of course, there are tools that can self-improve and so forth. So what is different from previous tools is like the previous tool is pretty clear what they can do and what cannot do. You know what a calculator can do, a car can do and so forth. But with this model, especially since they are so fast improvement, it's unclear what they can do and what cannot do. And the problems occurs when you assume that it can do something, right, by induction, because it did A, B, C, so it has to do D, and it's still on the boundary, they cannot do it. So it's like, that's kind of the way I'm seeing it. But yes, they are non-determinists, that's a part of the challenge. When there are failures with the software, a lot of times the problems are when it's not non-deterministic failures. These are the hardest failures, right? It's more prevalent, yes. But I think structurally, it's not that different, it's just much harder. And of course, it's like, that's why you need new kind of tools, and we are talking, we are here, right? You want something is harder to do, you want to provide better and better tools to help addressing that problem.
And I'm glad that you talked about liability specifically, because from my point of view, from the legal perspective, all of these questions go back to who holds the liability in the event of a data breach. And so when we're looking at how we're regulating and legislating around these systems, it's only been over the past year that we've started to actually see not just standards out of organizations like NIST, but also pieces of legislation that get highly technical and talk about the entire process of AI systems and what you need to do when in order to lessen your liability. And the only way we're ever going to see true global adoption of all of these systems is when you can very well define liability and how you can lessen your risk. I've been on stage with, the heads of all of the top banks in America over the past couple months, and many of them are not even using AI yet because they haven't even figured out how to get these systems through compliance, and it's because the liability is way too high with the sensitive data sets they're holding. It's the same with the healthcare industry. Unless they're using confidential computing, they don't even find ways to use these systems in a way that is HIPAA compliant. So they're having a lot of difficulties figuring out where does the liability lie, how can I lessen my risk, enough to actually adopt some of these new AI systems to improve my business.
Yeah, they've learned a lot of hard lessons in the past, right? Those, I've lived that. They've learned a lot of hard lessons in the past. And so what most financial institutions are doing are they're watching, because they want actually all of these things in place from a compliance perspective, because they've been on the reverse of that, where they went forward, where they bought stuff that went forward, and then had to go do it on the back end. And doing it on the back end is just not feasible, especially at this pace. The pace is way too much. So I totally see all of my financial partners that are all watching, waiting.
Jason, anything to add on non-deterministic systems? Okay, all right, let's go to the current agent architectures can struggle with data leaks because of context windows, MCP, RAG, all the things that have been talked about a lot the last couple of days. What are the inherent issues in design that make these systems vulnerable in ways that we're still grappling with?
I'll start here. I like to use an example from Star Wars. I'm explaining what I mean by that.
Hey.
In the beginning of the Verse movies, like, these are not the droids you're looking for. Like, this idea that a Jedi mind trick would work on a human being is ridiculous. Like, it's you have to suspend some disbelief to imagine a human brain is vulnerable to this kind of like prompt injection, right? And I think it's fundamentally a question of intelligence that we haven't been able to solve these problems. We're many orders of magnitude away from the number of neuron connections that are inside a human brain in a modern LLM, and we'll keep scaling, and so we will get there eventually. But I do think at some point, prompt injections and jailbreaks, maybe prompt injections first, we seem to be making a lot of progress on that, and then eventually jailbreaks are actually just not a thing. And then the question then becomes, if they're not, then is there additionally some really well-reasoned way that a model, knowing what the security compartments are and who should be trusted and what secrets are not to be divulged to other parties, is going to be solved. The reason I believe this is that models are, they just want to learn. They emulate the way that biological brains work, and we published research on this 3 months ago. That sort of provided empirical evidence that this is a case. So I think ultimately there will be a model-based solution, but it's a ways out. So what do we do between now and then? And really the question is, can we avoid putting information in the context window which we cannot trust the model to appropriately delineate and segment? So outside controls, things that sort of wrap the model, the scaffold, with the right security compartments or information compartments to make sure that there's isolation in space, is super important design principle today. We do this at Anthropic for all of the yesterday on stage, or not on stage, but yesterday morning we announced Claude Tag, which is this new multiplayer AI agent, where it's interacting with lots of different people. Everyone in that type of product or in that type of scenario, no matter if it's from Anthropic or anybody else, the only way to make that work is that if everybody is inside the same security compartment, because you cannot rely on the model architecture to differentiate between information leaks or not. So that's an example of applying that principle in an actual product space, even in a place where you have many people interacting with the same model.
Yeah, so one of the hardest things we found working with a model, and not only with a model, is these things about you don't know what you don't know. What I mean by that is, like, say you go all the extreme and do, you want to have a task, and you do a task, formal specification program. So it's not formal specs. If you have a formal specs, in theory, you should be able to generate a code, and then to prove that the code, you generate the proof that the code is going to satisfy the specification. Of course, the question now is that how you are going to come with the specification. And it's kind of very hard. And a lot of things, there are things you never know. You never think about. Because the models, it's also the models, why it's very hard to have this kind of boundary, what they do well and they don't do well. In some sense, and I'm sure, Jason, you can correct me here, but it's like the information and what they do for a model comes in two forms. It's like comes in what they are trained, pre-trained, post-trained, and then is a context window. If it's not in one of these places, and you don't know clearly what it is, it's like the kind of better off. There can be a reward hacking or things like that. Now, they are better and better. One better and better is like what they do more. Like for instance, I remember, this is a very clear example. I remember 1 year ago, or 1.5 years ago, when you use kind of Claude and so forth, people saying, hey, he's going to have more vulnerabilities than if I write the code. Now, fast forward today, it's going to have much less vulnerabilities. Why? Because that's always part of the training corpus and so forth. So kind of this boundaries always changes. But it's the things, you do not know what you don't know. This is I find the hardest thing. You know, always something like it's like things you, and it's not, you don't know also what you have to say. Right? It's like I remember we have, and I'll be short here. We have these examples, and there are many examples what is called kind of this reward hacking. Right? You want to accomplish a task, and then the model accomplishes the task in a way you didn't think about, and it's not correct. The simplest thing is that you have a system, and you want to increase the number of requests it can handle, and you ask, okay, go ahead. This is the code of the system. Optimize it, and so forth. And one of the most trivial things you see, is you have a solution which is processing a lot of requests. But when you look in the details, it's like, what is doing? Dropping the requests, okay? Now, you never think about things to specify to some human to tell them, you need to build the system to increase the number of requests to optimize it. You never think, by the way, don't even think about dropping the request, right? It's like, so that's kind of the things what I think is the hardest.
Yeah, and I wanted to piggyback off of that, and also something that Jason mentioned, which is that there's a lot of organizations that are saying, okay, well, there's some data sets that are so sensitive that if we put them into the models, we're not sure if we can trust the models to treat that data correctly. Cybersecurity-wise, we don't know if malicious prompting is actually going to be able to get that data out, so maybe we won't even put it in the model. I'm seeing with a lot of the organizations that we're talking to about implementing larger scale confidential computing for, and if they're already using confidential computing today, they're choosing only their most sensitive data sets to put through it, and then basically saying the rest of this data is less sensitive, and they're forced to do that because they don't have enough access to confidential computing architecture. And I would say the best example is, at our Department of War, they're basically running on confidential computing all of their autonomous drone programs, and the rest of the data is apparently less sensitive. I don't know how a Department of War or Department of Defense has less sensitive data, but they're just choosing what they can put with the architecture that they have. And there's a lot of other organizations, especially in the financial and healthcare spaces, that are doing the same. And so I think everyone here at this conference actually enabling larger scale access to confidential computing, perhaps we won't have to make those types of decisions in the future and say, well, okay, here's my most sensitive data sets. It's like, no, you can put all of your data sets through confidential computing if you decide to invest in that architecture. And I think that's one of the most important things that can come out of this conference, is making sure that everyone has access to that.
I think also with all of that is, so we're training these models, these LLMs, with policies and legislation that's happening. But I think all of us have legal teams and compliance teams and risk teams that are interpreting those rules differently for their own company. And that part is something that's not perfected. And so, that's where we get a little bit edgy here from a financial services perspective is, we are a very risk-averse company, but not everybody's that way. And so then when you look at the legislation or whatever, and how you should be treating that data, some of us are going to interpret that differently, even though the law is written black and white words, but everybody has a different interpretation of that. And that's actually a part, I think, that we're very worried about from a financial services.
Yeah. Okay. How about, for customers and then eventually regulators, how should they expect to understand the ways that agents are acting and have acted when it comes to observability, and then, and especially if something goes wrong, right? What are the expectations? And then, how can not only we get that information, but how can we make sure that information is trusted?
So I use this analogy a lot. Think of the model as a brain, and the way that the model interacts with the environment as the hands. And hands almost always today means an MCP server or a command line tool invocation. And because of this simplification of this mental model, every opportunity for the model, which you can think of as a brain in a jar, making calls out to its hands to actually do work in the real world, is the place to put the controls, is the place to put the observability, is the place to put the logs.
At the hands?
At the hands level, yeah. You really don't even need, at this point, to care that much about what's happening in the brain, although you can. I mean, at some level, that's what Anthropic is doing. We have these things called linear probes that we use for monitoring model performance. And increasingly for folks running on open weights models, you can do this as well. But if you just think about governance and the controls that you put in place from a regulatory perspective to understand, from an ISO 42001 perspective, am I meeting my governance requirements? The question is really, do the hands have the monitoring? Can I tell definitively not only what tools are enabled in the first place, so limiting the actual hands that are available, and then when you do enable whatever those hands are, the MCP servers, the verbs on the MCP servers, having a record of what exactly happened and what the context was of the invocation, so you can use in a SIM or a data lake or something to sort of have a post-mortem or a place to do that forensic analysis if there is a problem. One thing I want to just harken back to an earlier question just to really underscore this. We were talking about liability, but in my mind, actually, what we're really talking about is accountability and a blameless postmortem culture. Mm-hmm. What you want is to be able to understand from a systems design perspective, is the system that we're designing have all the controls that it needs in place? Mm-hmm. Do I have the appropriate audit trails? And when something does go wrong, am I resilient to whatever that event is? And can I, do the forensics and understand how we achieve, we entered this, failure mode and prevent it from happening again in the future?
Mm-hmm.
Yeah. So if I have to, one thing, just quickly. So one thing, the way I think I find useful to think about it when we interact, think about the actions that an LLM can do using the tools. You can undo it. It's not easy to undo them. Mm-hmm. That's kind of you can think about. And that depends a lot of things, right? It's like, for instance, if you have a version databases, you can allow that to change the database because you can always go back to the previous version. And also is a compliance, right? It's like, what are the things you can do and then are bad and you can undo it, cannot take it back, right? Right? For instance, if you let it send an email to an important person, you cannot take it back, right? It's a bad email. Yeah. So that's kind of the way to think about. And then there, like Jason said, you can put there kind of guardrails and right to make sure that thing doesn't happen. Of course, this means that you have to think ahead and to map everything bad that could happen, which is a challenge.
I mean, that's normally the process of interacting with regulators. You have to go to worst case scenario all of the time. What are all of the possible fallouts of there being a breach of these systems? What does that look like structurally? And then how do we think in terms of legislation around that? How do we think of how regulatory bodies are mandating that? And then again, how do we create standards so that the entire industry is held to the same rules, so that consumers can actually expect that they can use a product and they understand how it functions and where their data is going and what rights they have should there be a breach of their personal information. So there's one way to educate consumers, which again, is probably to make terms and conditions a little more obvious and to have a little bit of digital literacy embedded in the platform, tell people how to use things and maybe how not to use things, because that's not really taught in schools widely yet. So most people are not digitally literate enough to know what to feed into AI or not, or how to use it, or how to spot a phishing attempt, or whatever it happens to be. But on the regulatory side, we're usually dealing with people that are a lot less technically literate than the consumers even, and they really need to understand how these systems function. So I think everyone here that is in AI, if you've never met with a legislator or a regulator, please do that. Like, show up on the Hill in DC if you're a big company, if you're a smaller company working locally, show up to your local state Congress. Reach out to your representatives who represent you and your company and your consumers on the Hill, and make sure you are really engaging with them, because the only good technical laws are usually written with direct engagement from people who really understand the systems. You can't write a law that's technically enforceable if it wasn't co-authored with technologists. So I really encourage everyone to get involved in that if you haven't yet.
Great advice. I hope everybody wrote that down.
Absolutely agree with that. No, I absolutely agree. So we're definitely on the Hill a lot. with our other financial partners, because we see a lot of legislation coming through that is not enforceable because it hasn't been written. And so if you think about the way that Congress and the Senate works, is they're using interns and they're using staffers who are right out of school. And so yes, they're all smart and bright and eager, but they have no knowledge of this industry or any industry. And so we spend a lot of our time actually educating all the time these staffers, because they're the ones that are informing the legislators. And so if you're not on the Hill, you're not talking to these folks and helping educate and being part of whatever lobby groups that are trying to influence, then we're going to be failing.
All right, last question, 30 seconds or less. We'll start with you, Brittany, and we'll go down the line. Is the industry ready for AI to be regulated?
Well, for me, I would rather the industry be ready for technical regulation. I mean, we're all here because we care about confidential computing. We can technically regulate ourselves because law and regulation is never going to keep up with the advancements in this technology. So we have to, be doing encryption down to the hardware level in order for this to work.
Yeah, so I think for me it's about I really need to have, it's very easy to go into one extreme or another, to be super optimistic or don't really like things. I think that, again, it's about, and it's where regulation has a place, it's about trying really to understand what things can do and what cannot do at every kind of stage, and move quickly to match whatever the regulations with what the capabilities. And it's hard because you need to fundamentally change the process. You don't have years to react. This is what you are talking about, self-regulations. But you want to, it's a very fine grain, very fine line between, doing too much or too little. It's difficult.
I think for us, it's a culture shift that we're not prepared for, and actually don't have yet a good framework to help kind of retrain culture, not just in tech, just from a servicing perspective to technology teams, but the business. So I meet with my leadership team all the time, the executive leadership team, and they're asking me like, what training should we give executive leaders, and what this persona and that persona, and they're like, we're going to have an expert persona. I'm like, what's an expert persona? Like, what does that look like? And I think that we're not really prepared to shift the culture that helps you actually get to where you need to get to, and it's moving at pace. And so I feel constantly behind in how do I help shape that culture transformation.
Look, just briefly, I think a hot dog stand has more regulation than an AI company does. So, we've been on the Hill for a couple of years now trying to advocate for transparency, regulation at least, as a starting point. And frankly, the whole world today runs on audits. You can get in an elevator and know that you're not going to plummet to your death because of an audit, and the same is true for airplanes. There's so many other examples in our society. And so I actually would challenge the notion that regulation, just by nature of it being what it is, can't keep up, because auditors are increasingly quite sophisticated themselves. And so if the regulation says the regime is, there's transparency requirements, and that's coupled with external third-party auditors, which are not government, then you can imagine a world where the audit regime, which has highly technical people working inside of it, is the place where this sort of regulatory oversight and the controls get ramped up and move at the pace of the innovation. So I think I'm optimistic, and I really would like to see that go faster.
Excellent. Thank you all. Well, thank you for your time, and thanks. Help me join in. Thank you. All right. Have a good rest of the show.
Thank you so much.
Thank you. Thank you.
Thanks, man. That was a weird handshake. Let's try it again. Oh, wait, hold on, everybody. Hold on. I've got a final announcement wrap up real quick. Okay, so everybody, you don't have to go back to your seats, but just stand still for a second. I'll make it really fast. 4 years ago, Confidential Computing Summit came into existence through our founders at Opaque, Yan, Reluca, Rishab, and others working with the Confidential Computing Consortium to begin this event. I went to the first one. That was my first taste of what was then just a movement. It was full of PhDs presenting research. Over the last 4 years since then, this movement has arrived, and confidential is literally foundational infrastructure required in enterprises, government agencies, and as we've learned, across our personal consumer devices. So it's been an incredible journey seeing how what began as a movement of people who had a belief around it is possible to build verifiable systems, it's possible to build verifiable privacy and security, now has become critical infrastructure. And with that point, I would like to share that the Linux Foundation, who's our co-host with Opaque at this event today, will be taking over the Confidential Computing Summit in subsequent years. So this is no longer an Opaque joint. It's now going to become a Linux Foundation conference. Opaque will still be very actively involved as a top-tier sponsor. It will help with programming, but I'm really pleased that Linux Foundation, which has been such a terrific partner in organizing the 4th annual, going forward will be the steward, the very capable steward of what has already proven to be a very vibrant and growing, rapidly growing ecosystem. So thank you so much, particularly Angela and her team. So go eat, drink, be merry, and go build some cool shit together, guys. Hi.
My name is Olivia.
Hi, nice to meet you, Olivia.
I guess, okay. So Abu Dhabi is here, beautiful city, very close to the super famous Strait of Hormuz. And there is a research center, Technology Innovation Institute, around 1,500 talented people working on applied research. So we don't do papers, we do products. In different verticals, we have centers on advanced materials, AI, autonomous robotics, on directed energy, quantum computing. And I'm coming specifically from the Cryptography Research Center. In Cryptography Research Center, we are around 150 people. That I can confidently say, in terms of size, is in the top 5 of largest institutions fully dedicated to cryptography worldwide. Actually, I only know other 2 institutions that have same numbers, so I could say top 3. Inside this research center, there is a smaller team that is the Privacy Enhancing Technologies team, is the one I'm leading. I think we are around 20 people, maybe 30, I never count them, but sometimes I go to the office, there is a new guy, around 30 people we are. We are working on secure multi-party computation, fully homomorphic encryption, verifiable computation, and identity and access management. Verifiable computation, I'm not talking about TEs here, I'm talking about proof systems, so pure cryptography. No? We have 4 product lines. We have identity and access management. We have a password manager that is based on oblivious to random functions. So it basically leverages secure multi-party computation. We have identification and registration for agentic ecosystems as well. And we have 2 product lines on confidential AI, one with fully homomorphic encryption, another one with secure multi-party computation. This is the one I'm going to talk about today. I'm going to talk about PetalGuard. It's our privacy-preserving federated learning framework. So it's a platform to build AI models without sharing data. So what's the problem that it solves? It's simple. We have different entities. They have data, they want to train a model, and they cannot. Because of privacy regulations, because the data is too sensitive to be shared, it contains intellectual property. Sometimes it's not privacy, sometimes the problem is size. The data is so big that it cannot be moved, it's in a data silo. No? And this is what requires learning, AI learning, to be decentralized. This is what federated learning does. So use cases that we have in UAE, we are in conversations with several companies. One of them is trying to do models for climate change prediction. They have environmental data from different public and private institutions in different companies, in different countries, and we are helping them in doing these models for climate change prediction. The pictures, by the way, are from Abu Dhabi. So as you can see, it's not all sand and desert. We also have some green beyond the golf courses. Also, we have a police department that wants to do model for crime prediction. So like in the movie, Minority Report, same style. And they want to use data from different Gulf nations and Emirates. I think it's an easy task because there is no crime in Abu Dhabi. It's the safest country on earth, except for the Iranian drones. Then we have Emirates Health Services that wants to make a model on predicting no-shows in medical appointments. This is an issue that we have there, in which I actively contribute, unfortunately. But these are just some examples that I put here for diversity, but we are in conversations with other companies to build models, also in the defense sector. So what is confidential federated learning? What is conventional federated learning? FL was invented by Google in 2016. And the idea is very simple. I have an interactive slide that explains how it works. The idea is that you do not move the data, you train where the data is. So you have the animations are visible? Because I don't see them. Huh? Yeah, okay. You have an initial training phase in the entities, then just instead of sending the data, you send these local updates to an aggregator. The aggregator combines these locally trained models into an aggregated model with the combined knowledge and then sends back. And then we repeat this process again and again until we have a model with sufficient accuracy. This is how federated learning works. Intuitively, we are never sending the data. We only send local updates. So we can confidently say that we are protecting the data. But in reality, this is not true. Because now we know that there are very effective attacks that can be used to extract the data from the local updates. So there are membership inference attacks that are highly effective. So conventional federated learning, as it was initially designed by Google, is no longer secure. But if we go to the state of the art, we can find production-ready frameworks for federated learning there. So there are already very good frameworks out there, and they are aware of this issue. So they have to be providing some mechanisms to protect against data extraction. And I have selected two that are the most common ones that I find in literature. You can find it in Flower Framework, for example. You find these two countermeasures. First one is secure aggregation. How this works is there is an initial phase in which entities talk to each other. So they select some masks, they agree on some random masks, and then they mask their local updates so they look like random. They send these masked updates to the aggregator, and the aggregator can still combine them into an aggregated model because the masks are selected in a way that they cancel each other. So they add up to 0. There is even a version in which you can mask the aggregated model and the unmasking is done in the entity, but the concept is the same. The idea is that we make the local updates look like random, and we can do the aggregation anyway. In terms of privacy preservation, this solution is very effective. It's impossible to extract data when we use masking, but there are some complications. First problem, complex client coordination. Clients need to talk to each other. In practical scenarios, when you have thousands or hundreds of entities, not all the entities talk to each other, you have subgroups. But that also means that each entity has to trust all the other entities in each subgroup. So there is a trade-off between trust and complexity here. No? Another problem that we have is that if one of the entities does not submit the masked updates, aggregation fails because the masks do not nullify each other. There are variations in which we can solve this using threshold schemes, but that brings complexity and also a trade-off between complexity and trust. So it's not an easy problem to solve. Another issue that we have with secure aggregation is that if one of these clients sends a local update with a backdoor, we will never know. We cannot run model poisoning detection techniques on masked models. Another issue is that a rogue aggregator can do many nasty things here, and we have no way to detect it. This is the main problems that secure aggregation have, or the main limitations. Another solution that we find in the state of the art and is widely adopted is differential privacy, adding noise. So we can add noise to our local updates, send these noisy updates to the aggregator, and the aggregator adds them into a noisy version of our aggregated model. And indeed, we can add sufficient noise to these updates in such a way that model data extraction is unfeasible. But if we do that, the noise in the aggregated model becomes significant, and the accuracy gets significantly degraded. Applying DP, applying differential privacy directly on the aggregated model is a good practice. The trade-off between accuracy and privacy is acceptable, but using DP to protect the local updates is not. So it's not a good solution. So what we do in PetalGuard is completely different. We use secure multi-party computation because it does not pose any trade-off between accuracy and privacy. We can have both. The main difference that you may notice is that we do not have one aggregator, we have several. I put 3 in this example, but we could have as many as we want. The idea is that we have an initial training phase where we train our local model without sharing the data, like in conventional federated learning. But after that, we don't do masking or noise addition. We do secret sharing. So each parameter is transformed into random cryptographic shares, one per aggregator. Then we send these shares to the aggregators, and they, in a decentralized fashion, they combine them into shares of the aggregated model. Then they can send copies of the shares of this aggregated model to the entities for reconstruction. And then we can retrain again and repeat this process several times, several iterations, until we find a model with sufficient accuracy and we finish the federated learning process. So as you can see, in each iteration, we are never sending local updates, we are never sharing the aggregated model. All the things we share is random cryptographic shares that disclose no information. We have 0 data exposure, end-to-end cryptographic guarantees of privacy, compliancy by design with privacy regulations, no accuracy loss, and it's fully modular and scalable. So we can have as many entities as we want. We can also have as many aggregators as we want, and there is no performance degradation. In terms of accuracy, you can see in the left side, comparison of using MPC and not using MPC doesn't affect accuracy or loss function at all. So I'm talking about performance. What happens with bandwidth? secure multi-party computation is famous for being bandwidth hungry. Each parameter, we have to divide it into random cryptographic shares, one per aggregator. And each one of these shares has to be encoded into an algebraic structure, like a finite field or a ring. That's heavy. So it can be like something like this, scary picture. But we can use, for this specific use case, for this protocol, there are some mathematical optimizations that allows us to send shares only to one aggregator, not to all of them. To the other aggregators, we can send very small random seeds. And with these random seeds, the aggregators can generate all the shares by themselves using pseudo-random number generators. This is very important because now the bandwidth does not depend on the number of entities and aggregators, only on the number of entities. So it scales better. And it's even better than this because we can place our aggregators where the entities are. So we don't need to send any share. We only need to send the random seeds. We have basically reduced the bandwidth to nothing at the time of transmitting the shares of the local updates. Unfortunately, for submitting the shares of the aggregated model, we still need to send all the shares. There is no mathematical optimization possible there. We tried. In terms of security, this solution is information theoretically secure. That's the strongest notion of security that it exists. It means that not even a quantum computer can break it. Actually, not even infinite power can break it. If an aggregator, if an attacker compromises all aggregators but one, the information extracted is 0. The attackers need to control all the aggregators. I know that in this example it looks simple because I have 3, but I can have as many as we want. We can have 100 and we don't degrade performance. The only thing that the attacker can do is to tamper the shares of the aggregated model, but not in a smart way. So the attacker cannot introduce backdoors. It can only do additive attacks. So basically, it can transform our model into something useless. But we would notice. We would see that the accuracy is not converging, is dropping. The only problem is that we would never know who is the responsible, who is the aggregator that has been compromised. If we want to know who is the one that has been compromised, we need verifiability, which we don't have in this basic version of the protocol. In secure multi-party computation, you can have verifiability in many ways. And in Petalgar, we decided to deploy verifiability in two different forms. The first one, we changed our underlying secret sharing scheme for another one called replicated secret sharing, in which we have to increase the size of the shares. So we are consuming more bandwidth. Also, the number of aggregators is reduced to only 3 or 4. Not more. If we go to more than 4, then the share size increases exponentially. And the trust setting also changes. Now, we can only accept one corruption. If we have 2 aggregators corrupted, we can already lose data. It is possible to get verifiability without changing the trust assumptions. But for that, you need communication between the aggregators. You need correlated randomness. And we didn't want to implement that for verifiability here. But it's doable. Another way, easy way to have verifiability in MPC is deploy inside TEs. TEs give you verifiability unquestionable. And the MPC protocol will give you information theoretical security for privacy. And I have been talking about private aggregation, but we want to do more than that, and Petalgar will be capable of doing more than that. We want to do differential privacy on top of the aggregated model and model poisoning detection on top of the local updates without seeing these models, everything operating on shares. For that, we need secure computation. So we need to be able to run functions on secret shares. And we are working on that at the moment. This part is not just yet production ready, but it will be at the end of the year. For that, we require communication between the aggregators, but not communication of private data, communication of correlated randomness. This is something that adds up to the computational overhead, and so it takes more time, but fortunately it can be preprocessed. So you can have a preprocessing engine, like several workloads that are computing this correlated randomness, and whenever the federated learning process starts, you can feed it to the aggregators to speed up the process. This is what we are building up now. In terms of deployment, solution is fully Dockerized. We have a Docker container for the aggregators. We have a Docker container for the training entities. CUDA compatible only. Compatible with any model like CNNs, transformers, LLMs of any size. You can deploy aggregators and entities wherever you want, as many as you want. If you deploy them together, that means that the entities that train do not need to trust anybody because they already control one of the aggregators. We have tested already with LLMs. Our testing pipelines work with Falcon 3. We have also a graphical user interface that is very intuitive. You can configure all the servers. You can configure how is the data pipelines, how is the model that you want to fine-tune, what are the federated learning, the accuracy that you want to achieve in all your iterations. You can follow up how is the training process through an orchestrator. We are distributing through AWS Marketplace. So if you go to our web and click here, that will take us, will take you to our AWS Marketplace. It's listed there. We will also integrate with OPEC platform. So there will be a confidential AI platform that contains confidential federated learning. And as I said before, if you deploy the aggregators inside TEs, you have verifiability without protocol costs. So it's a perfect symbiosis. And that's it. I would just add that we are working now on finalizing the part of differential privacy and model poisoning detection using secure multi-party computation. But at the same time, we started working on a more challenging task that is vertical federated learning. That requires other crypto primitives like private set intersection, for example. But that will be next year. That's it. Thank you. No time.
We still got 1 more minute, so you can still talk. Okay, let's get started. Hey everyone, my name is Eric Bonost. I'm a product manager at NVIDIA focused on confidential computing. My team is responsible for some of the infrastructure software that NVIDIA is building. So as an example, the software in order to use GPUs with Kubernetes, software to use NVIDIA GPUs with hypervisors, and a couple other software. This is my first time at the CC Summit. I'm super excited. I'll say the experience, the technical depth that is presented here is amazing, and I'm very happy to be here. But I'm not the only one that is here, and I warned my colleagues, at least some of them, NVIDIA is confidential computing is very strategic to NVIDIA. So if the NVIDIA people could just raise their arm just to show how many there are. So if you see any one of us in anywhere, feel free to engage us. We do not have, most of us, the green sticker that says, please talk to us, but please do. We're here to network, and we have people from architecture, engineering, security, solution architects, marketing, everybody is here. So feel free to engage us. So having said that, this presentation is going to be about building trusted AI factories with NVIDIA accelerated confidential computing. And I want to start with really that the point that I'm trying to make is AI is useful now. I personally have been in the situation, I think most of us have been, that AI has been cool. We were able to use AI to basically become more efficient in what we're doing. For example, gathering information or learning about something new very quickly because we can ask the AI to explain it in a way that is actually easy for us to understand. To now AI as being useful as it can actually do work for us. Agentic system, autonomous agents are able to do that for us. So we're at this inflection point where AI is useful, and because it's useful, we want more of that. We want to create more useful impact, we want to create more output. And as I think everybody knows, we've heard it here before, right? AI as an agent, right? They reason, that means they think, they infer, and they do more and more and more, and that drives just the request for compute and for inference up and up and up, and that's why we see all this demand for accelerators in the industry right now. So having said that, at NVIDIA we've been basically explaining to the industry, to our partners, to end customers, that we're now at the point where we're building factories, AI factories or agent factories. And we fully understand that a factory is going to be measured, and the measurement of a factory is based on the cost per token. So the more tokens you can generate in a basically defined perimeter of power, right? The more output, useful output you can generate, and the more valuable your AI factory will become. We do understand, and we see it internally as well. It is distributed, so some of the AI will run locally where our most sensitive data, so on-prem, resides. Some of the AI will be in the cloud, in the neo cloud, wherever it may be. And the AI, in some cases, will have to move where the data is, and sometimes we're willing to move the data where the AI sits. Data privacy absolutely matters, right? I mean, I think I'm preaching to the choir here. And security has to be designed in right from the start. If you don't define and build in security right from the start, there's a great chance that your agents will do something that which will make your company or yourself show up in the evening news. And I guess we don't want that. I've said it, I kind of said it already, but I think we've gotten to the point that in the past, data centers were there to help us. They were storing files, they were doing computation based on what we as humans have asked them to do. Now, data centers, not everyone, but conceptually speaking, right? Data centers are creating output. They're running agents. They're doing work for us. So it is important to understand that, right, the more AI output, so the more tokens we're generating, the more valuable output we're taking, the more potentially revenue we as a company are creating. And that is driving huge consumption of, right, compute these days. So when it comes to agents, right, NVIDIA, we've been using agents. We are using agents deeply. Every employee is asked to use agents, right? Try to find out how we can become more productive by the use of agents. And we do that all the time. We learned in our own deployments that once you deploy agents, or you're intending to deploy agents, right, security and trust is an essential role that you need to cover. I do want to quickly share about NVIDIA OpenShell. So if you've heard the recent keynotes that Jensen did, OpenShell was always mentioned. And think of OpenShell as an open source community project that we're engaging to basically manage the behavior of agents. And then, of course, NVIDIA Confidential Computing, which we'll cover during this session. So when it comes to OpenShell, and I'm not going to pretend that I'm an expert in OpenShell, but what I do want to say is when we started deploying agents, it became very obvious that the security that we were applying, the compliance needs, didn't really match to the use of agents. So OpenShell is intending and is helping with managing the behavior of agents and so allowing us to apply policies and enforcing those policies. So think of it this way. You want to make sure that an agent runs in a sandbox, right? Could be any type of different sandbox, right? OpenShell will help with that. You want to apply policies, OpenShell can help with that. So for example, which systems call can an agent make? What part of the file system can it access? What type of network devices or network or remote services is it allowed to work with, right, in order to get data and to be productive? That's what OpenShell helps with, and it's very complementary to all the other software that is out there. All might be a little bit much, but have a look at it, and you will learn more about OpenShell, which is something that we are using internally, and we've seen tremendous amount of interest in the ecosystem of using OpenShell. To be honest, or to be transparent, the interest in OpenShell is unprecedented in the ecosystem when it comes from an NVIDIA, looking at it from an NVIDIA perspective. So many partners are engaging with us in the open community on OpenShell. The momentum is there, and it's tackling a nerve that everybody is trying to solve for right now. So what we did is we created a secure agent workspace reference design. So if you're not, if you're trying to understand, if you're an end customer or partner, how to deploy these autonomous agents, we wrote a reference design that uses OpenShell and some other parts to basically explain how we've done it, and we are constantly updating this reference design to make sure that our learnings are being projected externally. There's a QR code in case you want to learn more. Okay, let's get to confidential computing. Having been here for the first time, right, I don't think I have to explain what confidential computing is. That doesn't really make sense. You know this as well as I do. But I do want to share where we see momentum when it comes to confidential computing. What do we see as NVIDIA when people ask us, where do you see confidential computing being used? Where do you see the interest? And there are basically two primary use cases that have been coming up over and over and over again, and even more with every month that we have that we're out there. And the two use cases are, number one, model protection. Model vendors that have spent millions, if not billions in dollars in creating proprietary AI, right? They want to protect their IP, their model weights, and they do see, very often, the need to move their AI wherever the data sits. And confidential computing is very helpful for that use case. The second use case that we're seeing, not at the same quantity, but the second use case that we're seeing is protect my data. Protect my data so that nobody else can see it, or if I sent my data somewhere, making sure that the operator that is hosting this confidential computing environment was hosting the physical systems, is not able to see my data. That's the second use case. And we see that those two use cases over and over again. I guess not really, not revolutionary, and we kind of expected it. I don't know, but a couple of years back, we had an NVIDIA employee, Phil Rogers here. He was on stage for the keynote. I remember with him sitting in a room roughly 4 years ago. Swanko, one of them, was in the conversation as well. He said the model protection use case is going to be the use case for confidential computing. And the way that we want to do that, not the only way, is through confidential containers as well. And we'll speak about that in a second. So what we've done, and this is kind of preaching to the choir, is NVIDIA is now in its third generation of confidential computing with our GPUs. We had Hopper, Blackwell, and now we've announced Vera Rubin. What we do is we extend the hardware root of trust from the CPU to the GPU through isolation and encryption. Isolation as in virtualization, encryption across the CPU to the GPU, between the GPUs with NVLink, and then put zero trust enforcement on top of it with remote or composite attestation and security policies. We're able to provide model owners a safe landing spot that they can verify to run their models and basically move their IP to somebody else's operated hardware. So one thing that we hear when we are in our conversations with customers is what systems to buy. So what we've done is, and you might be aware already, we've had for many years now a program that is called NVIDIA Certified Systems. The intent of that program is to help end users, customers, make a confident decision about what systems are ready for AI use cases so that they can buy servers that have been tested and validated and with more confidence, choose the right system. What we've done this month, and we're extending it, we've expanded the NVIDIA certification program to include confidential computing testing. So we're working with the OEMs and ODMs, HPE, Dell, and the like, to make sure that they're testing their systems so that confidential computing runs on the system performantly as well. So that should give you as a partner, or as an end customer, a way to quickly identify which systems are capable and useful for confidential computing. Okay, I mentioned confidential containers a little bit, but we see primarily two deployment methods for confidential computing: confidential virtual machines and confidential containers. It's not that one is better than the other, they're just different, depending on the use case that you're trying to see. Confidential virtual machines has been out there for a couple of years. We've seen it in cloud service providers quite a lot, and we partner with them, and we're very happy to see confidential virtual machines grow in that space. What is new, though, is confidential containers. So NVIDIA has just G8, the use of confidential containers with NVIDIA GPUs. The team has been working in the upstream across all the different projects to make this possible. So think of Kata, Trusty, and the alike. So now there's an upstream based reference architecture that, there's a QR code that you can have a look at that allows you now to use your Kubernetes distribution, extend that with confidential computing capabilities to run your models that are potentially packaged as containers today, on Kubernetes easily. So that's new and something that we've heard a lot of demand for in the recent years, actually. So when it comes to confidential containers, I do want to call out one of our partners, Red Hat. There's also a session on Red Hat later today. Yeah, there they are. But the point being is, we did the work in the upstream. We did the work in the upstream, not only us, but the community did the work in the upstream. We were heavily invested in the upstream. And Red Hat is the first partner of ours, and we believe there are going to be many, many more that have a downstream product that provides commercial support for the confidential containers architecture. So enterprises can now run confidential containers with Red Hat OpenShift. Red Hat is, though, not the only partner. We have many partners, And if you know how NVIDIA goes to market, you will know that, we build we build great technology, right? Performance is, right, the DNA of the company, but we work across the ecosystem to make sure that our technology actually ends up at an end customer and is useful for an end customer. We work across cloud service providers, OEMs, software vendors like Fortanix, Red Hat, Anjuna, Opaque, Edgeless, and Equity Labs, but also model providers that are using our technology. That's how NVIDIA goes to market, and we always hope to extend that. So last but not least, I want to speak about performance. In many of the conversations that we have, either with end customers or partners, right, a common question is, what is the performance impact of using confidential computing? So we've spent quite a lot of time in the recent months to speak or to validate the performance impact of using confidential computing. So what I'm showing here is, what we've did is, and we see confidential computing primarily used in inference use cases. So all the data that I'm showing you are inference-based. And we'll share a blog, and we'll release a blog in the near future. But on the left-hand side, you basically can see we're testing on an Intel TDX system, and we're using Qwen 3.5 with the SGLang backend for testing purposes. Now, what is important to note here is you're able to get, right, very close performance to near, right, to non-CC performance if certain optimizations are applied. The optimizations sit within the inference framework, in this case, SGLang. So the performance that we have achieved here is by including performance optimizations in SGLang, and I'll share in a little bit that, right, how we're making sure that everybody gets these optimizations out of the box and that you don't have to worry about it. But also, these optimizations are required because in our current architecture, we're using a bounce buffer. With Vera Rubin, that is not necessary anymore, and these optimizations are not required, and just out of the box, you will get this performance. So what you can see is, right, and with performance, it's always the same, right? It depends on the use case, what the performance is, right? In this case, we're testing with, right, a certain concurrency, and you're basically seeing here, I think this is throughput, yep, throughput per GPU, but you can see that, right, what the performance impact is of CC. Here's another example. In this case, it's again throughput with different input and output sequence lengths, and you can see the performance difference between the two, right? And this is with the performance optimization. So the performance impact is minimal when the optimizations are applied. Here's another example. In this time, it's time to first token. Performance impact is minimal. We typically, right, it's typically in the single-digit numbers, and this is what this is showing. And once we release the block, there's going to be more data so that you can reproduce this. Here's another example with time per output token, very similar. And here's the slide that I do want to call out is, right, as I said, the DNA of NVIDIA is performance. We want to make sure that you're getting the best performance out of our architecture. So we'll optimize whatever we can optimize. So we've learned that there are certain optimizations that apply, right, to having a bounce buffer solution today, right? And we've tested with SGLang as an example. We did the same with TensorRT LLM, right, our inference backend. And what we've done is, with the release candidate, right, and you see the version here in TRT LLM, we already applied all the performance optimizations required. So if you use if you use TRT LLM, you will get the performance optimizations out of the box. When it comes to SGLang or Flash Infer, which is used by SGLang, we have the PRs underway so that the next version of SGLang hopefully includes all these optimizations so that you don't have to worry and everybody gets these optimizations. Now, a question may be, what about VLLM? We are investigating, and we want to make sure that all these optimizations are available in VLLM as well. So we're validating which optimizations make sense for VLLM so that everybody gets these performance optimizations. So last but not least, Vera Rubin. There are three things that I want to call out, and you might have seen other presentations from NVIDIA employees where Vera Rubin was already mentioned. The things that I want to call out about Vera Rubin is, so in terms of performance, as I said, These performance optimizations that I just showed do not apply for Vera Rubin NVL because we don't use a bounce buffer anymore between the CPU and the GPU. We have TDIS. So that's right, that problem is gone. You get the performance out of the box. Number two, with our current architecture in terms of Blackwell systems, the trust boundary was basically right within a system up to 8 GPUs. With Vera Rubin NVL72, the trust boundary is now 72 GPUs. So that positions this system, this rack scale system, ideally right for these new frontier models or these new models that are much, much bigger and need much more compute. And then third, right, we're using TDIS, but the third point is we, with Vera Rubin, the Vera CPU is part of this. So this is NVIDIA's next generation CPU architecture, and that is confidential computing capable as well. So having said that, we have 5 minutes left, and I'm at the end of my presentation. So I want to thank you all for coming here. I hope that was helpful. And as I pointed out, there are there are so many NVIDIA employees. If it's about hardware, security, whatever it may be, we're here to answer any questions. Thank you very much. Okay.
そうすか、普通に。OK。じゃあ、やっぱ取っとくか。そうね。
Okay, so let's start. Good afternoon, everyone, and thank you for having us today. Our core message comes down this one line. The future of AI will be built on global innovation, but it will be governed by sovereign trust. So over the next 25 minutes, we'll show you why Japan is the market for sovereign AI and why confidential computing is the key. So first, let me introduce who we are. So we are a company, a Japanese confidential computing startup. So we are trusted by leading Japanese enterprises and governments, and also we help to lead Japan's Privacy Tech Association and also national discussion on regulations concerned with confidential computing. So today we have two speakers, including me. So my colleague Takiharu, he is CRDO, Chief R&D Officer. He's leading R&D on making TE and Privacy Tech production ready. And I am CFO of this company. So today I will talk about market opportunity in Japan and the concept of sovereign AI. And Takiharu, will talk about technical part and also what the actual market in Japan looks like. So maybe you might have heard sovereign in this summit so many times. So I will quickly review the concept of sovereign AI, and we will focus more on what the Japanese market looks like. So today, before going into the details, so here's our thesis. So 3 beliefs that frames everything that follows in this session. So first, redefining sovereignty. So sovereignty is not about ownership, it's about control of trust. So a nation does not need to own every chip, every cloud, every model to be sovereign. Rather, it needs to control how trust is established over them. And second message is how trust can be earned. So not a promise. So in a sovereign context, just trust us is not good enough. So trust has to be something that anyone can check. And lastly, third message is with the right trust layer in place, Japan is very wide open. So a largely untapped market. So these are 3 messages we want to tell you throughout this session. So let's start with the global picture. So sovereign AI is no longer a niche policy idea, it's now a global agenda. So governments are framing AI and data as pillars of economic security and national strategy. So in Europe, France is backing Mistral AI as the continent's sovereign frontier model. And Canada has committed $890 million to investment into a sovereign AI supercomputer. In the Gulf, the UAE is building Stargate UAE, a national-scale sovereign AI data center. And lastly, Japan. So Japan has its first national AI plan with around 70 billion investment into AI infrastructure. So please notice what shifted. So previously, the question, so how powerful is the model? It was very important, but now it's where and under whose control does AI run? So this question really matters. And this is what this whole talk is about. So why do we need to pay attention to Japan? So Japan is what I would call a premium trust market. So huge demand, the world's strictest standards for trust, but crucially, the most valuable data is still locked out from AI. So look at the funnel. So Japan's cloud and AI market size is expected to reach around 120 billion by 2029. And about half of this sits in regulated industries like healthcare, finance, and public sectors. And what's important here is the most of the data in regulated industry is still locked out from AI because the data is too sensitive to handle in cloud or AI environment. So assuming that 50% of data is still locked out from AI, so 30 billion market exists. So what is important is this 30 billion market is not a market someone has already taken. It's completely untapped market. So this is the illustrative but rough estimation of the market size sovereign AI can finally reach. So the demand is here, but the real question shifts to, so what does sovereign AI actually require? So sovereign AI isn't one thing. It's built from 5 components. So computing, infrastructure, model, data, and governance. And when you look at this, so you might think, do we have to need all these 5 components domestically? But so I'd like to ask you, so is it realistic? Or so does every component need the same level of sovereignty? So actually, the answer is no. Sovereignty is not self-sufficiency. So sovereignty is control of trust. And this means different components call for different postures. So sovereignty has a gradient. So computing, infrastructure, and model, for these, you should leverage globally. So the best chips, best clouds, and best models should come from global supply chain. But data is somewhat different. So data is what you should protect domestically. And governance, this is the trust layer, and it's where accountability lives. And this is the true locus of sovereignty. So you don't achieve sovereignty by owning everything. So you can achieve it by controlling the layer of trust. So that is governance that sits over everything. So then, what control of trust actually mean? So control of trust means guaranteeing 3 things: confidentiality, integrity, and availability. So confidentiality means unseen, so no one can see the data inside, so even the cloud it runs on. The integrity, so this means untampered. So what runs is probably the real thing, so not as untampered. And lastly, availability means unstoppable, so it cannot be switched off by someone else's decision. And here's the important split. So the first 2, so confidentiality and integrity, so these can be solved by technology. But the third one, availability, cannot be solved by technology, but by a choice. So let's dive into how we can guarantee the first 2 things, confidentiality and integrity. As you know, the answer is confidential computing. So when you look at the sovereign AI technology stack, chips and cloud at the bottom, and the model at the top, and the trust layer, so middleware in between. And this trust layer corresponds to confidential computing. So this is a technology that keeps data and AI models confidential. So this is what a title built on global innovation and governed by sovereign trust means in practice. So we can use whatever chip, whatever cloud, and whatever models. But the so control of trust, the governance, so this is a layer that makes all of these components safe to use on sensitive data. So we should secure this layer locally. But how does this technology work to secure the data? So for that, let me hand over to our Chief R&D Officer, Takiharu. So he will talk about technology part and also what the actual market in Japan looks like.
Thank you. Okay, thank you for Shuzo. I'm Takiharu. I'm a co-founder of a company, and I'm start to talk about how to achieve this sovereign AI. And okay, so many of you already know about the confidentiality and integrity by achieving confidential computing. So, but the left side is confidentiality. So let's start with the confidentiality. So it means the computation runs inside a TEE, so keep data in safe, even while it's used. And not even the cloud provider can see inside. Even an attacker with full admin rights cannot read it in memory. It's instead encrypted. Now, the right side integrity, the TEE makes the signed proof. It shows exactly what code is running on the real hardware. And the user check this proof before sending any data. It's remote attestations. And if the code was changed, it's tampered, the check fails. And the data is never sent to this kind of environment. So these two hard problems are already solved by the confidential computing, but it's lead to the deeper questions. The question is who verify the verifiers? So here's the problem. So if the attestation process is a bit critical to achieve the sovereign AI, but the verification process is, if the verification process is closed, then this process cannot be trusted, right? So if we need the solution for open verifiability. So if the verification process is open, then the remote attestation process can be truly verifiable. So we launched the open source remote attestation softwares. So this is called human attestation, and this is much easier to use the remote attestation than ever before. So, and this open source software is the permissive, so it's very easy and free for anyone to use this in your own product or your own solutions. And also, this technology covered with the major TE technologies such as Intel SGX, TDX, and AMD SCB SNP, and NVIDIA confidential computing, and AWS Nitro enclaves. So the QR code is a direct link to our human attestation open source software project page. So if you have some interest, please go to this page. Yes, please. And another situation is the sovereign AI is real in Japan right now, from the chip to the model. So Japanese companies are moving fast. So our trust layer connect them all. So we are the middleware layer. We given the middleware layer in this sovereign AI in Japan. So at the model level, we land the NEC's models. Cotomi is an AI large language model in Japan, and inside the confidential computing environment. And the cloud level, we made a Japanese cloud confidential computing ready. This is Sakura Internet. And the chip level, we are working with the Fujitsu. Fujitsu is making the Japanese processor. It's a Monaka. This Monaka processor is capable with ARM confidential computing architecture, ARM CCAs. So yeah, Fujitsu now plans in 2027 to launch the new CPU. It's capable with ARM CCA, and this is very important. So it is a made in Japan chip with confidential computing built in, and we are working with the Fujitsu to grow in a confidential computing market in Japan. And second one is NEC's Cotomi things. And we tested NEC's GenAI models, Cotomi. It ran with both AMD's SCB SNP and NVIDIA confidential computing turned on, and it worked. And everyone asked the same question is that what is the cost in performance to turn on the confidential computing? We measured its time to first token measurement. So this result was at most about 10% slower than the normal environment. But for more real workloads, this is a very small price for fully confidentialities. And the third one is Sakura Internet. So Sakura Internet is Japanese cloud platformers, and we tested their Xeon CPUs in H200 GPUs, and we turned on the confidential computing feature in their environment, and then we learned the remote attestations on the real AI workloads inside the TE. So this is the full stack. So confidential GPU and a confidential CPU, and verified on the Japanese cloud. So they are building blocks. So, but the next one matters most because it is not a lab test; it's in the productions. So this is a strategic partnership with the KDDI. So KDDI is a Japanese telecommunication company, and also is a Fortune Global 500. And the data, they hold the data with personal data with 40 million users data. And we process their data inside the TEE in the production levels. And also, we have another project that is national security, but the details are classified, but I only say that this only. So we're trusted by the highest levels in terms of confidential computing in the production levels. So let me show this one, KDDIs. So yeah, this is already running in the production levels. And the KDDI LAN is data collaboration platform on our data clean room backed by the confidential computing team. And it takes their data from 40 million users, the location data, attribution data, purchase and post data, and then it combines this with the partner company's personal data, and all inside a protected environment. And the raw personal data is never shown to the other side. So this is a very key point. And the output is like a statistical results or AI training or AI inference. And without the confidential computing, this data could never be brought together. So, and this is not just a demo. It's create real revenue, and the combined analysis helps KDDI find the new customers and improve its store strategies. And we will go deeper into this use case in the next sessions from 4 p.m. at the Gold Ballroom. So if this caught your interest, please come and join us. Okay, so the final slide is this. The trust layer is already, but to complete the Japanese sovereign AI ecosystem, 3 gaps remains. So the first one is confidential computing is still not well known. So to the leader here, please market this category with us. So let's grow it together. And the second one is the confidential GPUs are not still available in Japanese regions. So to the cloud and data center providers, please offer confidential GPU in Japanese regions. And the third one is there are very few frontier model providers in Japan right now. So to the model providers, please host your models in the Japanese regions. So the chip, the cloud, model, if we close these 3 gaps together, then we complete ecosystem, sovereign AI ecosystem, and the $30 billion market open for all of us. Okay, so thank you for listening. So if we have some interest to the sovereign AI in Japanese market, so please come to join us to talk with more deeper. Thank you.
Chaka Khan. Chaka Khan. Great. Thank you all for joining us on confidential computing in the emerging regulatory landscape, from optional control to compliance simplifier. I am joined on stage with two people you probably have already become familiar with, but just in case, why don't you guys kick off by doing introductions? Mark, you go first.
Okay. All right. Thank you. It is my favorite jacket, actually.
I love it. It's a beautiful jacket.
Yeah, so I'm Mark. I run product and go-to-market for Anjuna Security. We're a company that helps enable very frictionless confidential computing. But I'm also the co-chair of the Cloud Security Alliance Confidential Computing Working Group. And so that's an entity you're probably familiar with. The Cloud Controls Matrix comes from them. We do work to educate the industry and also sometimes influence regulatory controls frameworks as well. Brittany.
Hi, everyone. My name is Brittany Kaiser. I'm the CEO of Alpha Compute, NASDAQ ALP. I am also a data rights activist that sits on multiple U.S. congressional committees on fintech, digital innovation, technology, and ethics. I've helped co-author over 60 different bills that we've passed in the U.S. on data protection, privacy, and digital asset ownership. And I spend a lot of time in Congress, so excited to dive deeper into regulatory topics.
Great. So let's start off with, why are regulators beginning to focus on protecting data while it is being processed rather than only at rest in transit? Brittany, you want to go first?
Well, it's because finally our legislators and regulators realize that they have to get a little more technical in order for legislation to actually be implementable. Over the past decade, I have spent probably tens of thousands of hours with legislators and regulators, really getting into the definitions of not just data, but how all of these technologies function and what are all of the risks at different parts of the data processing cycle. And a lot of the legislation that started to be passed about 8 years ago, like GDPR and some of the early privacy acts in the United States, were not actually technical enough in order to have a technology solution that would allow you to be compliant. And I think that has been one of the biggest issues that I have dealt with over the past decade, really working with legislators and regulators, is how do we work more closely with technologists in the space that can really get down to the bottom of how the data processing functions, so you can identify all of those risks and make sure that the law actually addresses each of those items. And whether it's just going to be legislation or it's going to be the way that regulatory bodies look at this or standard setting, we need to make sure that we get as technical as possible so that we can actually protect end users.
Yeah, I would comment too that there are some regulations that automatically require you to have data in use protection to some extent, but it doesn't tell you how, typically. GDPR is one of those. It's the privacy of processing, and then we've got all sorts of data minimization requirements. There's others like PCI DSS that was always about processing data, but it doesn't explicitly call out protection of data in memory unless it persists. So there are clauses in PCI DSS that specifically call it out. But I think one of the things that I want to sort of surface here, we've got some slides, if we can just bring up the slide deck up here. So one of the things that I track as part of both the CSA and my job at Anjuna is to look for regulatory changes and mentions. And so one of the things we have, by the way, is a call to action for each and every one of you. Don't wait for regulations. Be a part of the process of helping them get there. And so we'll talk a little bit about that in a second. But if you look at this chart here, so this is a kind of a survey that we did, which was the kind of the mentions of trusted execution environments or data in memory. Basically 5-6 years ago, nothing, just trickles of information there, and in some of the latent regulations like GDPR, PCI DSS, etc. But I don't know why I do this, but I sit there in the evening scanning for regulations. How boring is that sounding? But it's actually pretty exciting when you're in our industry. But we've seen a rise of mentions of trusted execution environments, secure enclaves, data and use protection, privacy enhancing technologies, and all of these kind of fall into that same bucket. And so to your point, Aaron, about why do we need this? I think the regulators usually respond to industry issues. And I've got an example of one of those coming up just to kind of show you this, that's from NIST. But at the end of the day, we've seen continued attacks to systems. Despite all of the software rings we apply around software, around critical software, the attacks persist, and the regulators pay attention to that. And so even with regs like GDPR, which says use state-of-the-art technologies, we've seen regulatory mentions of TEEs and so on just keep on rising. And so what you need is a foundation of standards, which then is referenced by the regulatory bodies, and then the enforcement. And I don't think there's any reg that's going to say, use a TEE or else, but they will certainly imply you've got to start thinking about data and use protection because of the kinds of risks that are there. So I think there's a really interesting trend, and we'll continue to see this go up. To me, this is signals for organizations to be ready. So get ready with confidential computing and technologies like it to be there when the regs do hit, because otherwise that point is just too late in time.
So you mentioned GDPR, and one of the interesting things around GDPR and TEEs is that there was a recent change in Sweden, I think, where it requires processing of GDPR data inside of a TEE. So I expect we'll probably see more of that proliferate.
Yeah, well, Sweden has always been ahead of the curve. Sweden was the first country to have a government cybersecurity certificate, a standard that was set by the government. And you could go through a program in order to get that certificate. And if you were a company, you got the golden stamp of approval from the government saying your data is safe with these companies. So of course, all of the companies that got those first cybersecurity certificates were booming with business because all of a sudden there is some sort of trust standard in how organizations are dealing with data. And I've done a lot of cybersecurity trainings and data ownership and privacy trainings with the Swedish government. I go out there all of the time, and they really are leading. We actually have loads of GPU deployments that we're doing in Sweden at the moment, which we're very excited about. And I think a lot of people in the Swedish government have really, really focused on making sure that they can be a thought leader in data protection and privacy. And this absolutely didn't surprise me when they put that forward.
There's also the Swedish chef. Let's recognize him. Björk, Björk, Björk. Which emerging regulation standards or industry frameworks are most likely to accelerate adoption of confidential computing over the next 3 years?
So I've just happened to have a slide on that one, Aaron.
Fantastic.
So again, part of this kind of the monitoring of what's going on, the TEE mentions, we often get asked, hey, why aren't there regs that could kind of really drive towards this? Well, there are emerging, and some of those conversations are in the United States. If you look at, for example, DoD zero trust architecture guidance, confidential computing, isolation mechanisms are referenced there. NSA brought out guide recently on the version 2.0 for zero trust, again referencing trusted execution environments. It doesn't go into the details, but it's that first stage of recognition that this kind of technology is an acceptable control mechanism for mitigating risks and to implement strategies like zero trust more broadly. So, that we won't go into them here. There's the Sweden one on there, the IMY, which is a great shift.
You're so prepared, Mark.
Indeed. But there's two here that I highlighted as for kind of examples of where things are starting to emerge. So. Just recently, in the last month, ETSI, which is the European Telecom Standards, I can't remember what it is, the ISE Institute, yes, brought out a kind of an early stage guidance for confidential AI. And in there, it actually goes into quite a bit of technical detail about the instrumentation of trusted execution environments to provide isolation and trust guarantees. Now, that's a standard, it's not necessarily a reg, but again, it's that recognition of frameworks in industries where risk, compliance, complexities of managing attacks needs to be upper level than where it is today. So this is a kind of a sampling of kind of mentions of data and use mechanisms. Some countries are quite ahead, like the UK, for instance. The US has certainly been active too, and there's a couple of examples of the NIST ones I'll show a little later today as well.
By the way, we have Anna Tallis from the European the author of GDPR and EU AI Act, who's going to broadcast in at the closing session some words about regulation. I reached out to her, and she was unfortunately committed to speak at some governmental event and couldn't make it in person. And she'll be zooming in though from at the closing. So next question.
I haven't seen her in years.
Well, I just met her, and she was very lovely. So Ken, Confidential computing reduces compliance complexity by satisfying multiple regulatory requirements through a common control framework.
I think the answer to that is kind of a yes, but it's also a yes with an asterisk on it. So the way I kind of look at this is many of the regs here often revolve around data minimization, right? So try to avoid collecting information, which is in direct contrast with the AI agenda of most organizations, which want to vacuum up every single piece of data and somehow monetize that. But if you look at things from a regulatory controls perspective across most kind of mechanisms for isolation or minimization, what it tends to come down to is, number one, about kind of the data, and there's things like consent in there as well, obviously, from a privacy perspective. But from a technical controls perspective, even if you look at something like PCI DSS, the way you assess the environment that's in scope of PCI is to look at things like the network segments, the presence of cardholder data, or the systems that can process and access that. And so we've taken a view for many years of putting scope inside an area where it might be a boundary around a network. Now, with confidential compute, you can shrink that boundary to the processor. So all of a sudden, you've taken a lot of this other stuff out of scope of potential regulatory compliance. And that's actually where the value is. You're not eliminating everything, you're shrinking the footprint of the things that you have to worry about. So instead of worrying about an adjacent system that happens to be right next door on a compute plane that's open, that is accessible, which would be in scope, and therefore you have to have 256 different controls in order to meet compliance, you can basically say, look, this is the domain that's in scope, and I can prove that. And the beauty of confidential computing, it lets you attest to that. It's not just sampling and providing a document and a point in time. You can prove it, and then on an ongoing basis, keep proving that. So there's work still to be done to bring the kind of regulatory bodies and the assessors who actually look at the compliance frameworks up to speed on this stuff. But I think we've started to see a groundswell with this activity here, which is very encouraging.
Yeah, absolutely. I would completely agree with that. As I'm engaging with different types of regulated industries, from finance and banking to healthcare to government and military, I'm seeing more and more that the demand for confidential compute is really to reduce risk and make compliance so much easier. Exactly as you said, you're reducing the amount of risk vectors because you are fully technically and mathematically provably owning all of your data and not sharing it with third-party systems, where then you need to think about, well, is it tens of or is it hundreds of third-party systems that actually get access to this data throughout my stack? No, it's 100% yours, and you can show that and attest to that. So I think, you know, especially for HIPAA compliance and for military purposes, and I'm seeing this with a lot of big banks that haven't even implemented AI yet because they literally can't get it approved by their compliance departments, that if they are starting to experiment with trusted execution environments and confidential computing, that all of a sudden they're able to use AI for the first time because it's the only way that they're able to get that type of approval internally.
So I think most of this just gets automated. And what I mean by that is what I observe is we're enforcing policies as code at the workload or agent graph and the container. So I'm sure most people know what I'm talking about who are here. Enforcing policy as code that are contractual terms, there are frameworks for this like ORDL that you can implement contractual terms as code and then provide hardware tested verifiability of those policies being enforced. So the thing I'm saying is I think most of this policy compliance complexity gets automated away because we can embody it as actual code that then goes through the attestation process and produces a cryptographic measurement. And then like for opaque, and I'm sure Anjuna does this with your new watchtower, I'm sure, where you can output, you could emit like, oh, well, here's all of the controls that have been cryptographically enforced inside the runtime for a particular agent. It's a natural step that Anjuna's watchtower opaque agent control with our confidential core would emit proof of the policy's enforcement that were contractual requirements, for example. It's just a natural step.
You're getting to the point where you have to use automation and AI to keep a grip on this because the scale and the volume and the complexity is high. You know, if you look at even just this, right? So if you're an enterprise, this is just a very small sampling of regulatory bodies that probably have several different control frameworks that need to be then instrumented. And then you've got the business level contracts on top of that. How could you keep on top of that just with a human? So it absolutely has to be. And then you've got to think about, well, how do I trust that?
Yeah,
So
especially if you have, it's not just
challenge.
about the humans that are executing and touching things that would be governed by specific policies. What happens when you have swarms of tens of thousands of agents operating at machine speed, being able to process, petabytes of data in a matter of minutes or hours, right? That's when you have to automate this, right? And good news is we've got like DSLs. You can actually map a human language and contracts into policies that gets turned into code and then goes through an attestation from a cryptographic root of trust in the hardware. Brittany,
Yeah,
go ahead.
absolutely. I mean, in the end, this conversation in the age of AI is about permission structures. It's not about data minimization, because in the end, these systems want as much data as possible. So it's how do we secure those permission structures? How do we know that data that is not supposed to be shared with other parties or into different parts of the system is not being shared? How can you prove that? It's one of the reasons why I've worked on smart contracts and on decentralized technologies for 15 years, because smart contracting and being able to have self-executing contracts where you know exactly where the data is going and where you can, when it self-executes, the data is no longer accessible. That's something that confidential computing also allows similar types of mechanisms where you can prove that the data hasn't gone where it's not supposed to go. And for compliance and auditing purposes, I mean, as a public company or in any other regulated industries, this is just absolutely essential.
How are AI governance, data sovereignty, and third-party data sharing driving new interest in TEEs and confidential computing?
I think we've covered some of that. I think it comes back to that kind of scale problem, right? So, one of the things we've been looking at as well, and it comes back to kind of what you were talking about with, what can you govern? When you actually look at what goes back and forwards from agents to LLMs, there's the things that you control, like prompts and stuff like that you have visibility into, but there's a whole gamut of other things that happen behind the scenes that you don't. And it's sometimes kind of shocking what data actually ends up, even in just an LLM itself. So first of all, you've got to ask the question, well, how do I stop having things that I don't expect going into environments that I don't control and still have the capability to have the mission complete, the LLM still providing that kind of value. So that's kind of one issue. But then there's the question of, okay, well, what about the LLMs themselves, the services? What am I putting into that? I think there's a general mixture of both massive hope with AI and also massive fear. And we're in that sort of V-shaped kind of area which we have to solve for in order to completely unleash it. So there's a very natural pairing between making AI fully scalable and meeting the needs of enterprises and also meeting the needs of privacy from a consumer perspective.
Yeah, I completely agree. I mean, I'm a techno-optimist. I do believe that we're building these systems to vastly improve everyone's lives and make everything more efficient. And like the late, great Dr. Stephen Hawking used to say, we build technology to live in luxurious leisure. And what he meant by that is the technology is supposed to do all the grunt work so we can concentrate on our passions. But if we don't realize the negative consequences of what these tools can possibly cause and reduce those risks as much as humanly or technically possible, then we can, be in quite a mess. And I've experienced that myself in the past. So in order to reduce data breach risk and lack of compliance risk, and in general doing damage to our clients and end users, we need to make sure that we are implementing confidential systems where we have mathematical proofs that we know that nothing is being done with the data that we didn't want it. It's not getting in places where it shouldn't be. And in the end, overall, that means we're going to be able to do more and more experimental and exciting work with these technologies because we will be able to get it approved by compliance and implemented into our daily lives.
We have more questions here. Are there any specific ones you guys want to ask, or can we open it up to the audience to ask some questions?
Yeah, let's do that, because I think we've covered a few topics.
And I will give you prizes if you ask questions. I have cool prizes for you if you ask questions. So I'll ask one more question just so that you can get together your thoughts and courage to raise your hand, and I'll walk over a mic. How does agentic AI change things for organizations?
Yeah, I think we've touched on that a little bit, but there's this. It comes back to that sort of dilemma. You've got massive pressure on organizations to tap into agents and the power. You've also got the kind of the dilemma, which is, hang on a minute, there's all sorts of the security risks that we need to think about that are completely new because of the non-determinism and so on and so forth. we've started to see, organizations like NIST start to address that. In fact, this standard that's actually in public comment period was all about, it was driven from the risk to the kind of some agentic breaches that took place. So this is a reaction from NIST to kind of token theft, which is just all about access control at the end of the day, but it becomes an even more problematic scenario for agents. So what I loved about this is that I saw, the deck that and the presentations that NIST produced were about the origins, mentioning agentic security risks, but bringing confidential computing to the fore as a control for at least managing things like credentials and keys and so on. It's kind of like good bread and butter stuff, but it's the first time I'm seeing confidential computing being mentioned as a mechanism. And NIST are also saying, efforts are underway. Look, keep an eye out here because we're going to be talking about this agentic problem. And so we've got a standards body here really leaning in on this. So it changes the game. It has to happen quick though, because otherwise industry is just going to move on and do whatever they can to make this happen.
Yeah, I've already seen organizations and individuals, especially implementing AI agents into more and more sensitive data sets. And so we're seeing new types of security risks that have never existed before, where you have one system that has access to absolutely all of your data sets, both for your commercial life as well as your personal life. And when you're having everything from private messages to emails to all of your public presence and public and private communications for work and for your own life, all in one spot, you can imagine what that actually looks like when your agent falls subject to malicious prompting. So I think we're seeing much higher security risk and breach risk than ever before, and therefore I'm not surprised to see that NIST is suggesting confidential computing as a way to actually think about what is the standard to make sure we can protect people when implementing these technologies.
Great, we've got a question from the audience. Start with your name and your hometown.
Yeah, good afternoon. This is Venkat from Dallas. Yeah, it's a great conference. Thanks for organizers and Linux Foundation and Opaque and Alpha Computing. My question is there any collaborative confidential computing or the roadmap to where major players or globally where they could benefit from? You see a lot of standards, right? On the previous one of the slides, standards all over. For example, since I work in financial space, we work on GDPR, and then recently even RBI, Reserve Bank of India, protecting their customer data. And I was in AI Summit in Delhi last Feb, I think. Yeah, it was in Feb, and largest conference, and all big weights were there. So how does in general, the simple question is, collaboratively, we win or protect the data at large, globally? Is there any roadmap that you see happening?
You guys want to jump in? I mean, I could we made some announcements. I'll start with that. So yeah, I think that you see how everybody individually, within large tech, have built their own stacks and policies and enforcement to enforce and verify this inside large tech companies, or inside large financial services companies are kind of rolling their own. I think that the next stage here is how do you create interoperability between these and standardize these, which is why Opaque released Agent Trust, which was a collaboration across Microsoft, Anthropic, Intel, NVIDIA, AMD, and a bunch of others. And we should work together to determine, hey, how do we make these governance rules, how do we make verifiable governance portable so that you can have a portable record that you can examine before distributing a workload or sharing data? So there's absolutely work underway around that. Like Agent Trust is one governance record that's portable, which all it does is take a bunch of existing standards like Skit, Salsa, Eats, a whole bunch of stuff, and then package it into an envelope that then anybody could process and use as a passport. So I think that's probably the highest impact area right there, is breaking down the walls where individuals are rolling their own stacks and making it portable. But Mark, Brittany?
Yeah, there's other ways to collaborate as well. As on the standards themselves. So that, the samples of the bodies that I mentioned there, these are still very early stages in many cases, right? It's often a technical standard that then has to be incorporated into a regulation. I'll jump ahead, there's a couple of examples of those, but, for example, the CCC, the group that's sponsoring this event, also has collaborative working groups for governance, risk, and compliance. And the purpose of those is to influence standards bodies as well. So I would strongly encourage getting engaged at that level, which is all about really kind of very vendor neutral approaches to kind of collaboration on enablement standards. There's the Cloud Security Alliance too. That's the group that I chair. We're producing technical documentation and white papers on
How'd you get
education.
the slide done between him asking the question and you like?
Yeah, I know.
What the hell, man?
This is what AI does for you.
This is amazing.
Exactly.
And then also your accent is so authoritative.
Yeah, I'm
Please
actually
keep going.
originally from New Jersey. I learned this accent.
Like a proper English accent. Keep going.
Right. But, again, there's work on things like open source, but then there's the actual organizations that can influence standards group as well. So, if anybody here in the US also wants to comment, there's an open comment period right now with NIST. I'm not representing NIST here by any means, but it's one that's worth looking at, which is again, a kind of a technical guidance on confidential AI. The public comment period is open until July the 13th. And it doesn't have to be you analyzing it and saying, hey, I'm critiquing this particular attestation thing, this register's wrong. It's not about that. It's about just saying, this is so important for industry. We fully support this as a company, and putting those letters to NIST, and there's a process for that, because that's the groundswell that then drives the adoption and further investment, because NIST then sees signals from the market. So that's really, really important.
I'd also say that some of the most interesting collaborative projects that you can get involved in to be a part of this roadmap are more on the technical side, not just legislative, regulatory, and standards. We at Alpha Compute invest a lot in open source R&D. I'm a huge open source advocate. There are tons of open source projects where you can get your team involved, jumping in and making commits and doing GitHub pushes and actually building out some of the interoperability and accessibility of confidential computing. We are actually listing a lot of those projects on our website. Besides Alpha Compute, I'm also the founder and president of the Open Source AI Foundation. We're a 501c4 based in Washington, D.C. And so we advocate for the use of open source as the main way for a lot of these problems to be solved collaboratively. So we'll definitely be listing those, so you can check on our website for that as well, and for things that you can get involved with.
Cool. We've got 1 minute and 27 seconds remaining. What evidence or assurance mechanisms do regulators need to trust confidential computing as a compliance control?
Firstly, they need to be educated. So, it's not always about the technical piece. If you look at the kind of the level of education of confidential computing is tracked with that compliance curve of mentions and so on. So I think we're getting much, much better about that knowledge, but it has to then translate down to the people on the ground that sign off on whether it's an automated report or a manually generated one. So I think part of the challenge is just the education piece on this. That's why getting involved is actually important, and spreading the goodness.
Yeah, I completely agree. It's education and awareness, and unfortunately, some of this is generational. We did not grow up being taught how technology functions, just how to use it. And so I think this is going to take, 5 to 10 years before the entire world actually understands some of these concepts. But unfortunately, it's going to be over the next few months where everyone's touching AI. So that's an incredibly dangerous gap. And so I think making confidential computing as accessible as possible, as quickly as possible, where it's invisible in the back end and people don't need to know to ask for it, is one of the main things that we should all be concentrating on doing.
Okay, thank you guys so much for your time. And Mark, thank you so much, because you audibled and jumped on this, and you were just terrific. I mean, hell, you had all these great slides put together. It's a miracle.
Amazing.
It's amazing.
Yeah, just if anybody wants a copy of the report, let me know as well. That's just a survey
Yes,
of industries.
please.
Yeah.
And what's your phone number, Mark? They can call you.
555-555.
All right, thank you so much, everyone.
Thank you.
Hello, hello. Can you hear me when I talk at this volume? Cool. All right, I'm assuming I can get started? Cool. All right, hi everyone. I'm Arthur Savage. I'm an employee at Red Hat on our emerging technology security team, and I am here to talk to you about post-quantum cryptography. All right. Yeah, there we go. Cool. So I have a lot of slides and not enough time. So can I get a quick show of hands? Raise your hand if you know nothing about post-quantum cryptography. Okay. That's good news because I'm going to have to go pretty quickly through the basics so that we can get to the confidential computing specific stuff. Cool. So let's get right to it. I don't have to convince anybody in this room that cryptography is important. It's in everything that we do in the internet at large, and especially in confidential computing. And the crux of the problem is that classical asymmetric cryptography can be broken by a large quantum computer, which means that all current classical cryptography has to be replaced with a post-quantum equivalent before Q-Day happens, Q-Day being the day that a large quantum computer exists. And we don't necessarily know when that will be, although we have some estimates. And let's talk a little bit more about that. So quantum computers, because they are non-deterministic by nature, they can leverage non-deterministic algorithms. Specifically, Shor's algorithm is the one you'll hear a lot about because it can factor prime numbers in polynomial time, and prime factorization being the algorithm that, or the hardness problem that underlies things like RSA, elliptic curve cryptography. So this is a pretty big deal. And that opens up several quantum attacks. The one that gets the most press, I should say, is harvest now, decrypt later, because as an active attack. Obviously, digital forgery is still very important and needs to happen on a similar timeline just because it may not be an active attack, but the migration of digital signatures takes longer. So that means that it has to happen now, basically. All right, and I won't go too much into the different types of quantum computers. The two that I want to point out are superconducting, which is the most common quantum computer in production now. They're on the smaller side, around 100, 200 qubits-ish usually. But the most up-and-coming one is the neutral atom quantum computer. They are the ones that are scaling up more rapidly, but they do have some drawbacks still. So. All right, so now we're getting into the what do we do about it. So here I've just listed the algorithms. On the left side, you will see a short list of vulnerable algorithms. It is not exhaustive, but you can see these are very common. And the secure algorithms. So lattice-based cryptography is most of what is intended to replace classical asymmetric cryptography. We'll talk a little bit more about that later. But there is some current cryptography that is thought to be secure against quantum computers, and that includes symmetric cryptography and block ciphers like AES. Cryptographic hashes also remain robust against quantum computers. It's very good news. And okay, so who is deciding which algorithms we use? So the NIST has run a competition to develop these new algorithms to standardize them as FIPS documents, and the two lattice-based algorithms, MLChem and MLDSA, are the primary ones that are being integrated. So that's FIPS 203, FIPS 204. You'll see them a lot in this presentation. There is also CNSA 2.0, which is the suite of algorithms that is allowed for United States national security software. It's a little bit more restrictive. And again, you'll see that this is a very US-based perspective. There are other algorithms competitions, other standards in other countries. I don't have nearly enough time to talk about them, so if you have any questions about your specific locations, you can talk to me after. I'd love to chat about it. Right, and like I mentioned, so MLChem and MLDSA are the ones that are being most widely deployed, with MLChem intending to replace key exchange, like asymmetric key exchange for networking purposes, and then MLDSA, which is the digital signature algorithm. And there are others there. Hash-based signatures are less widely deployed because they have some drawbacks, and there are more algorithms coming up in the future. Right. So CNSA 2.0 matters a lot for highly secure systems and also for open source. This alphabet soup can kind of be distilled into you need the highest strength of every algorithm that is allowed. And algorithms like SHA-3 are restricted in use, which means that these algorithms are not technically allowed for use in national security systems, and they are used frequently in confidential computing. They are not necessarily vulnerable. It's a little bit of a subtlety there, and we can talk a little bit more about that later. Right, so you get conspiracy Charlie here because this is how I felt putting together these timeline slides. Because there are some well-defined regulatory timelines, and then you will see that there is an industry acceleration that is kind of moving faster than that, and there's a reason for that. So let's get down to it. So the original CNSA 2.0 was released back in 2022, and it had an updated version released December 2024. So this timeline is from the updated version. And there's multiple milestones for it, but the kind of crux of it is all software to be quantum resistant by 2035. But when we look at industry timelines, you can see that that's happening a lot sooner, and companies aren't choosing to take on extra work for no reason. So yes, and this is also an extension of that. So this happened less than 2 days ago. So this is pretty new to me as well as to everybody. But there is also an additional acceleration of US government federal PQC timelines. And this applies beyond national security software, but also to all federal systems and contractors. So it has pretty wide-reaching implications. And you will also see that the timeline 2030, 2031 is sooner than CNSA 2.0. So what we're seeing is that CNSA 2.0 hasn't quite caught up yet to what we're are seeing from executive orders and from industry. And again, there are also international timelines. They tend to follow the US-based timelines plus or minus a few years, so we can discuss more specifics personally if you wish. Right, so this is my new Legally Distinct television show that I am previewing to all of you today so that we can get a bit more into the details of what is most important for confidential computing and what is true and what is not, what we see in the popular discussion. So no, we cannot just make RSA bigger. That is because quantum computers could factor classical crypto and polynomial time. So if you double the size of RSA, you are not getting an exponential increase in strength. And making RSA bigger, it doesn't solve your problem long term, and you can also use that effort to making PQC happen now. So making RSA bigger is not recommended. And this one I also hear a lot is Q-Day is always a decade away. That is no longer true. So some of the, So some of the specifics for what has caused this accelerating timeline are that there have been improvements in quantum error correction, that quantum computers have gotten a lot larger, and that Shor's algorithm has gotten more efficient in that there are new proposed implementations of it. Yes, and this is one of the proposed implementations. So the speed up comes from better quantum error correction, but also new instruction set, new circuit design. And this article, or this publication, I should say, is still preprint, but it's had a few months to circulate through the cryptographic community. To my knowledge, its findings have not been refuted. So it has some weight behind it. And as you can see in the bottom of the slide, it creates a speed up of about 3 orders of magnitude from what we had originally anticipated. First early estimates of how many qubits that you might need to break RSA were around 20 million. As you can see, that's about 20,000 plus or minus. So yeah, that's a pretty big deal. And the largest quantum computers have gotten larger. So you can see the Caltex is a little over 6,000 qubits. I know that sounds like a little scary on its face, but neutral atom quantum computers, while they are very large and can be in a stable superposition, are not yet capable of doing all of the operations that Shor's algorithm requires. So it's a step in the right direction for breaking crypto, but it's not like there is still much work to be done here. Right, and this slide also details, so for neutral atom quantum computers, there have also been improvements in the gate techniques to make the operations more stable. So again, it's like all of these different developments are kind of coalescing into being a bigger threat. Yeah, so this basically just means that the transition needs to happen sooner. Cool. And then, so I hear a lot that, lattice crypto being too new to really have confidence in, but the core, algorithmic design is actually quite old. So it was developed about 30 years ago. It is simply the FIP standardization is what's new. The implementations are new, and there's a little bit of subtlety there. But there's been 30 years of time to make hardness challenges against lattice crypto, and it's holding for now. But how much do we trust it? So part of the reason, again, because the implementations are new, we're seeing mostly hybrid classical crypto and post-quantum crypto, especially for TLS 1.3. So it's made to be a conservative choice, but it also does make standardization more complicated. It can make signing and verification more complicated. Practically, it actually is harder. So it's causing, there are some delays. And in the end, if we take Q-Day as 2030, this is a lot of effort for algorithms that will be essentially deprecated in 3 or 4 years. So that's why, especially NIST and also myself put an emphasis on crypto agility as opposed to necessarily hybrid cryptography, so that if an algorithm is found to be vulnerable, you can swap it out quickly. Obviously, that is much easier said than done, but it's the general idea of how to make sustainable systems in a changing cryptographic landscape. Cool. And another thing I just want to mention is that sometimes you will hear that AES and SHA have their security halved by quantum computers. That's not necessarily true. And there's a blog that I linked there that has a really good breakdown of why, but the algorithm, Grover's algorithm that people are referring to when they say that is not easy to parallelize. So it's a little bit it's less of a threat, is what I'm saying. CNSA 2.0, however, still says we need the highest strengths for AES and for SHA, which obviously introduces complications from a performance perspective and from this verification for hashes. Okay, so hardware. Obviously, there are plenty of people who work for hardware manufacturing companies in this room. So what I'm discussing are publicly available timelines. If you happen to have anything to add when I'm discussing these, please raise your hand and you can, contribute to the discussion if there's something newer than what is published that you're allowed to talk about. So obviously, hardware matters a lot for confidential computing, and this includes trusted execution environment hardware like SEV-SMP and TDX, but it also includes hardware security modules, TPMs, anything that requires a hardware root of trust, and it especially matters for resource-constrained environments because PQC has a higher computational footprint, and that matters. So this is just some developments that have already happened, like TPM space. They've already updated the specification to have MLChem and MLDSA, which is awesome. The reference code and any downstream software libraries are going to take more time, so it will be a little bit before you can use a PQC TPM in your day-to-day life. Also, there have been HSMs that now support PQC, which is awesome. Right, so for Intel, AMD, and NVIDIA, I was not able to find any public timelines for PQC transition in hardware beyond what I've put on the slide. At the keynote yesterday, there was a mention of Intel's offerings being like all fully PQC by 2029, which is awesome to hear. But this was kind of all I was able to find. And that's a little bit concerning only because, like, yes, I'm sure these discussions are happening, but, you know, it would be nice to have that in public so we can make plans, because software is going to have to move very fast once hardware catches up. And it also means that hardware will have to be replaced. Anything that has a burned-in key or certificate that is classical cryptography after Q-Day happens is no longer valid. Like, you have lost your root of trust, so you have to replace your hardware. There's kind of no way around that. There is some leeway depending on what you're doing with firmware, with software updates, but like, at a certain point, there's just nothing you can do. You have to replace it, and that will cause like probably hardware shortages. There could be delays in distribution just because, like, if you have to replace everything, that's kind of a big deal. And if we're unlucky, the timing could take longer, like after Q-Day, but we'll see. Again, this is why the publicly available timelines are important, so that software engineers can plan what they're doing for the next few years. Right, and when I was reading through the specifications for like SCV-SMP and TDX, I did notice some discrepancies with CNSA 2.0. These are not vulnerabilities, just to be very clear. But, you know, I did see this and I did wonder, like, okay, how is this going to jive with CNSA 2.0? Because it specifies AES 256, which SCV, SMP, and Intel TDX use AES 128, and that is a better design choice in my opinion because it's faster, but it also is incongruous. So I would be curious to know like how that's going to go down. Also, so I saw TDX uses SHA-3 256, which so SHA-3 is allowed, but it needs to be bigger. You're not allowed to have 256 for anything, basically, with CNSA 2.0. So again, that's another discrepancy that I noticed that I thought people should be aware of. Cool. And then software. So software gets really complicated when you are doing a kind of cryptographic migration like this. There was a NIST quote that I found a while ago about how, like, migrating cryptographic infrastructure fully can take up to 30 years. So we're looking at like the long haul here. And this heat map is a good representation of how long or how patchwork things can be. You can see all of these different critical infrastructure projects are moving at different paces, and that includes standardization and implementation. It's just a lot of stuff. And I really do encourage you to look at the Post-Quantum Cryptography Coalition's summaries on this subject. They're very comprehensive, very helpful. Right, and so what we kind of see here, and this is, okay, so this was more infrastructure, this is more software. So what we see is NIST will like put out FIPS documents, and then software engineers will take the pseudocode within those documents and implement them in core language libraries and in cryptographic infrastructure. But all these different projects move at different paces. So for example, Rust, I believe, currently has MLChem and MLDSA crates, but they're relatively new. And I don't believe they're production ready yet. And then, for example, Golang cryptography, they implemented MLChem very early, like a year or two ago, which is awesome. But they have yet to implement MLDSA, which has created some delays in cloud computing projects for being able to get like signatures and certs up and running. And like, you know, that's not unique to any one specific languages. They're all moving at different paces. And then when you get to the actual like applications, confidential computing applications, all of these problems coalesce, and it makes upgrading them very difficult. So this is just a short list of some of the things that, for example, Trusty, it's used by a lot of us, but it needs, like, if it's going to support post-quantum cryptography, then the hardware needs to be upgraded. The IETF standards for JSON Web Tokens need to be finalized. The TLS transport needs to be updated, needs to be consistent with OCI standards. And then obviously there's the language-specific blockers that I already discussed. So these problems compound, and that's why it's so important to start early and to be communicative, like, as a community. And one more example. So I know that Keylime's support for trusted execution environments is relatively new. It's here because it's a project that Red Hat is involved in. And some additional blockers that exist include like the Linux IMA, TPM. Like I said, the specification is updated, but not the hardware or the reference code yet. And then there also continue to be discrepancies in hash sizes. And when you take into account that, like, you know, there's the agent, client, and verifier all need to be like updated too, it gets very complicated to make sure everything is synchronized, especially when some of the stuff is already in production. So it's a big effort. And this is kind of why I saved a little bit of extra time, because I want to like open the floor a bit. I would really love to hear more about like what your company or your team are working on. If you're working on anything PQC related, if you have any success stories or difficulties, I'd really love to hear from you. And if you have any questions for me too, I'll take questions. That is most of what I've got. So I open the floor to you. Okay. Yes. Yes. So I am potentially not the correct person to explain the precise math, and that would also be really hard to do here. But it relies, let's see, off the top of my head, it relies on the like algebraic lattices. Let's see. Yes. So it is the shortest shortest integer. No, I'll have to look at my notes. Yeah. Sorry, I'll have to look that up for you. Any other questions? Yes.
It's a massive project where a lot of teams are thinking about it and scoping it. So I just want to say that we're working on it. But the thing I really wanted to call attention to is our promising computing platform relies on Recore, the Linux Foundation's transparency law, and they currently have a PQC RFC up looking for comments. So if you are interested in that, you can join the group, the working group there. It's just a publicly part of their website, and there's a document that elaborates their PQC goals for Recore, the transparency law. Looking for help.
Yeah, so I've spent some time being involved with the SigStore project, which Recore is a component. I wasn't aware of an RFC. There is a discussion going on, like they're working on PQC plans, but I don't know about the RFC specifically. So I would definitely like to look that up so that we can, because that's very important. Yeah, Red Hat also does work with like SigStore and Recore. So yeah. Yeah. Yes. 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 Yes, I am familiar with OpenTitan. I have read a little bit about it. I'm really happy that Open Hardware is working on it, and RISC-V too. Yes. Anybody else? Okay. Yes. Yeah, yeah, absolutely. Anyone else? Yes. Yeah, no, I totally understand. Which is why like there's a distinction between like the underlying hardness assumption. So like the lattice crypto and then the actual implementation. So like the math is pretty well trusted, but then like when you think about what would make it insecure, so it would be like side channels or something, and that is an implementation side issue. So like there's a lot of trust in the math, but whether it can actually be used is a different question, which is why hybrid is so popular and being standardized. Yes. And like when it comes to, for example, CNSA 2.0 with the like mandating Pure, that is for US national security systems. So it's like, it is, the US government's most sensitive software, and that like, because they're recommending that for most sensitive systems, that kind of gives me a little bit of confidence tangentially. Yeah. Okay. Thank you very much, everybody. I will be outside and we can discuss more.
I think this is okay. Yeah. Cool. Yeah. Just this. Cool. Hi, everyone. I'm Varun. I'm a research scientist at WhatsApp. And this talk is about WhatsApp's private processing. And this is a very technical talk, engineering talk. And I'm just going to kick off with a bit of a recap and some of the products that we're actually working on that we've launched in the last couple of years. But otherwise, this talk is mostly going to be about how we actually build this platform, and more importantly, about our experience running an actual production service on Tees for over a year, which is a AI production service at scale. And so first of all, just a quick recap on what we've been doing at Meta with private processing. We started off in 2022 with SGX, and we just used SGX for some signing keys at the edge. Then we moved to AMD CVMs for some internal services in 2024, and we created the remote attestation TLS protocol for our services. In 2025, we launched our first products on the WhatsApp private processing platform, first user-facing products. And in 2026, we're continuing to build on that and launching newer products, which I will talk about shortly. So what is our goal? At WhatsApp, we're trying to get AI to everyone in a way that's completely private, in a way that is essentially the same as what WhatsApp's messaging is, end-to-end encrypted. When you send a message to someone else, they cannot see, no one can see what you send them except the recipient of the message. Similarly, with WhatsApp's private processing, whatever you send to the AI cannot be seen by anyone except the AI model itself. And not even Meta or WhatsApp can actually see what you're interacting with the AI about. And this is built in an open, verifiable way, which is actually audited by security experts. And in parallel, we're also heavily investing in actually making parts of these open source, and so that anyone can actually build these things and verify what the T is doing with their personal data. And so quickly, two of the products that we launched in 2025. Summarization, you have long chats that you cannot catch up on. You can quickly summarize them with AI, which is summarized in a T, so nobody can see it except you. Write with AI, get some writing help on rephrasing things and things like that inside WhatsApp. And more recently, last month, we actually launched Incognito Chat with Meta AI, which is now our flagship product of private processing in WhatsApp. Essentially, it's a chat with Meta AI that you can, it just works like the normal chat with Meta AI, but completely runs within Ts that you can talk to without Meta being able to see your messages. And when you close it, everything kind of disappears. So it's fully ephemeral. That's why incognito. So now Kevin will talk about how we actually built it, overview of the platform. Kevin? Yep.
Hi. Sorry, guys. We're going to be doing this weird baton pass first, so please forgive us. I'm Kevin. I'm part of the infra team that helped build out a lot of the infrastructure that powers private processing. Let's just do a very quick overview of what private processing looks like, and give you an intuition so you can kind of understand the rest of the slides. We have a WhatsApp client who wants to go talk to a lot of the Ts that are running inside of our private processing stack. We have two major stacks, Ts here. We have the orchestrator and a predictor. The orchestrator is effectively just the front end that will just route all of the inference requests over to these predictors, which are have the GPU cards attached. They're just NVIDIA Hopper GPUs, and they are running in the CC mode. We also have a load balancer, which just standard fare. You're just going to send it to an orchestrator. We have an anonymous credential service, which is what we're going to be using in order to kind of authenticate your your WhatsApp clients while we're trying to anonymize them and prevent them from being targeted or something like that. There's also just the standard WhatsApp server, which is how you're going to be getting your responses. Here, the orchestrator is going to be doing a lot of remote attestation with all of the predictors so that the orchestrator knows that it's talking to legitimate predictors. And the client is going to be talking, or is going to connect to the private processing stack through a oblivious HTTP relay, which will help hide your IP from Meta, so we can't do any sort of targeted attack against you. We also have transparency logs that are coming from Cloudflare. This contains all of the transparency proofs, which represent all of the measurements in the trusted computing base for all of the orchestrator and predictor jobs. These are stored inside the orchestrators themselves and the predictors, so that we can bundle them as part of the attestation report. And then the client will go and talk to the anonymous credential service, get some sort of token that will be used to authenticate within the Meta infrastructure, and we can kind of use the oblivious HTTP relay to go and authenticate with the orchestrator and kind of do all of that. Afterwards, the orchestrator will take the it'll take any sort of requests or any user prompts that are coming from the WhatsApp client, pass it over to the predictor. Predictor will do some inference and then return the results of that through the WhatsApp server and back to the client. All right, so that's just a very quick overview of the actual platform itself. Let's talk a little bit about some of the features we saw and some of the challenges that we encountered when we were developing private processing. So one of the things that we initially started off doing was we would build all of the image alongside of the application. So we would tell developers, hey, go build all of your VM images and then, or rather build all of your applications and then install into this VM image. And then, it would cause this whole dependency issue where you would have to build and rebuild. Yeah, you have to rebuild the entire world and just kind of do this weird dance where you just build everything. It would cause builds to take 30 minutes and, just add all these dependency issues. So we had to think about how we would actually separate some of the builds, kind of dependencies and all of these related concepts such that we can kind of own parts of it, and then kind of the service owners, so WhatsApp and other people can kind of focus on their own business logic. So we think of it as this generic abstraction on top of the applications that service owners will use. So here we've separated into two interfaces here. We have the application agnostic CVM. Internally, we call it the generic CVM. And this is where we abstract all of the T integrations. We provide all of our platform daemons here, and then we also use this to launch the application container. The application container I can show you here is effectively just what the service owner is going to provide to us, and also a bunch of the application containers and data components. And then if you see in the rest of the diagram here, in blue, that's everything we own, and then AMD firmware is also provided there as well. So how do we add these application containers into the CVM, but also can securely ingest those such that they're part of our trusted computing base? This is something else that we also thought was going to be an interesting issue. I'm sure there are a bunch of open source solutions, but this is how we did it at Meta. So the issue with our initial idea of having these generic CVMs is that this base CVM can only serve multiple. It can serve multiple services, but it's not part of that trusted computing base. Recall that we're going to be separating all of these together. We're going to be separating all of these application containers from the actual image. So if we were to try to do any sort of attestation, they wouldn't be included. But so we had to come up with some sort of artifact injection framework such that we can ingest untrusted data such as the application data or model prompts or whatever, and then kind of verify them through this TSA model. I just hope that this implementation is a little bit more secure than the TSA. But anyways, the idea here is that we want to have this dedicated channel where we are guaranteed that we can ensure that all of the untrusted data comes through this particular channel and through no other method, such as a shared file system or anything like that. This allows us to kind of decouple the resources from the application container. We can avoid including the model weights or system prompts in these giant, all these giant resources from the actual CVM, such that we can kind of elegantly put these into its own layer of transparency ledgers or something like that. So we leverage transparency proofs, and we kind of use those as the way to kind of decompose the attestation such that we can kind of verify that these are part of some other ledger. I have a better visualization here, but say we have a model. we will generate a hash from that. We'll publish it to the transparency log here. And then we'll get a hash of that transparency log, pretty standard fare. Afterwards, we'll take that same untrusted model and we'll put it into some sort of binary transparency proof. And then we will kind of try and use this binary transparency loader in the CVM to kind of load it into the CVM, have that binary transparency loader, generate the hash of the model, and then we do a couple of simple checks here. We'll check that the hashes match what's provided in the binary transparency proof, and then also just make sure that that's signed by Cloudflare or whatever our transparency ledger is. It doesn't have to be Cloudflare, but that's what we use it on. Once we verify that these two things are valid, we will then trust the model and then present it inside of our attestation reports. Next up, I'm going to have Henry talk about some of the operation work.
Right, so bringing up the private processing stack was a lot of work. But what's also a lot of work is maintaining it and evolving it over time, as we have to uphold the privacy, security, and transparency guarantees. So in this section, we'll talk about some of the operational work we do to make this happen, with a focus on managing vulnerabilities. So our privacy and security guarantees rely on not only the TEE hardware, but also the integrity of the software that's being deployed. So we must take care to minimize the risk of bad code or malicious code being pushed to production. However, Meta's software supply chain environment makes this a little difficult for the following reasons. We have a large engineering organization. I can't say the numbers, but it's getting less with layoffs. We have a model repo with broad access. So this means that hundreds of teams share the same code base. Anyone can generally push code as long as it's being code reviewed. We have general TCB build. TCB build here means the amount of code that is measured and attested. Now, while we cannot guarantee that no bad code will ever be landed, we can enforce controls to make it difficult for a single malicious insider to push code to production on their own. So we have several enforcements and internal controls. For example, artifacts must be built by a trusted builder. It must be built from a landed or accepted source revision. Deployments also require collaboration between multiple teams and multiple individuals. We also heavily use AI throughout the deployment process for code reviews and as well as to continuously audit the code base for potential vulnerabilities. Furthermore, every stage of the deployment generates internal audit trails. So that acts as a deterrent for malicious behavior as well. And finally, the load-bearing component is binary transparency, since any artifacts we deploy to production have to be published to a transparency log. Now, about the dependency load. So at Meta, our model repo incorporates hundreds of third-party dependencies. And as we see software supply chain attacks become more and more sophisticated, this is becoming a real and growing problem. So to address this, and this risk is actually further exacerbated by the fact that products typically prioritize more feature support over just minimizing the TCB. And as we know, TCB generally scales with vulnerability risk. So to address this, we have vulnerability management infrastructure. It ingests CVE data from multiple sources. It scans our code and binaries for potential vulnerabilities. So we use these signals to gate pushes to production, as well as to raise alerts about possible vulnerabilities in active deployments. Now, even with all these controls, right, there is still the chance that these vulnerabilities inevitably reach production. Therefore, we need a mechanism to mitigate these incidents, and it has to happen fast. So this brings us to our next topic, revocation. Revocation just means invalidating particular artifacts. So imagine a client connecting to a server but rejecting it because for some reason it's revoked. So we have revocation with expiration time and explicit revocation with a revocation list. So for the expiration time, binaries are like milk. They go bad over time as they accumulate CVEs. So we enforce expiration for all of the artifacts we deploy to prod. What happens is the WhatsApp client, when it tries to connect to
a TEE server, let's say it's running a CVM image that's more than 90 days old, it will reject that connection. However, expiration time on its own is insufficient. Imagine if we have a server-side vulnerability, we hotfix it, we fully deploy it, or we think we do. Because it's possible for some vulnerable instance of the server to be running within our infrastructure because Meta is untrusted, and it can pass attestation up until it expires. So this could be in the order of up to 90 days. And during this time, traffic could be routed to this one vulnerable server, and data could potentially be exploited. So to mitigate the risk of these long-living artifacts and the fact that it takes us actually 90 days to roll out changes to the mobile client, we have the concept of revocation lists, which is simply metadata containing digests that correspond to revoked artifacts. So revocation lists are also fresh. We have freshness enforcements. They expire after 24 hours, and we continuously refresh them. So this means that after we revoke an instance of an artifact, clients must see it within 24 hours, otherwise their attestation verification will fail due to these freshness errors. Lastly, the revocation list is also a transparent artifact, which means its digest is published through the transparency log, and the content itself is actually available to be downloaded by the external researchers. Therefore, Meta's revocation operations are transparent. And what happens is researchers can verify that we are not doing any malicious operations. For example, if we unrevoke a binary before it expires. So revocation only invalidates the transparent artifacts, which are the CVM and application software packages. But what about vulnerabilities or hotfixing the AMD firmware? This is tricky because currently the TCB values or the firmware versions are hard-coded into the mobile clients. And for us mobile clients, we don't control their updates. It takes up to 90 days for these rollouts to happen. Therefore, we rely on another mechanism, self-attestation. So this works where the CVM boots up, it measures the firmware versions, compares it against a hard-coded set of expectations, and if the verification fails, then we refuse to boot. So to tie this all together, let's talk about a real-life incident where we had to use these exact revocation hotfixing mechanisms. So let's say we have to update the AMD firmware across our fleet. We apply the patch code and we roll out to all the hosts. Next, we have to rebuild the CVM images with new expectations for the new firmware versions. Because if we don't, then it's still possible for these vulnerable servers running the vulnerable stack to be deployed. So then we add these vulnerable CVM digests to the revocation list. The revocation lists are distributed very quickly to the clients, and clients are immediately able to reject connections to any stale CVM instance running on the stale firmware. So the important thing is that we're able to move fast, and the fact that these operations are transparent and can be audited. Next, Liz will talk to us about the bug bounty program and the future plans for the platform.
All right, good afternoon. The last part, we're going to talk a little bit for non-technical part. And let me quickly introduce our bug bounty program. So Meta has amazing bug bounty program cover our major products. And for the public program, it's open to any external security researchers. If you have any interest, just go to our website to have a look. And as part of our commitment to verifiable transparency, we also provide a bug bounty program for researchers to audit the WhatsApp private processing stack. So we want to be as transparent as possible and also open source as many components of private processing stack as we can. And for the starter, we have already open sourced the attestation verification library, which run on both mobile client and also within the TE workloads. As a matter of fact, we just open source attestation verifier library, and it's available and open from today. So please go to our GitHub and check it out. And the link is on this slide. So for one thing I need to mention here is for the WhatsApp private processing back program, it's a private program, so it's by invitation only. In the future, we plan to open source more components and also continuous improving our research environments by modernizing our documentation and tooling. And on this slide, what you can see is a UI for our private processing bug bounty program. So the researcher who enrolled in the bug bounty program can just go there, download transparent artifacts whose digest has already been published into the transparent log. Researchers can run or decompile the binaries to verify privacy preserving and also inspect the security of our systems. Okay, all right. So in the past couple minutes, we did recap what happened before and what we're doing right now. So what is next for Meta private processing? In summary, we are right now turning Meta private processing as a strategic platform, which is measured, attested, transparent, and introspectable. Right now, we already have the 4 capabilities in place, but we want to continue enhancing all those 4 capabilities. And what's more, what I want to share here is in the first half of this year, we actually did internal customer interviews. So we have collected lots of use cases, lots of new requirements. And as just we mentioned in the very beginning, we just released Incognito Chat in May, this first half of the year. We're actually also working on more new use cases. So we definitely going to have a more exciting news to share in the second half of the year. As a matter of fact, in the next year's conferences, we're going to have much, much more exciting stories that we can share with you all next year's conference. All right, so as we just mentioned, as a platform, we actually have 2 focuses. One focus definitely to strengthen on our platform foundation, which means that we need to improve our hardware security, explore more hardware options, and of course, we're going to expand CVM features. So for example, Mewtwo R8 TLS, we support client-server Mewtwo attestation, and we also going to implement CVM trusted time to prevent time-based attacks. And we're going to implement new virtual machine managers, cloud hypervisor, provide less attack service than QEMU. In summary, we want to make the platform more secure, more reliable, and more scalable. So that's our focus. And of course, as a platform service provider, we want to improve our internal developer experiences. We're targeting provide frictionless onboarding experiences to our developers, and we're proactively engaged with our customers. So we've been very proactively working with them to seek more feedbacks, identify new use cases, identify new requirement, where we can potentially use confidential computing to solve the technical challenges, and especially where that we can actually use the confidential computing as our new business revenue generator. So that's our 2 focuses for Meta private computing as a whole. With that said, that covers all our sharing today. And I want to call for all our Meta team members to raise your hand so that please, team members from Meta, raise your hand. And if you have any questions, and talk to us. Thank you so much. And again, we're open for any questions and discussions. Thank you.
Ready to get started? All right. We're almost at the end of this in the home stretch. So this talk, it's a little bit different. I've not tried this particular framing before. It has a little bit of a personal connection. So I hope that you you go with me on this. So let's just jump into it. Let's start with an introduction. So who am I, what do I do, and why am I here? So I'm Matt Wilson, and I'm an engineer. And I'm humbled that an organization like Amazon decided to put distinguished in my title. I'm asked, what does a distinguished engineer at Amazon do a lot? And candidly, I'm kind of still figuring that out. There's just so much change happening right now that sometimes it can feel a little overwhelming. I've been at Amazon for a little over 16 years. I was hired as a principal systems engineer on the kernel and operating system team. And so I call myself a systems engineer. I think in systems that span many technologies and disciplines. Our technology stack spans all these different dimensions that come together ultimately to serve our needs. So to me, systems engineering is all about balancing trade-offs and constraints to deliver practical, cost-effective solutions, no matter if we're talking about hardware or software or networking or power or processes. Systems are more than the sum of all the components. So at Amazon, most technologists that are hired at the principal level are software development engineers. And among my distinguished engineer peers, I'm the only one who came up through the systems development engineer job family, though I consider many of them to be fellow systems thinkers. So one of the things I feel called to do at Amazon is to advocate for systems engineering as a discipline. When I reflect further on what it is I really do, I consider myself a socio-technical systems engineer because I feel that it's really important to highlight the human elements of systems engineering, because it's really easy for technologists to focus mostly on the technology, and that can ignore what I think is the most critical part of engineering, which is making sure that the people who rely on the systems that we build, that they are well served by what we build, that they can rely on it, right? And there are human factors that determine how well they will be met, and also how well we will, from a sustainability perspective, the engineers who are building these systems, how that will work over time. So that means that in my engineering, I include how we organize and plan and operate at a people level, because no matter how much AI we bring to this work, I think that it will continue to be a human-intensive effort for at least as long as I am a practicing systems engineer. So this kind of socio-technical systems focus leads me to work on some amazingly complex and challenging problems. I started my professional career at Red Hat in the early days. So I feel an affinity for all things at the Linux Foundation and open source. I've been fascinated with how open source software works, how communities form and grow and fade away from the days when we called it free software. So today I'm part of Amazon's software builder experience team. And so we are responsible for all the software engineering systems at Amazon, including AWS. So part of what I do is I try to make these systems work well with open source, and I try to provide information, knowledge, and tools so that our software developers work well with open source. Right now, I'm also spending a lot of time addressing the concerns of AI-discovered vulnerabilities in open source software. That takes up a lot of my day. And then responding to supply chain attacks and compromises on GitHub, and it's taking up a lot of my nights. So software engineering and life cycles, the life cycles that software developers use to do their work, it's also an area of real intense focus for me. So that's also a socio-technical systems effort. So understanding how teams go about planning their work, share knowledge with one another, learn how to not only build software, but operate it in production, and how to build resilience in everything they do is core to the work that I do within Amazon Software Builder Experience today. Another area where I feel drawn personally is studying concepts like security and reliability, trust and trustworthiness, because those are very deeply human processes that need to be considered when we build technologies that can have real consequences on people's lives. I think it's highly relevant to confidential computing. And I think doing this job well demands a holistic systems approach. So I promise I'm going to talk about the Nitro system, but first, I think it would be helpful if we shared a common mental model for systems engineering and shared vocabulary about building trustworthy, secure systems. So I think that let's return to principles, right? So I think to get on the same page, let's start with the goal. And then we can work backwards to learn about some principles that can help achieve that goal. So here's the objective from my point of view. So our objective is to design and deliver an engineered system that reliably delivers on its intended function while ensuring that only the intended behaviors and outcomes occur with both within the system and the system as a whole. Then as an engineer, we need to generate and provide evidence that can support as the grounds for a justified confidence that claims about that system have been or will be achieved. And that is how we establish trustworthiness. Yesterday, there were some discussion during the keynote panel session about trust versus verified or justified trust. So that, to me, is what I call establishing trustworthiness. And I'm not inventing this vocabulary and this framework myself. This all comes from a document that NIST published in 2022 to help advance this idea of building trustworthy and secure systems as a systems engineering discipline. And I really wish that this document had existed when we started designing the Nitro system in 2013. Because the principles and techniques in the guide aren't new. Like we applied a lot of, I think, sound principles at the time, like least privilege and this and that. But the holistic systems framing, I think, is new. So this guide can tell us how to apply a holistic, multidisciplinary systems thinking and how important that is for achieving security assurances. The guide includes 20 principles that can be applied in the system engineering discipline that can help achieve an appropriate level of security. And that's a defined term in the framework, like understanding what the security concerns are and how those can be appropriately met by a system, right? They provide a basis for reasoning about a system, and they shouldn't be applied as rules to be complied with or prioritized or sequenced or ordered or prescriptive. This is a tool that you can use as an engineer to make sound judgments about conformance and about managing risk. They're tools for our brain, right? They can help establish that common vocabulary and mental models across the community practice, which is important when I'm trying to convince someone who is a fellow practitioner in systems engineering that the claims I'm making about a system are justified. It's helpful to have this shared vocabulary and mental model for the work. So today I'm going to touch on just a few of these principles and how they can be applied to the Nitro system. So first, let me talk about a brief overview of what the Nitro system is. So Nitro system is purpose-built to be trustworthy foundational component for EC2, provides virtualization so that we can take the resources that are running in the cloud and partition them into separated customer instances. There's a reason why we included system next to Nitro from day one. It's because this is a combination of hardware and programmable elements that work together to protect customer data while not compromising on the performance, reliability, or other operational characteristics. So first we have Nitro cards. Those serve as the hardware root of trust for the system. Those cards are built using system-on-a-chip ASICs from Annapurna Labs, which is the custom silicon division of AWS. Inline, they provide secure I/O virtualization for networking and storage, and inline data encryption, and removes those responsibilities from a host-based hypervisor. Therefore, the next component, the Nitro hypervisor, is radically simplified. It only needs to program the hardware so that isolation can be enforced by the hardware. The Nitro hypervisor is based off of Linux, but only the required subsystems are compiled. Our system design also includes a security chip on the system mainboard, which enables the Nitro card that serves as the hardware root of trust to measure and control all firmware components and mediates control of all system management interfaces. And so the Nitro system is the foundation for the security and the data protection of EC2. And there's some very specific elements of the Nitro system design that are important. First, there's a secure boot process that's based off of the hardware root of trust in the Nitro card. And it ensures that the integrity and authenticity of every programming component of the system. So you can think of programming components as firmware or software, but I just think of like the parts of the system that program the hardware. So programming components are minimized and implements only the required functionality. Hardware-based isolation is enforced by hardware, but programmed by those trusted programming elements. And we also have hardware-based inline encryption of all storage and networking, and on many of our systems, we have inline memory encryption as well. No AWS operator has access to the Nitro system. That's in the basis of the design, right? All operations on Nitro infrastructure are invoked via secure, authenticated, authorized, logged, and audited APIs. No APIs provide access to compute, instance memory, or storage contents. So I want to try to convince you that the Nitro system is trustworthy. So how can I do that using the framework? I'm going to make specific claims, and then I'm going to try to provide some evidence that I think will help justify that claim. So first, I claim that the Nitro system implements sound early boot firmware needed for trustworthy, measured, and secure boot functionality. So how do we build the assurance for this as engineers, and also for someone who's a concerned user of the system? Well, we have to make sure that from the very first instructions that come up when the system on a chip boots, which is in ROM, that all of that is sound, that we have assurances that that software has no memory, safety errors, or correctness from the very first instructions. And so we apply, I think, an appropriate level of rigor in building these components that are the critical components of the system, that we have can come to a justified conclusion that it is sound. So we published a paper in 2018 that made some very precise claims about how we proved properties of the boot code for the secure boot of the system. And it was 783 lines of code that were proven, which was no small amount of work at the time. It's also, we had to address a number of challenges proving, using the tools that we had at the time, proving code in kind of early boot modes of execution for the processor. So I have another claim, the second claim, that the Nitro system implements a single encrypted operational API control channel where all operations are authorized and audited. So this one, there are a number of subclaims that support this broader claim. And to get to sufficient level of detail with someone to evaluate this, we worked with the NCC group to evaluate the security design and the claims that we made. And it came to a conclusion that the evidence that we supplied supported those claims. You can get to the report on the QR code. And this is, I think, we've been continuing to enhance and grow the assurances we've been able to make over time. So in the beginning, we started with a very small amount of kind of formal modeling around early boot firmware. But we really want to be able to extend that to more parts of the system. So our latest claim is that the component that's responsible for programming the hardware isolation functionality of the Nitro system is free from memory safety errors, runtime errors, and is functionally correct. And so our latest release of the latest generation of Graviton processors utilizes a new component that enhances the overall trust posture of the Nitro system. It's called the Nitro Isolation Engine. This is the first formally verified production cloud hypervisor. It's 330,000 lines of machine-checked mathematical proof. And it's comparable in overall scale of effort to the SEL4 project, if you're familiar with formally verified operating systems. So this is a mathematical proof that the VM isolation that is implemented in this element of the system of the stack is correctly enforced, not just that we've tested it sufficiently. In order to actually have an assurance that the confidentiality integrity that we want to have through the hardware enforcement of the virtualization, you have to build that from a number of steps along the way. So you have to demonstrate that the code is free from memory safety hazards. So no null pointer dereferences, no use after free errors. You have to demonstrate that it has no runtime errors, such as unreachable reachable panics and things like that. You have to demonstrate that it has functional correctness. It doesn't have logical errors. And from there, you can demonstrate that the confidentiality and integrity that is enforced in hardware is correctly implemented. We have a white paper that we recently published about the Nitro Isolation Engine. There's also a presentation from the team that they gave at re:Invent last year. And so let's look ahead. This is kind of gets to the part of like, okay, we do all this work to establish Nitro system as the foundation of trust and trustworthiness, not just trust me, but please verify my work and come to your own justified conclusions. What can we do with that? So I think this is no big surprise. There are a lot of concerns related to AI, and confidential computing, I think, shows a good promise for addressing them. In particular, model weights providers want to have assurances that those weights are protected in production. And so today we have implementations of the Mantle inferencing engine as part of Bedrock, which is AWS's inference as a service. It uses the Nitro system to provide an attestation about what's running inside of the inference environment, and that it too is built with no operator access, and model providers can be assured that model weights are adequately protected. And how does this, like for anyone who is like looking to implement confidential computing and using Nitro, like how would you start? Hopefully, I'm curious. Is anyone in the audience are using confidential computing functionality like Nitro enclaves or Nitro attested instances? Okay, that's good. I think one of the things that I always ask is like, do you have an understanding of what it is you're protecting? Who are you protecting it from? And then we can help you map that onto how AWS can help. So first, for all Nitro system instances, like the assurance that you're protected, your data, like the cloud operator has no ability to access customer content, that applies no matter what. Like it's not an optional feature, it's always on. And you don't have to do anything to get those assurances. If you want to do other things like provide a remote attestation of either a Nitro enclave, which is a feature of the Nitro system, or Nitro instances, you can do that as well. You can use the trust that you, I think, can have in the Nitro system to demonstrate to someone else that this is the code that's running inside of an enclave or inside of an instance. So you can get more information at this landing page. And I wanted to close with like one more thought. This is a quote from, I'll call Corey my friend. Yeah, Corey is my friend. And he trusts Amazon. And so this is he wrote an article in the Register last week where he, the Register editor said, blink if you're in trouble or something like that. So I think that trust, as Mark was saying yesterday, is a complicated equation. And I think that trust is earned. And no matter what we get wrong in Corey's eyes, I think that he recognizes, at least from his perspective, that we take security and data privacy deadly seriously. And for engineering, that's something that we really internalize as core to the mission, and something that becomes really, we have to do our work in ways that withstands any level of scrutiny. It's difficult to provide complete transparency because you have to balance a number of concerns about confidentiality, intellectual property, and also giving ourselves the flexibility to make changes that continue to improve the system without having to go back and re-evidence everything. So I think that there's a theme in a lot of confidential computing discourse that kind of boils down to this. The cloud provider can't be trusted. You should just assume the cloud provider is hostile. And the software that cloud providers develop, like a hypervisor, must be assumed malicious. I think it's a healthy overall approach to assume all components of a system could be compromised. That's a good defense in depth. But that's different than just an assumption that a cloud provider, merely due to being a cloud provider, can't be trusted. I think there's a theme that software-based trusted execution environments, whatever software-based means, are weaker than hardware-based trusted execution environments. In fact, all these systems are systems of both hardware and software elements. All of the attestation programming for all of the trusted execution environments that I'm aware of are implemented in software. And so we need to apply rigorous methods to ensure that those software implementations are sound. And that should be part of what we expect from anyone who is trying to convince you that their technology is trustworthy. So I have generally a personal belief that people should have a right to evaluate what's right for them. And so I encourage everyone to accept that some people are going to trust a cloud provider, and some people are going to say, I have to trust a third party. And with that, I think I ran right at time, and hopefully, do we have any time for questions? No? Okay. Thank you.
Back to the stage, Aaron Fulkerson.
It's a lot of vigorous clapping for just this closing out here, man. Thank you so much. Let me get my glasses on so I can tell you what we got going on. One of the things we got going on, though, by the way, is we're giving away more prizes. So not only do we have awesome opaque hats, but anybody who wants those can have those. We also have another confidential agent, which is just a case filled with Flipper Zero and peripherals, which is awesome. If you know what a Flipper Zero is, if you don't, you should Google it. And then a whole bunch of other stuff that we're going to give away. And we're giving this away to people who've been selected by Nelly from the poster session. And Moran, who else? Right, and people who ask questions from the audience. Then you'll be able to pick fun prizes. Okay, cool. So I hope you guys have had a terrific 2 days here. I'm very proud of what we put together in terms of speakers and attendees. So thank you all for coming. We couldn't have done it without all of you. As we close out day 2, I want to really ground all the technical progress that we've made as a community in the regulatory reality of the moment. Regulation is one of the 3 forces we discussed that's rapidly transforming confidential systems from an optional feature to a mandatory one. And to help navigate these critical shifts, I reached out cold to the chair of the European Data Protection Board. So this is EDPB. This is the firm that wrote GDPR and also wrote the EU AI Act. And I spoke with Anna Tallis, who is the chair of the European Data Protection Board. And she's the author of both GDPR and EU AI Act. It's another one of these just like, I'm bold and stupid enough to reach out and see if they would participate. And she agreed. Unfortunately, she was being sequestered as a committee for some government thing that I don't understand in Europe. But she said, hey, listen, I'd like to Zoom in. And she's doing that with a recording that I'm really happy to present to you, all of you, about the significance of this and her great work in the EU setting a standard. It's a short 4-minute video. Let's go ahead and turn it on.
Good morning. It is an honor to open this confidential computing summit as chair of the European Data Protection Board, the EU's independent authority ensuring data protection rules are applied consistently across Europe. As a Finn, I naturally have a soft spot for the Linux Foundation. The EDPB's role in regulating AI is vital. We ensure AI complies with the General Data Protection Regulation while tackling its unique risks, bias, discrimination, surveillance, and unchecked power. Because AI is not science fiction, it is here, and it is reshaping our economies, our policies, and our rights. If AI is left unchecked, we risk a future where a handful of giants control the tools, the data, and the rules. The EU has not waited for that to happen. Instead, we have built a legal framework that balances innovation with fundamental rights, one that's already setting global standards. This framework comprises, first of all, the AI Act, the world's first comprehensive AI law adopted in 2024. It bans harmful practices, imposes strict rules on high-risk systems, and demands transparency and accountability, all while fostering trust for the innovation. Because AI is only as good as the data it's trained on, the GDPR naturally remains a pillar of the framework. Finally, the Digital Services Act, Digital Markets Act obliges platforms to take responsibility for harmful content and open up to competition, especially smaller players. The Digital Markets Act, DMA, aims to make the digital markets more fair and more contestable and gives users greater choice and control. The Digital Services Act focuses on transparency, accountability, and safety in online services. The DSA requires platforms to minimize the risks of exposing citizens, including children and young people, to illegal and harmful content. The European regulatory enforcement is complex, but so is the technology we regulate. There is, at the moment, a strong push to do away with red tape and cut unnecessary burden for businesses. At the EDBB, we hear this call for simplification and we listen to it. We play our part by clarifying the rules, by explaining the interplay between the different laws, and by supporting compliance. But we draw a firm line when simplification comes at the cost of fundamental rights. Simplification should not be an excuse to dismantle protections that have been carefully put in place. Strong regulation is not the enemy of innovation. It is the foundation of trust in new technologies. And trust is what ensures the success of these technologies. Strong regulation is about stopping a select few players from vacuuming up every byte of data to feed their models, while startups have no fair chance. Strong regulation is about building an AI ecosystem that is competitive, not oligarchic. It is about public services we can trust and control, and it is about rules that work for everyone, not just a powerful few. Thank you.
All right, thank you, Anna. So I'd like to bring up Brittany Kaiser and Nellie Porter to close out the session before we bring up some poster sessions. So come on up, ladies.
What a wonderful 2 days. Thank you so much for having us.
Oh, it's been a pleasure that all of you were here. I am so pleased with how this all turned out, but I'd love to hear from both of you. How about a feature and a bug? You want to do a feature and a bug, Nellie? Highlight, low light, feature and a bug from the last 2 days.
I think the best thing is to see all of you so excited and so determined to make the situation with our privacy, confidentiality, reality. I think seeing all of those presentations and seeing all of those faces, it's unbelievable present to me, being on every single Confidential Compute Summit. So keeping all of this community together and making this significant progress is absolute victory for all of us, and I absolutely salute you. So number one, seeing you, talking to you, and enjoying every moment of that, number one. Number two, seeing how far we go together and what we were able to accomplish, and understanding how many challenges are still ahead of us. So we should not stop, should continue. So learning about all of that and great ideas of everybody, it's number two. And number three, I want to see that those particular forums will continue, and we continue to communicate every single time to challenge each other, learn from each other, and make these things reality.
So I should have introduced one of the really important aspects of Nellie's job, aside from her day job at Google, is that she is the executive chairman of Confidential Computing Consortium, correct? Chairman of the Confidential Computing Consortium. So not only has Nellie been involved with building secure, confidential, verifiable systems for how long, Nellie?
Decade, 10 years.
Yeah, so from the very beginning of this technology, Nellie's been pioneering this at a global scale through her efforts at Google, but then very active in the CCC, and then you took over as chairman of the CCC, was it the beginning of this year, end of last year?
It's last of year, 2 years already. And
Has it been 2 years already?
Yeah, and I was actually one of the founders of Confidential Computing Consortium when we started together with Mark Ruzinovich and Red Hat and other teams, because it was very clear for all of us in the beginning that unless we will come with common voice to influence regulation and standards and everybody around us, confidential compute will not exist. So it was absolute desire for all of us to talk, to understand and promote and convince the world, as I said early, about the things that now world understand how badly they need it.
Well, you didn't give us a bug though, Nelly. You have to give us a bug. Feature and a bug. So what was a low light of the last 2 days? What can we improve?
I think it's too much. 20 minutes, again, every single presentation. We still need to have time to, again, collaborate, to talk, to understand, to process. I think it's all packed together. Next time we need to have 3 days.
Yeah, we should do 3 days next time. Okay, and then more gaps for networking and
a little bit
collaborating
more
and building.
time for networking.
More time to build cool shit together.
Exactly.
Okay, Brittany.
So, oh yeah, I have Mike. So feature, for me as the CEO of a NASDAQ listed company focused on confidential computing, I've never been to a confidential computing summit before. So it was an absolute pleasure for the first time for me to be preaching to the choir. And I know that's not always what you want at conferences, but this is the first time I've ever gotten to do it. Usually I'm on stages all over the world every single day, and I'm preaching to people who have never heard of confidential computing before. They don't know what a fully encrypted workload is. They didn't know privacy-centric AI is possible. And so to be in a room full of people that have been working on this for the majority of their careers, or at least for a long time, and are actually serving clients on a daily basis and implementing this, it was incredibly inspiring, actually. So I think that's definitely the biggest feature for me. And you know, I was going to say something similar on the bug side. I wouldn't call it a bug. It's just that there's so much more room for loads of people to be at this conference that don't know about confidential computing and can really get into it because they're surrounded by so many people that do this for a living. So I would think next year, getting loads more people that want to be here to learn about confidential computing, because most people I talk to today are actively working in the space, which is why I got like really just so incredibly inspired and excited to be here. But next year, it could be bigger, it could be longer, there could be more actual working sessions. I feel like there was a lot of, after I got off stage, lines of people who all wanted to talk about how we can collaborate, how we can do integrations, how we can service clients together. And I think there's a huge opportunity for everyone here to plug into what everyone else is doing, from R&D to actual client service delivery. So there's definitely, we'd love to be involved again next year. We are so honored to be both speakers and sponsors this year, and would love to do it again next year for sure.
Great. I'll give a feature and a bug too. Thank you so much, ladies, for sharing. The speaker lineup was incredible. Like, I've just been blown away by the quality of speaker that we were able to attract. And I'm sure you probably heard me say that Apple doesn't speak at third-party conferences. They only speak at their own conference. For Yvonne to be here speaking and Apple to be promoting Confidential Computing Summit as they did in their press release and on their product page, like, amazing. But yeah, great speakers, great conversations that I've had in the hallways too. And the bug, I would say, is as beautiful as the San Francisco Mint is. And Moran and I picked this venue, so this is totally on us. It's a very beautiful space. By the way, we had like meetings in the vaults downstairs, like for the last 2 days, which was like on brand for the Confidential Computing Summit. Was we're like,
I think it's
no, we've got like vaults. We're gonna have meetings in vaults.
Yeah,
it's so perfect.
Confidential.
Right, hardware enclaves. Like, yeah, they got vaults.
Close the door.
Right,
And done.
but we couldn't close the doors, and the acoustics are freaking awful. So like the breakout rooms, this is the bug. Like I heard from multiple people that it was really hard to hear speakers because the acoustics were really bad, echoing. And then we're doing podcasts downstairs, multiple people doing recordings. The acoustics are really bad. That's my only bug. I would love to do it here again, but we got to come up with some kind of like acoustic curtains or something.
Cryptographic isolation.
Yeah. Like, credit to Moran. Like, I mean, this was, Moran, would you please stand up, actually? Please stand up. Moran, you guys have no idea how much.
Yay!
This, 3, 4 in the morning, she's responding to emails from the Linux Foundation and other speakers, and like this would have never happened if it weren't for Moran running this. I just cannot thank you enough, Moran. And plus, she found the venue, which I do love the venue in spite of the acoustics challenges.
Yeah, it's beautiful.
Okay, wait. I've got another question, but I need my glasses. I know I have them somewhere.
There's a bug. You're always losing your.
Okay. All right. So, are today's AI deployments already creating compliance risks for enterprises and consumers? Where do you think risk is going to? I think the answer to that we all know is
yes.
But where do we think this is the first cracks are going to emerge?
Well, right now I'm seeing, in government, military, and regulated industries, so public companies like ourselves, banking and finance, healthcare and medicine, where compliance is usually number one. A lot of these industries are having trouble implementing AI because they can't get it through compliance. There's data retention issues, there's data breach issues, and therefore they're not able to take advantage of some of the most cutting edge technologies that we have here in America and even from abroad. And so that's a huge shame. And so the opportunity is to scale confidential computing so all organizations and individuals have the ability to safely implement AI in order to improve their daily lives.
Plus one. To add to that, I think it's another interesting movement that we will see, because we're all in cryptography. Post-quantum is going to blow up everything that we do. So it's why, irrespectively if people love or, again, never heard about confidential compute, they absolutely will hear about post-quantum migration, and then confidential compute will be adopted because it's part of their cryptographic capability that you will benefit from. Mm-hmm. So both things will bring to the same result. They need more privacy, more confidentiality, more trust.
So I'm going to ask another question, but I want to prime the audience that there are microphones available to you, and I would like to encourage all of you to start preparing your question and your courage to raise your hand, and I'll direct a microphone to you. And if somebody raised their hand right now, I would forego the question I'm about to ask, but I don't see anybody doing it, so I'll ask the question.
And we have prizes.
Prizes. Guys, I'm telling you, there's not only a Flipper Zero, there's an Anchor power bank, there's some kind of coffee cup, some kind of
hugely valuable thing, whatever it is.
They're like super nerdy prize. Oh, we got a question, David. There you go.
I just stepped out, so I'm not sure where you were, but I did have a question about regulation, and I was curious if you see regulation, like the regulatory agencies, are they looking for signals from consortiums, from confidential computing groups? Are they looking at the big primitives and seeing like who's doing, hyperscale? Like where are they getting their signals? And who do you think's influencing them the most, if it's, a government or like a large agency like that?
So I'm seeing regulators that are, reaching out to us, reaching out to consortiums like the Confidential Computing Consortium and asking for advice. It's only really been over the past year or so where we're starting to see confidential computing and trusted execution environments mentioned in legislation, mentioned by regulators, put into standards by organizations like NIST. This is really, really new and is happening for the first time. And so that is pretty exciting. But the only way that enough regulators and legislators are even going to be informed of this is if everyone in this room actually takes action. I don't know how many people here have actually met with a legislator or regulator before to give technical advice. If you have never done that, please do that. You should be testifying on behalf of or against bills. You should be meeting with people either on the Hill or in your local state Congress. It's really easy to do, doesn't cost you much besides a bit of your time, but that expertise is so valuable because the thing is, these guys are experts in law and politics. They are not experts in technology. So you have to go to them and their teams and brief them about how what you build actually functions so that they understand how to sensibly legislate and regulate around it. And a lot of the best, most technically implementable laws are co-authored with technologists. They're not written by the legislators. They're mostly written by technologists with the help of some lawyers and legislators, and then introduce, and then sensible legislation that is actually functional can get passed.
And no surprise, all of those regulations that coming in the last year were influenced by Confidential Computing Consortium. We specifically have dedicated SIG that talking about standards and regulations, and us presenting the story with one voice instead of talking about different implementation and different capability is helping us to again invite all of those different regulators to understand better and appreciate better what we can offer and educate them how it will fit into their regulation story. So it's never done organically. So your question, it's definitely done by consortiums that care about that and educate, again, our regulators and also companies. So no surprise when needs to anybody issuing some new law or have some ideas about draft, we, all of big companies and even everybody involved to comment on those, again, RFCs, RFK. So we taking it incredibly seriously and providing our feedback, educating everybody that want to learn about privacy, about confidential compute. So it's not by surprise. You see more and more, and I can promise you it will be even more. Again, regulation and legislation done with understanding of basic principles of confidential compute.
Great. By the way, when I was speaking with Anna and her team, some governmental bodies who are less regulatory friendly, largely because they're influenced by companies who have interests to prevent regulations, have had like work visas for executive directors at certain government or like regulatory bodies, like in fact EDPB, is it EDPB? Their executive director's visas was revoked, preventing him from even traveling to the US related to the EU AI Act, actually. I think that for most rational parties, we all understand the risks associated with AI, and thankfully, we have organizations like Anthropic and others that are very concerned about regulating some common sense regulations related to AI. Organizations like Anthropic, I think, really genuinely give me hope, right? As a corporation for the public good, a B Corp, and one that is actively advocating for regulations, it gives me hope that there's a bright future ahead for us. Is there another question from the audience? Oh, great. I should have shut up and let you talk.
Yeah, please do. Thanks for having us here. This has been, I have to say, this has been an awesome conference. Thanks for having you here. I mean, the speakers, I totally agree with you. Today's keynotes were wonderful. Yesterday's keynotes were wonderful as well. So thanks again for putting this on. I know how much work goes into this, and it's really cool that you made it all happen. So thanks. I wanted to talk about regulators, and I'm a member of the Confidential Computing Consortium, and technically what that means is every other Thursday, I click on a Zoom link that comes in my email, and then you get to join guys like Dan Middleton in the Technical Advisory Committee, and we talk about confidential computing, and we kind of just figure out what it is, and then we write it down, and that's what the white papers are, and that's kind of what guides a lot of what we're trying to do here. We also have a SIG that talks specifically to regulators. And just in this last year, we've had NIST join, the ISO has expressed interest. So we're really starting to see an uptick in interest from regulators, and there's an ISO white paper on confidential computing, and when you read it, you can tell it lags like a couple of years behind where the technology is at this conference, but they're picking up the phone, they're calling us, and they're letting us review their papers, and we're getting all kind of in a line on what it all means. So it's just really cool. So I just want to encourage everybody who's interested in helping to shape the technology, look up confidential computing and join the consortium. Click on the Zoom link and join our calls. We'd love to have you.
Do you have to end it with a question? You'd be like, do you agree? Yes, we do.
What's your email address again?
Okay, well, I want to make room for the poster sessions presenters. And Nelly, you've got the poster session presenters. So Brittany, why don't you and I step off and then let Nelly take the mic and invite them up.
Amazing.
We need some interstitial music. Oh, wait, never mind. I'm just joking.
And I have not one, but two. So we have two winners. So the winner number one, it's about standardization. No surprise, it's a very important topic of attested TLS. I think it's fantastic work that we need absolutely to encourage. It's ability for us to have fully attested TLS session when our customers talking to the models or agent talking to the agents or anybody talking to anybody. And this work, I think, is absolutely deserved to be recognized. And the second one that I love so much, it's about our mistakes. So the second work was done by some research group about trusted execution, broken assumptions. And I think it's fantastic work because we celebrate our successes, but there is plenty of work needs to be done to understand that our promises stay as solid as we want them. So both of those winners, please come in. And again, do we have presentation or what is the things? Do we have, by the way, people from those two? Stand up, please. Who are, no, we don't have winners. What is going on? I am so sorry. We will send them. No, Alec, no. Alec, no. No more questions. So no winners with us. They didn't survive so long day, I am sure. It's unfortunately. Sorry.
That's quite all right, Nelly. Those poster sessions people, come on now, poster session people. So,
You have your mic.
yeah, I've got a mic, thank you. So I guess without the poster session presentations, we should wrap it up and just simply thank all of you for your participation. I have a bunch of prizes to give away. I'm not sure, Moran, do you have any creative ideas for how we give away prizes? Yeah, I mean, or we can take more questions from the audience and I can pull up some, okay, great, yeah, all right. Hey, Nelly, you should come back up and field some questions with me. Great, go ahead. We'll bring Nelly up. She'll come back up.
Cool.
She's on her way up.
Hi, Nelly. I don't know if Brittany's still here too, but Brittany had a really cool paper on the Alpha Compute website. And she was talking about the importance of data sovereignty in the era where people that own data and compute are essentially the power makers of the next century. So I was really curious, like a lot of us here today are like here because of enterprise use cases. Like a lot of us like sell or are part of enterprises that sell to other enterprises, like typically B2B. But like a lot of this like core foundational technology with confidential compute, I feel is incredibly important for consumers, and especially with like consumer privacy. So I guess like my question is, it's like, how do you ensure, like how do you incentivize like these companies that are consumer facing to adopt CC and like let go of their data moat? And like fundamentally there's like a monetization play that they want to utilize, but it's like, what is the incentive there to protect consumer privacy?
I'll take a crack at it, Nelly. And then you can add on. I mean, here's my thought is that it takes someone who perceives privacy as a differentiating capability for their products to lead the way. And we just saw one of those leaders. Was it today? I can't even keep track. Was it this morning?
Presentation.
I was like, was it yesterday?
No,
Yeah.
it was today.
Yeah, it was today.
Presentation for companies that absolutely build the whole brand on privacy.
Yeah.
And for them, I think it's very clear how to accomplish that, utilizing all capability, and confidential compute is one of them to accomplish that.
Yeah.
So privacy is differentiation.
And I've had a lot of folks approach me about, oh, well, I want to roll this into this consumer product. And my response has been historically like, great, you should go find somebody to help you do that. Because Opaque's focused on enterprise, because in the enterprise, you have the ability to bear the burden of where the current primitives are, which is, there's a significant lift getting this set up inside the enterprise. And in the enterprise, it's like, okay, well, we know what an enterprise deployment looks like of technology. That's quite different than what does that mean downstream for the consumer? Well, unless there's a demand for it from the consumer, they're unwilling to bear that burden of the initial deployment cost. So thankfully, we have a beacon, a signal coming from a brand that has bet their brand as a differentiating feature on privacy. And now what we can expect will happen is what you just said is like, well, that's going to be a signal to their competitors that it's table stakes that they need to step up as well.
And we will see it. No surprise. We will see it. It will come.
We've got multiple in the back.
Oh my God. Those guys.
And I'm not sure which one you were alluding to there, but we've had Apple talk about what they're doing for consumers. We've had...
Sorry, I should have said Apple. Sorry.
Yeah.
We specifically didn't mention Apple. Then you broke the secret.
I broke the secret. Just like I'm going to break the secret of last year with Meta and WhatsApp with their private processing. So I think we've got a couple really strong examples.
Great point, Meta, yeah.
I also got to speak to DigiCert for the first time today.
Wow.
And answer some of the questions they've had about the consortium. And that's a CA. And when you think about what is attestation, it seems sort of shocking that we don't have CAs directly involved. Can you imagine going to websites now and not just getting the HTTPS certificate, but you get an attestation so that you know that your privacy is enforced in that cloud server?
And it is why attested TLS is becoming so interesting, because TLS is built on certificate on PKI, being web PKI and enterprise PKI. Adding attestation to this channel is ability for us to tie the attestation to all of those CA capabilities. So I'm really glad that DigiCert and other CA will help us to make attestation so easy and so broadly available.
Yeah, I'm intended to meet with DigiCert too, and they of course came up in a conversation.
We can introduce.
So by the way, everybody who's asking questions or making comments must come to the front of the stage at the end of this to receive a gift. And I think Mike has a...
And on attested TLS, just another note, that's something that evolved out of the attestation SIG based on research that came from RATLS, the RATLS protocol that originally came out of Intel, but that got improved by the community, discussed in public, and progressed that way in the open.
Who the hell is this guy? He seems so authoritative.
I think he deserves a prize.
Who are you, by the way?
I'm Dan Middleton.
Oh, okay, Dan. Sure, I know. By the way, if you guys don't, I have face blindness. I'm not joking. I will not recognize you.
I'm a long ways away, especially without glasses on.
No, they're reading glasses. You have to have like a very specific look for me to recognize you.
I'll work on that.
You have a very average look, Dan.
Okay.
Well, I get
Any
to learn
other
from
questions?
everybody at the technical community at the CCC.
I just had a question. I don't know if it dovetails on that or not, but it goes back to the agentic stuff. Like, do you see, or does this exist, that there's an actual like SLA then on like the actual on like agentic SLAs, I guess?
Yeah, so for sure, there's a lot of people who are doing kind of agent credentials or an SLA, as you put it. And I'll mention that as part of agent trust, that's what that agent manifest is the specific rules that govern this agent that gets then cryptographically enforced. And that's all was released as open source. And there's several other options like that. In fact, the Agent Trust, Agent Manifest one that we released is just building on Microsoft AGT open source. And it's, I would have to ask him on which specific, I think it's got an EAT in it, which is another emerging or standard around it. But yes, David, that's like a thing for sure. But it's new, it's like emerging, like this isn't like established. Correct, it's very much emerging. And then Linux Foundation also announced the agent namespace, which presumably would store the specific rules that govern the agent. I haven't read about it, but my assumption would be that even if it's a cryptographic identity, that cryptographic identity would be tied to a specific set of rules for that agent as part of the namespace.
Like, would that be something that would actually be standardized, or is that something that comes into play based on whoever's delivering that SLA?
You are literally like at the time where these standards are emerging. These are all very good questions.
Standards usually take significant amount of time.
Yeah.
So again, and as soon as we agree on the right approach, I think it will become de facto standards, and as soon as we implement it, standards will come.
Yeah, and the interesting part about this too is like all of these, the parts for this exist, right? There's a bunch of the parts that already exist out there, either as open source libraries or standards, and they're beginning to converge into a coherent story, but we're not quite there yet. Great question.
Mike.
I think you know I've got an accent and a look. First of all, I want to say thanks to Aaron and the team at Opaque and to Linux Foundation events and all the AV stuff.
Linux Foundation events.
Yay! A great job. And a couple of people have said to me, you know, where are we with CC? And as of this year, it's felt a bit different. It's felt that we've moved maybe away from talking to ourselves and talking to it's actually happening, which is just fantastic. And the question I've got really is, how can we let people know about the people that are using it? Because lots of people use CC, right? Apart from telling Nelly she has to publish all of her customers, which isn't going to happen. You know, how do we let other people know? Because that's what we need. We need to have people to know that other people are using it, and that will make all the difference. Any have any bright ideas? Aaron's run away with that question. Okay, that's fair enough. Nelly, what do you think?
The goal, I guess, to not publish the list of customers. None of the companies would be happy to do that. But the goal to maybe identify the most impactful use cases that those customers will be interested to talk about. So, for example, in Google, we have multiple case studies that we're publishing with customers that really okay for us to disclose the conversations and the usage of confidential compute as it's applicable to their business. So I think this is the way how we would be able to identify those customers. Is it willing to blog about that, willing to publish their case study, willing to share their experiences with everybody and with companies from their segment, from their industry as well. So it's the path.
Yeah, so Opaque brought a lot of customers here. So there's a lot of Opaque customers running around. I don't want to ever make it about Opaque since this is an ecosystem event. So we do bring customers. There were customers who spoke, Encore Capital being one of them. But notice, like, we don't encourage them to put Opaque all over their slides. We try to keep it more agnostic about the technology. I think that serves the Opaque and the broader ecosystem well. Thank you so much. But so you saw many Opaque customers on stage, and many of them you wouldn't have even known that they were Opaque customers because it's about us having a rising tide that secures the future for our children to have safe use of AI. But yeah, I mean, every single year there's been more and more customers of confidential systems on stage and talking about it. It's like you said, it's happening, it's happening. You know, I've only been grinding at this for, by the way, I have temporal distortion, like I do not perceive time very well, probably because like most of you out there, you just work a lot and you kind of lose track of time. So I think I've been at Opaque for 2.5 years now, October 2023, so about 2.5 years, I think. So I've only been granted to this for 2.5 years. You all have been at this for like a decade. I mean, thank you very much because you put in the foundation for our future to be secure. So just in the last 2.5 years, it's been tremendous seeing major milestones occur. Like, gosh, before I joined Opaque, I was like, hey, this is like cool on analytics and ML, but guys, how do we do this on language models? And they're like, oh, hey, there's going to be these new GPUs. And I was like, oh, that makes sense. And we can do this attestation stuff on what I thought were, I was like, there's going to be these services that are going to call other resources and tools. Now we call it agents, right? Before I even joined Opaque, I'm like, guys, there's going to be services that are really just language models that are going to call different data sources and tools. And we're going to need this graph level attestation to enforce governance. Now we're there. But there was all these major milestones beginning with like, oh, there's going to be confidential GPUs. Oh, they're available on the cloud. That was only September of 2024 that we even could have access to confidential GPUs on Azure and GCP. Then what were the other major milestones? Like off Apple Private Cloud Compute, their initial announcement was 2025. And then what was the next major milestone? OpenClaw. That was a big deal, everyone. When people are like, oh my God, this thing just hemorrhages data and you can't govern them. Like, oh, we have to do some kind of cryptographic enforcement. What was the next major milestone? I would say NVIDIA GTC with Jensen and his entire leadership team in every session talking about verifiable systems. Well, clearly they were talking about Nelly's work with Apple. And he understood the significance and importance of that, but it was all over April GTC. And since then, in fact, Mythos was another major milestone where everybody woke up and said, oh my God, we've got to have these systems that are verifiable and confidential. And then I would argue that the next major milestone that was okay, we're there. We have escape velocity. We now are out of orbit. We have escape velocity, and that was Apple running the world's largest confidential AI across 2 billion devices. There's no longer a question of, is this a thing? It's obviously, this is where we have escape velocity. In fact, on June 8th, I had this moment. I walked out of my office in San Diego and I went for a walk and I was like, all right, we did it. We're there.
Congratulations to all of us.
To all of you. I'm a latecomer.
We did it.
Well, I guess unless there's, oh gosh, I'm sorry, Apostolos.
All right.
Where do you come from? What is your country of origin?
Greece. So
this is the
yeah,
third
this
time I've
joke
given
never
him a
gets
hard
old,
time
right?
about his name.
So
you're from Greece?
No way. So I wanted to see this from the perspective of us on the hardware side of things, right? So we build all these confidential computing features in our products, and we're very happy to finally see them taking shape and being adopted by the industry. And I've been attending this. This is the third time I've been on a confidential computing summit. By the way, congratulations to Opaque and the Linux Foundation, because every year it gets better. And yeah, Nelly.
And Nelly.
Absolutely. So the question is agentic AI and the necessity for post-quantum cryptography really going to be the inflection point where we see exponential adoption of confidential computing? And what can we do, the hardware guys, to accelerate this trend even more? Like, is this the time we've been dreaming every year? Like, yeah, it's going to happen. We're getting there. Are we there yet?
When you're on the curve, it's hard to see the exponential, but I won't name names of partners who've told me that they have vertical growth because it would be inappropriate for me. But every partner that would know, they have vertical growth. It's exponential on this.
And can I have my hardware wish? We need more of that. We're struggling with, again, capacity. Bring more hardware to us because demand is growing exponentially, especially again CPU, GPU, and all other accelerators. As more we will have ability to bring it to the world globally without any performance and latency implication, we will be golden. We have demand. We have huge demand. We need capacity.
And you heard Mark talk about it yesterday, where he said one of the friction points for confidential is access to the hardware. And you heard also folks from UAE, like Naja was talking about some of the challenges she has, friction related to the hardware. By the way, we had folks from Kazakhstan here too. Similarly, they're like, hey, well, we need access to the hardware. So.
Thank you so much. And we need more of that.
Cool. Great. Is there anybody else who'd like to participate in the conversation? It doesn't necessarily need to be a question. You have to end it with, do you agree? All right. Well, thank you all. Oh, okay.
One more.
So we've heard several different messages that all kind of equate to this is our year. So we'll start with the assumption that that's true. This is our year, it's happening. You've mentioned the exponential curve, and it's hard to see it when we're on it. But we've also talked about things that could be like step functions, whether it's regulations arriving or moments of market demand through differentiated features, like with what we saw from Apple and that kind of growth, or whether it be a big data breach that leads to people being worried about legal liability. Like, what will be driving that step to make this ubiquitous? Like, what will be the thing that pushes us over the top?
I've got some opinions on it. Go. I think we've already seen several of them this year, right? I listed some of them, right? Like personal agents, people recognizing what happens with personal agents. When you have a company that's putting, I don't know, $500 billion behind their product roadmap, that they're pushing on, like NVIDIA, it's a pretty clear signal to the market. They're educating the market. They're also reacting to the demand from the market. And then, of course, when you've got one of, or perhaps the largest consumer electronics company on the planet who's fully adopted this, I mean, what more evidence do you need to see that's going to drive the adoption? Yeah, I mean, I think
all of the above is your answer.
Yeah, I mean, like, I don't know that there.
It's all of the above.
It's all of the above. I mean, here's another thing I think we were talking about earlier today, which was when I first came to this space, my beginning of my career was around distributed systems at Microsoft, and we were applying PyCalculus. So it was all about verifiable systems. I was like, oh, this is going to be amazing. We could use like hardware to create closure of compute and verifiable systems. And then very quickly I realized that the customers didn't really care about that. They were like, oh, well, look, I could just have like a confidential core around some of the key workflows running in CPUs. And then as long as I can get like policy enforcement that's provable there that I can share downstream with my internal auditors or my downstream customers, that's good enough, right? I was like, great, because that confidential GPU is such a pain in the ass, and I can't get them half the time. And you know, my cloud vendors only support like a single GPU. So what are we going to do with that? So I was like, that's great. We can just do confidential core. Since then, I've begun to see them saying, well, look, I want to connect some of these resources that you're attesting the communication channel, and I would like to get mutual attestation back from that resource. And now we've got some of the world's largest tech companies saying, we're going to do that with you. So when I first started here, I was like, I told the team, I said, hey, there's going to be a point. We're going to start with this, but at some point in the future, there's going to be hyperscalers who are going to do mutual attestation with us and allow us to aggregate that up for our customers. And I'll tell you that they, on my team, were skeptical, and now we're actually seeing that. The other thing that I said was, hey, you're going to see a proliferation of like people using small language models that are going to be specialized, and they're going to want to run that in their own TEEs, and we'll be able to do it because it's just like a small language model. Maybe we can do it on the CPU, maybe we can do it with the GPU. We're now starting to see that too. So I think that I'll go back to what I said before, which is it's hard to see the exponential when you're on the curve, but we're already there. Like June 8th was the final point of evidence for me where I was like, all right, cool, we did it.
And good to know I have a look since you were able to connect to our conversation earlier.
Actually, I'm really good with voices, true story.